feel of this view. What do you call that? This view.
pledge for creation's soul. Far above all earthly gold, a pledge for creation's soul. tread these waters, make our waves, yes we do. Peaceful shall proceed in every single way. Come, let's bring light to the night of day. There comes a time and some will know, the time when true bonds really show. Can you depend on friends to help when you're in need? If they got problems of their own.
Hey everybody, how's it going? Yeah. So I'm very excited to announce something that actually isn't in the slides, but for the first time we're actually live streaming this with live captioning. So everything we say is actually being transcribed by somebody in Denver and going into the YouTube live stream. So even if you're not able to experience all of the live stream, you'll still be able to read the captions. This is very expensive. And very difficult to set up, and it required about 8 people working this morning. So I just wanted to say thank you to all of you who are doing this job, because now we actually have live captions on every single track broadcasting live. So super happy about that. Speaking of that, accessibility, just a few notes. Guide dogs, please leave them alone. Don't block the doors. There's an elevator back there for your use. Please feel free to take advantage of it. We are paying an elevator operator to operate it the entire day, and I'd be very disappointed if nobody used it. And also live captioning, like I just mentioned. Code of conduct, we're using confcodeofconduct.com. We basically have a zero tolerance for harassment. We'll just kick you out and not give you a refund. And if anybody has any complaints, come talk to me or to Tracy, who is in the registration area, who helped check everybody in. She'll realistically be the one kicking you out. Let me talk a little bit about some awesome stuff that we have on the schedule today. We've got a real-time apps panel that's going to be on this stage after the first break. There's a serverless application architecture fireside chat that's going to be on this stage right after the real-time panel. The web meets the virtual and holographic worlds by Max Furtman, maybe the longest and most buzzwordy title of any talk today, but I'm also really looking forward to it. That'll also be here, followed by the animation panel, a presentation by Estelle on inclusive code, a panel on building better browsers. That's actually going to be a really, really jam-packed panel. React Application Architecture is going to be our last session panel, followed by, well, actually there is one more panel before the after party that I forgot to put on here, but there's a closing plenary panel that's going to be moderated by Brian Lonsdorf. The after party is actually on site here, so you won't need to wander out to another bar like we've previously done. Just go downstairs. There's actually a great nonprofit that we're working with called Queens of the Castro. It's a bunch of local San Francisco teachers who dress up in drag to raise money for queer youth scholarships. And it's a legit charity. They're 501c3. And so what we've done is we've given them a bunch of drink tickets. We encourage you to pay them some money for a drink ticket. I think it's like $4 or $5 or something like that. Everything that you pay goes to their nonprofit for local scholarships. Finally, how many of you were here 6 months ago for the last Forward? A few of you. Do you remember the stroopwafel debacle? We ordered these stroopwafels, which are these tasty treats from the Netherlands. And we promised everybody, we were like, there's gonna be stroopwafels, you guys. Like, you don't even know how great this is. It's gonna be amazing. We put on the break, like stroopwafel break, and then there was a shipping problem and they didn't get here in time. And I got up and I said, I'm sorry, there's no stroopwafels. And I was booed. I was roundly booed because there were no stroopwafels. But I have good news. Today, we have stroopwafels. Thank you. Thank you. Even if you learn nothing about JavaScript today, you can go home and say, I had some tasty pastries. And so to demonstrate how to eat a stroopwafel, we have an actual Dutch gentleman who we flew, I'm serious about this, who we flew in from the Netherlands.
Goedemorgen allemaal. Hey, thanks. Good morning. Yeah, I'm Mikey. Actually, I'll just keep using this one. From Lupercur. Oh, it's not going to work.
No, mine is too fancy.
Oh. Itchy mine. Here, that's good. Or is it on this side?
Smooth.
Goedemorgen. I'm Mikey from Amsterdam. And today we finally have gotten over Strooppocalypse from last time. We have actual, what you guys call stroopwafels, what we actually call stroopwafels, here today for our first break. And I'd just like to show you how to eat one of these bad boys. You're going to start with an extremely hot cup of coffee. You are going to take a stroopwafel. I'll just use this one. You hold it over the coffee. Now, if the cup is bigger than the stroopwafel, don't let go. You wait. And you wait. And after about 2 minutes, your stroopwafel will start getting goopy and syrupy, and it's really what we say in Holland, lekker. So please do enjoy the stroopwafels. I think that's at 10:30. And now, just really quick to plug Lupercur, a little bit about what we do. We are a small, friendly, multinational conglomerate. But we have an outpost in Amsterdam. We have a team working here and a team in North Carolina. And by team, I mean small groups. And we work on lots of incredible things. In our 5 years of existence, we've managed to work with some pretty big clients, including Netgear, Disney, GameStop, Denso, Ipsos, Salesforce, Mod, and Planned Parenthood. We believe in clean code and clean design. So yeah, we specialize in Clojure and Rails in the back end, React on the front end, and we also do Swift iOS apps. Just a quick, the kinds of things we're working on. So right now we're working with Mod, which is a space in Phoenix, and there's a new one here in the Mission called the Archery. And this is a whole suite of back-end apps for people. Front end, we did a watch app featured in Bloomberg. We're pretty psyched about that. Also working with Planned Parenthood to do a sort of textbook and education app for their Get Real program, which is realistic sex education. So we're happy to do the kinds of projects that we believe in. And of course, one of our favorite projects is this one here, Forward. That's Dave in the background, covering his face. So we've been with Forward since the beginning, and we're really happy to meet so many of you great people and do so much good work. So that's about it. We are actually right now looking for client bases. So if you guys hear of any work, come on down, say hello. And also, it's always nice to meet new devs. So we'll be downstairs, and we'll see you at the stroopwafel break. Thanks so much.
Awesome, thank you. Sweet. Forward.js is the hashtag today. If you tweet something that Tracy likes, Tracy is the arbiter of good taste in this building, then she will give you some tasty treats that are going to be really awful for your blood sugar level. Let's talk about numbers. So we had Forward Swift yesterday. We've got Forward.js today. We had 8 days of different workshops that I hope some of you attended. How many of you attended a workshop in addition to being here? Oh, nice, nice, sweet. So 1,300 of you all told, 55 presenters, 38 different workshops, $12,000 worth of coffee. You guys have expensive tastes in coffee. I hope you know that. And also we were able to give out discounts of $26,000 off the list price tickets in scholarships to students and the unemployed and underrepresented groups in tech. That's based on your ticket sales. You're the ones that funded these scholarships, so please give yourselves a round of applause. Thank you very much for your support. We literally could not do this without you. We already talked about Loop Recur. Now I'd like to introduce somebody who's actually presented at each of the previous Forwards, the previous 4 Forward conferences, and been a huge supporter of ours. She works at Mozilla, and she's going to introduce our keynote speaker today. So please, a warm welcome for Diane Tate.
So are you ready for the Stroopwafels? Yeah. So one of the things that really motivates me to help out with this conference, as Dave mentioned, I think I've participated in this 4 times. Dave's nodding. Is it's all about JavaScript and the open web, which we care deeply about at Mozilla, and it's very people-centric. Mozilla, we care about technology, we care about products, but we care about people. And code is nothing if you don't pay attention to the people behind it. So that's why I'm super excited to introduce you to the keynote this morning, Jenna Zeigen. Jenna basically embodies the whole idea of the tight interdependence between our humanity and the code that we write. In college, her thesis, well, she studied cognitive science, so I can't think of a better depiction of the marriage between human and code or human and science than that. Her thesis was called What's So Funny? Investigating the time course of lexical access in the processing of puns. Pretty human, pretty scientific. Basically, her life, as I understood it and researched her and exchanged a few notes with her, I really discovered that her life is a fusion of code and brain, or code and humanity, and how they interrelate. She's described herself as someone who's known to write about poetry and programming. To me, that sums it up. And certainly today at DigitalOcean, she's really concerned about the human elements and making sure that her team is supported in human ways so that they can code and write great products and write great technology. So to sum it up, I'm going to actually describe her as she describes herself. One morning, and by the way, this might spark some memories of literature. One morning, Jenna awoke to find that she had transformed into a programmer. She's been pretty psyched about coding ever since. She's currently swimming with JavaScript at DigitalOcean as the engineering manager for the community and creative engineering team. When she's not teaching pixels to party or helping keep engineers happy, Jenna enjoys climbing, coffee, and cat gifs. Or is it GIFs? Her best party trick is that she wrote the most serious academic paper of her life on puns. So I can't think of a more perfect person to talk about how our brain is conspiring against making good software than Jenna Zeigen. So please welcome her.
All right, thanks for that lovely introduction. So yeah, welcome to my talk. So as you just learned, I'm an engineering manager at DigitalOcean. And you might also know me as Zeigenvector on the internet, so feel free to tweet at me if you please. I'm also an organizer of a JavaScript conference in New York called Empire.js. So I know exactly how much goes into making a conference work. There's so much stuff you don't know about this. So let's give them a round of applause for making this happen that you're all hearing now. All right, so as you were just told in my introduction, before I was a JavaScript engineer, even before I was an engineering manager, I studied cognitive science in school. And while cognitive science is a study of how we think, we make decisions, and as I really dove into how we process language and speak and understand language, if you were to ask me to sum up what I learned in those 4 years of college in one concise sentence, it would be that humans are predictably irrational. And this predictably irrational phrase was coined by the psychologist Dan Ariely, and you may have read a book by him of that title. But what does this mean? What does it mean that we are predictably irrational? It means that we employ predictable tricks, patterns, and shortcuts that allow us to make more efficient decisions, to have what we cognitive scientists call cognitive economy. But this fast, efficient thinking also often causes us to deviate from rationality in our judgments. We're not always thinking exactly the best that we could be thinking. And so it even causes us to make severe and systematic errors, as two very eminent scientists in the field of judgment and decision making, Amos Tversky and Daniel Kahneman, said. And these errors are called cognitive biases. So I'm going to be talking about these cognitive biases as well as some other ways that we're not great at thinking and how this affects us making good software. So if you've never really heard before that we're not the best rational thinkers or decision makers, this might cause you to be sad, shocked, embarrassed, confused, or even like skeptical. Like, no, I'm a programmer. I'm so great at thinking. But no, you're a human too. And when I learned this, even though like I had 4 years to digest all of this information, it still makes me sad. I want to be really rational. I want to be able to think clearly and make awesome decisions all the time. But I also started thinking, how does this make me, like, how does this affect me as a programmer, and how is it affecting my team? Because my job as an engineering manager is to make sure that my team is happy, learning, getting along well together, getting their work done. And it's also my job as an engineering manager to grow and build the best team that I could possibly build. So I started thinking, like, how does all the stuff that I learned in school that I thought I was never going to use again because it has nothing to do with programming, how is this affecting my team? And how is it even affecting me as a programmer as I'm sitting there trying to write software? So I came up with some things, which are these things. So these are some of the ways I think that our cognitive biases and the other ways that our mushy brains are not working so well and is affecting our making good software, all the way from actually writing code through interacting with the teams that we are writing that code with. So, starting from the basics of programming, I think that one of the fundamental underpinnings of programming is logic, right? There's like if statements and else statements and booleans and ternaries. But computers can only do what we tell them to do. And it turns out that humans are not very good logical thinkers. So one of the tools that psychologists use to test this is a categorical syllogism. And this is one of them. So a categorical syllogism is a logical argument beginning with two premises and ending with a conclusion. So I'll give you all a sec to think about if you think this is true. All right, so when this experiment was run back in 1959, 81% of people said, yep, the conclusion follows from the premises. But that's not right. 10% of people said something else is wrong, and only 9% of people got this right. And just like any other shocking psychological result, this was run a few more times, and it was found that between 70 and 90 people were unable to do this properly. And in fact, if a syllogism's conclusion is something that people think is true outside of the world of that syllogism, they're more likely to say that it follows logically from the premises. This is called the belief bias, that what we believe to be true influences our ability to think logically through something, even if that conclusion doesn't necessarily follow logically from the premises. And it doesn't really get much better when we start thinking about complex if-then statements. So to test this, someone ran this experiment called the Wason 4-card task. So in this case, each card has a letter and number. So a letter on one side and a number on the other side. And the participants were asked to evaluate the following rule. If a card has a vowel on one side, it has an even number on the other. And then they asked participants what cards need to be flipped over to check that this rule checks out. So I'll give you a sec to formulate your own opinion. So only 4% of participants got the right answer, which is to flip the A and the 7. If you're stumped about why this is right, just a hint is remember that the rule says nothing about what consonants have to be paired with, only what vowels and odd numbers have to be paired with, or even numbers, sorry. So I started wondering, what does this ability for us to not really be able to formulate rules to test logic, what does this say about how we can test our code properly, or when we're debugging? Probably not that great. But luckily, there is some hope that once we start trying to reason about concrete examples, we get a lot better at it. So some other scientists modified the Wasted 4-card task and decided to have their subjects instead test a more concrete rule, such as if a person is drinking beer, they must be over 19 years of age. And in this case, 73% of people got the answer right. So that's a big bump. It's not perfect. It's still a little like, but much better than the like single-digit percentage from the more abstract one. So if we're not writing perfectly logical code, we're bound to have some bugs. But debugging is hard. Even Brian Kernighan thinks so, because he says that debugging is twice as hard as writing the program in the first place. So why is debugging so hard? I think there's some cognitive science that goes to answer that question. One of the things, I think, is the confirmation bias, that we have this tendency to search for, interpret, favor, and even remember information that confirms our pre-existing beliefs and hypotheses, while giving disproportionately less consideration to things that go against our previous beliefs, and we're giving less consideration to alternative possibilities. So to test this, Wasson again presented some subjects with a series, such as this one, 246, and we're told that the trio conformed to a specific rule, and their job was to figure out what that rule was by asking if other trios conformed to the rule. The rule in this case was actually pretty simple, just that the numbers had to be in ascending order. But people had trouble, especially those that would just ask confirming questions and not disconfirming questions. So those people who asked disconfirming questions performed a lot better on this task. So if you were to get set on the rule, such as that the numbers had to just go up by 2, you would start asking things like, oh, does 6, 8, 10 confirm, does that rule work? And then be like, yeah, that works. So if you could keep going down that path and keep digging yourself deeper and deeper, but if you thought to say, I'm going to test something that goes against the rule that I thought, just to see, and you were to ask 1 to 1 million, you would realize that that also is part of the rule, and you would get a much better picture of what the rule actually is. So we tend to scrutinize disconfirming evidence too, and we try to find flaws and ambiguities in the disconfirming evidence. So I think this is part of that like denial phase when you're debugging, right? Like, oh, it totally wasn't my code, right? Like, I wrote good code, must be a bug in the library, or at least it's someone else's code. So as that evidence piles up, it takes a lot of evidence to be like, oh yeah, maybe actually it was me. And it's really hard, and it's even harder for emotionally charged issues, such as when your code is wrong. For me, like, writing code is a bit emotional, and like, take it a little bit personally. It's not the best, but when I have a bug, it's kind of like, hurts a little bit. I don't want my code to be wrong. So another thing that I think gets in the way of us debugging, making debugging easy, is the fact that we tend to be rigid in how we approach a problem. And this rigidity is called Einstellung. I'm not a German speaker, so I hope I pronounced that properly, and that word means attitude. So if we wrote the code, we're going to be pretty rigid in our ways of thinking through the problem, and it's going to be harder to think outside the box and squash the bug, especially if the bug was on a more conceptual level. If it's just like a typo or a syntax error, it might be easier to find if it was just like you just thought about the problem in the wrong way. But even I know that, like, I will admit I often substitute a single equal sign for a triple equal sign, and that's even sometimes hard to find, right? So like even easy bugs are hard to debug. So if the bug is about how the way you approach the problem, it's going to be even harder. In fact, we sometimes block problem solutions based on our past experiences, and this is called fixation. So so this is. It's hard to see a problem from a fresh perspective. So this is why I think it's good to pair on squashing bugs. There's also an element of frustration that goes into this. Scientists found that we often have no idea when we're going to solve a problem or if we're even close, even 30 seconds before we crack it. So to test this, scientists gave subjects insight problems. So kind of like word problem, brain teasers, those types of problems where you get that like, eureka, I solved it moment. And the scientists asked their subjects to rate their progress in terms of warmth on a scale from 1 to 10. And initially, subjects were giving ratings of 1 to 2, and then suddenly their rating spiked up to a 9 or 10 when they got the answer, whether or not it was right or wrong. So I know often for me, debugging kind of feels like that. It feels hopeless until the moment when you find the bug and figure it out. And I know that kind of like the frustration kind of makes you feel sad, and then the sadness is this feedback loop that makes you less creative. And I think breaks often contribute to being able to fix a bug. And some scientists think that breaks are important for solving any creative problem. And some scientists think that this is because it helps you forget misleading hints. To test this, psychologists gave participants some puzzles to solve, as well as some misleading hints that led them down the wrong path away from the solution. So a control group had a minute without breaks, and the experimental group had 30 seconds of time, and then were interrupted for a brief amount of time, and then had another 30 seconds. The interrupted group it was found that they had better performance, and it also found that they remembered the misleading hints, or did not remember the misleading hints. So I know for me, when I'm trying to debug something, I'm like zeroed in trying to fix that bug because like there's something wrong with my code, I have to fix it. But taking a break is important, but our brains are often so fixated on trying to solve the problem that we often forget to take breaks. Also, creativity is often, kind of feels like creativity is involved in finding a bug and solving the bug sometimes. And creativity is involved in, I think, any coding. And cognitive science has not that much to say on what creativity is, because it's kind of this wishy-washy zone. But cognitive scientists kind of believe it's nothing special, that it's just the sum of all your experiences, memories, time, training, motivation, and they all come together in the right way. And some scientists also think that it's just really efficient associative memory, just being able to pull from past experiences and apply them to the problem at hand. So I also think that this fixation on a problem also affects us when we're trying to read other people's code. It's like, I know for me, it's a lot harder to read someone else's code and understand what they're talking about, as opposed to when I'm going back and reading my own code, which is also sometimes hard. So I think this is also due to the fact that we tend to think about problems in a fixed way. When you're reading someone else's code, you're probably trying to go along with the actual semantic content of their code, not just making sure they don't have syntax errors. So you're kind of stepping into their shoes to try and think through it with them. But that's hard because they may have gone about the problem a totally different way than you did. And again, we tend to have a set way of solving things that we tend to choose over and over again. But there's also a different side of other people's code, which is using other people's code. Y'all might have heard the not invented here syndrome phrase, which is that we tend to not use other people's libraries because I could just write it myself, right? Why would I use someone else's code? There is a cognitive science effect that I think kind of speaks to this a bit. So some scientists, including Dan Ariely, the predictably irrational writer, asked some participants to assemble IKEA furniture, build Lego contraptions, and fold origami. And then they were asked how much money they would be willing to pay for their creations, as well as experts' creations. And participants were willing to pay about the same amount of money for their own dilapidated things that they were willing to pay for experts. Like imagine when you try to fold an origami crane the first time, it doesn't really work, but the experts' ones are beautiful, like you would value your own dilapidated origami crane the same way that you would value an expert's. And while this effect, which is called the IKEA effect, it's a fairly recent experiment, while it's about money, I think that this does, you can kind of extrapolate from this to why we might not use other people's libraries, because we give our own library the same value as we do for the expert ones, the open source ones that have been polished by a lot more people's use and by pull requests and were written by people who might, in fact, know their stuff a little more than you do. So now that we are dealing with other people's code and libraries and, working with other people, we might want to start planning our work, right? So yeah, as an engineering manager, sprint planning is part of my job. And I have found that I often, after a year, still not that good at it. So I take some comfort in the fact that this is cognitive bias, that we have something called the planning fallacy, which is that we're really bad at making predictions about how much time it's going to take us to do something. This was coined by Tversky and Kahneman, again. So in an experiment that wasn't theirs, scientists found, they asked 37 psych students how long they thought it was going to take them to finish their senior thesis. And the average estimate was 33.9 days, while the actual average time it took people to finish their theses was 55.5 days. So that's a lot more time. And only about 30% of people finished in the amount of time that they predicted. So this phenomenon occurs regardless of if the people who are giving an estimate know that previous similar tasks took them a lot longer than they expected. And this also only happens for our own tasks or tasks that we're involved in. In fact, for taking guesses on estimates for how long it's going to take other people to do things, we show a pessimistic bias. We think it's going to take them longer than it actually does. And this is part of a larger bias called the optimism bias. So we think that bad things are more likely to happen to other people than they are to us. So this is seen in a wide array of situations, not just planning our work. So people tend to think that they're less susceptible to stock market capriciousness, or that they're less susceptible to crime. And smokers also often think that they are less susceptible to cancer or other smoking-related illnesses than other smokers. So yeah, we just think that we're kind of more resilient. Bad things are less likely to happen to us. And this does occur more often for negative things not happening to us versus positive things happening to us. But it is seen in both cases, but the negative one is stronger. So now that we are planning our work, probably you have to go back to your desk and do the work. And if your offices are anything like mine, if you're actually working in an office, there are no walls. The person next to you might be having a conversation with the other person next to you, or they might be on the same Google Hangout, even though they're sitting at a desk right next to the same person on the Google Hangout. So it might be pretty noisy. The air conditioning might be on too high. Light might be in your face, but we're actually pretty good at paying attention to what we're supposed to be paying attention to. Even the things that get past our filter, that's only a small amount of things that are going on around us. And this is called selective attention. And as I said, we're pretty good at it. And this was figured out by some scientists doing something called the dichotic listening task with shadowing. So this is a artist's rendition of what it looks like. So the subject has one stream of sound going in one ear and another stream of sound going in the other ear, and they're supposed to repeat back what's going on in one ear, so it's usually speech that they're repeating back. They're supposed to ignore what's going on in the other ear. And then afterwards, they are asked what they remember going on in the unattended channel, or the ear they're not supposed to be paying attention to. And generally found that there's little memory of any semantic content. So there's they don't remember what was said to them. In fact, a switch from English to German goes unnoticed. So yeah, very little is is bubbling up to your consciousness. But we're not totally oblivious to what's going on in that unattended ear. So physical attributes of the sound are remembered. People are generally able to recall if the unattended channel was speech or not. But if there's something salient that happens in the ear, so if their name is said into the ear they're not supposed to be paying attention to, or some not safe for work words, people generally notice them. And this is what scientists call a cocktail party effect. So if you're at a party, you're paying attention to a different conversation, and then someone says your name, you're going to notice it. So scientists think that this is because selective attention requires both ignoring and paying attention. So you have to ignore everything else that's going on. There's some amount of processing going on. We're processing enough so that we know if there's something important for us to suddenly turn our head and pay attention to. So there has to be some amount of processing, but they think that we're like suppressing that information, so we can just go on with what we deem to be important. So, but what about when you hear something that piques your interest? We can only pay attention to so many things at once, mostly one thing. We have a limited supply of mental resources, and we don't have the budget to do more than one thing. And just, you can walk and chew gum or something, but it's probably going to be hard to read something and hold a conversation with someone. So you're unlikely to be able to keep writing that difficult taxing algorithm if you're also trying to listen to the conversation that's happening 10 feet away about if the product you're working on the algorithm for is going to get scrapped or not. So we are sometimes helpless to the processing power of our brain. So we do things automatically. All of these cognitive biases are a result of us thinking automatically. It's kind of not really giving very much thought to what we're doing. And so if you had an email account in the 90s or early 2000s, you might have seen this. This is actual science. It's called the Stroop task. And the idea is that you're supposed to say the color ink it's written in, or what the color of the pixels are, not the word itself. So that first word, you're supposed to say red, not blue. And the leading theory as to why this is so hard, it's generally hard, is automaticity. That reading is an automatic, habitual process that we don't need to pay much attention to. But recognizing a color is not an automatic process. We actually have to devote resources to it. So, well, automaticity doesn't mean there's no processing. Reading doesn't require controlled attention, it uses enough resources to reduce the amount of resources dedicated to color processes. So that's why it's so hard to say what the color is. So if there was just a red splotch, it would be easy for us to say that's red. But the fact that blue is there and it's automatic, we have to kind of say, nope, not blue. It's red. So we work in offices because we are working with other people and making software for other people. And this is something, when I heard it, software is about people. It's a phrase by awesome people at And Yet. It kind of changed the way that I think about software. That software isn't just the code that we're writing. It's not just the programming. It's not sitting in a room writing code. Software is about people. It's about you, it's about the people you're working with, and it's about your users. If your users can't use your software, I guess there's some point to writing it for the mental exercise, but there's no point making it good. So if we're not growing as programmers, if we're not getting better, if we're not working with teams, we're not going to be making the best software that we could. And if we don't think we're good programmers, we're not going to make good software. And you're not going to make good software if you don't realize how much more you have to learn. So this is the Dunning-Kruger effect. that relatively unskilled people think that they are better at tasks than they actually are. And this was, as the emojis are going to say, it's inspired by the case of a dude who robbed 2 banks after covering his face with lemon juice. Since lemon juice can be used as invisible ink, he thought it would cause his face to be invisible on the security cameras and they would never catch him. Oops. And this is kind of a smaller subsection of the fact that we tend to overestimate our own skills and abilities. This is a cognitive bias called illusory superiority. And it's evident in areas such as intelligence, performance on tasks and tests, and thinking that we have desirable characteristics or traits. An example of this was in a survey of faculty at the University of Nebraska. 68% of people rated themselves in the top 25% for teaching ability. And more than 90% of people rated themselves as above average. It doesn't mean that they were all bad teachers, but 50% of them were below average. This is not meant to demoralize you. No, it sounds a little grim. This means that we all have a lot more to learn than we think we do. We have a lot more ways to make our software better than we might realize at first glance. There's also a corollary here, which is that skilled people tend to underestimate their abilities and think that tasks that are easy for them are easy for others. So if you've been doing this for a while, if you're in that senior engineer camp, you might forget what it's like to be a beginner. And this is gonna make people who are working with you, who know less than you do, feel not that great. If you're like, oh, all you have to do is that, it's just that, it's easy, it's simple. Not gonna be fun for those people who didn't know that before you told them. So that's not great. Another not great thing that this can manifest as is imposter syndrome. You know, this is a term that's been getting a little more traction in the programming community. And imposter syndrome is when people think that their achievements are not the result of, that they don't deserve their achievements, that they got them through luck, timing, and deception. And some studies suggest that this is particularly common among high-achieving women, but I think I've seen it apply across the board to even some of the best programmers that I know. Like, can be seen as humility, but it's also crippling. Like, if you don't think that what you have to say is worth it because you think that you got to the position that you're in because you pulled the wool over someone's eyes, you're not going to be making the best software. The people around you aren't going to benefit from your knowledge. So, you're all great programmers. So, the last thing I have to talk about is assembling a team. And most software I make that sees the light of day, I've made with a team. And diversity is a hot topic these days, and I think it's worth talking about. So, like, why is diversity so hard, right? Why is it so hard to assemble a diverse team and the best team that you could possibly make? And I think one of the reasons is that we favor members of our own in-group. This is like a scientific cognitive science thing. And so I think this relates to the referral policies that a lot of companies have. So if we're going to be referring people from our own social circles, and our social circles look like us because those are the kind of people that we prefer, we're not going to get, everyone's just going to look like you, and I don't think that's the best team you could make. And we also prefer the status quo, something called the status quo bias. That people will just go with the default choice, even if it has the higher cost, whether monetary or emotional. So the states of New Jersey and Pennsylvania inadvertently ran a study on this when some laws changed and they had to give people a new option for something, I don't remember what. So there was a more expensive option where people could have like full rights to sue someone, I think, and there was a less expensive option with limited suing rights. And this one state had one way and the other state had the other like default option checked. And it was found that the majority of people stuck with whatever option was pre-selected when they went to fill out the form or whatever. And so they just didn't care. They're like, oh, I assume that that's the way it's supposed to be. That must be the better option since they pre-selected it for me. So this is related to loss aversion, that we weigh the potential losses of switching options more heavily than the potential gains of switching options. We're even liable to uphold the status quo even when it hurts other people. So people have underlying needs, and these vary from individual to individual. And if the status quo is providing you and satisfying your needs, you're going to not want to change it, even if the system is disadvantageous to other people. And we hold positive feelings about ourselves and the groups that we're part of. And we also hold positive attitudes about the overarching social structure that exists. And we're not going to want to change it if it's benefiting us. There's also some attribution errors, which I think speak to why it's hard to assemble the best team possible. One of them is the fundamental attribution error, that people have a tendency to attribute situations to other people's character rather than to external factors. So the classic example of this is if you're driving down the street and someone speeds and cuts you off, you're going to curse them out and think that they're a bad driver. But it's very possible that their loved one is in the back seat and they need to be rushed to the hospital immediately. And while they might value safety in all other situations, like road safety and following the law, a person is hurt and they're not thinking rationally. But it's only in that situation. And if you were in that case, you would have done the exact same thing. So in this case, I think we should think about the system on the people who we're interviewing. So it's not necessarily like these people are, it's like what the situation that they're in are causing them to not be able to do certain things that they would have been able to. So it's not that they don't like math or programming, because the system told them it wasn't supposed to be that way. So this is also similar to the group attribution error, which is that people have a tendency to believe that attributes of a group member reflect the entire group. There's an XKCD that I think illustrates this quite well. So on the left, you see two dudes, one of whom is apparently not good at math, and his friend is saying, "Wow, dude, you suck at math." On the right, you see a man and a woman, and apparently the woman is not great at math, and her friend is saying, "Wow, girls suck at math." So why the discrepancy here? Well, studies have shown that this group attribution error is stronger in perceptions of groups that are viewed as more dissimilar to one's own group. So the dude is less likely to think that this applies to the other dude than he is to think that it applies to the other woman. So decisions made by people in their own group are the result of structural constraints. It's not their fault, blah, blah, blah. But decisions of other groups are the result of their attitudes, that they are lazy or something. Another thing getting in the way of us creating the best teams we could possibly make is the availability heuristic. And the classic example of this is that people think planes are dangerous because we hear about plane crashes all the time and not successful plane routes. So because we hear about crashes all the time in the news, those stories about plane rides are more salient in our memories, and therefore we think that plane crashes are more common than they actually are. There's also an experiment that Tversky and Kahneman ran on this availability heuristic, in which subjects were asked, if a random word is taken from an English text, is it more likely that it starts with the letter K, or that the letter K is the third letter? And people would often say that it's more likely that a word begins with the letter K, but it's actually the other way around, that there's more words in which K is the third letter than if it's the first letter. And it's just the way that our word recall works. It's a lot easier to come up with words that start with K than have K as the third letter, and therefore, because it's easier for us to recall the word starting with K, we think that they are more common, but they're not. So I think this applies to the tech community in that if the more salient members of our programming communities are all stereotypical programmer types, we're going to think that that's what programmers all are, and that they're the people who do all the programming. And if we're also in a workplace, we're surrounded by people who look like the stereotypical programmer, we're going to start to also think that. And if everyone who you see on stage looks like a stereotypical programmer, you're going to start to think that everyone who deserves to be on stage and has valuable things to say, they must all be stereotypical programmers too. Well, that's not the case. In a similar heuristic called the representativeness heuristic, we tend to think that categories are relatively homogeneous. So if someone is a software engineer, we expect them to have the traits that we associate with a software engineer and vice versa. So this heuristic leads to several biases, such as something called base rate neglect. So Tversky and Kahneman ran an experiment in which they gave descriptions of people in a group that was composed of 70 lawyers and 30 engineers. And then they found that participants often said that someone who sounded like an engineer was more likely to be an engineer, even though the probability was against that because there were 70 lawyers and 30 engineers. So I think this applies in the tech community at programming meetups. It's fairly likely that someone at a programming meetup is a programmer. But I can recall countless stories which with me and my friends were approached by people at programming meetups, and these friends are programmers, and asked if they were a designer, because women are supposed to be designers. But like, no, we're at a programming meetup. It's likely that we're a programmer. All right, so I've been saying and kind of hinting at like diversity is probably important for a team. And I have one cognitive science reason for that, which is going to go back to that creativity thing. I said that creativity is the result of having really good dissociative memory, about being able to recall experiences, memories, ways of solving problems. So the more diverse your team, the more likely those people are going to have a diverse set of memories, experiences, and motivations and backgrounds. So I think that will lead us to making better software. All right, so how do we get past this? I promise we can. So this is all natural. This is all like, we do this for a reason. And that's because our brains are, in some part, statistical reasoning machines. We build up this data set over the entire time that we're alive in order to help our brains have that cognitive economy, to help us be able to think fast in situations when we need to think fast. So the quicker you think, the quicker you're going to be able to get away from that saber-toothed tiger that is chasing you. But when we're sitting at a desk, when we're making decisions about solving problems or thinking about ourselves and our worth within the programming community or assembling a team, we have time to make decisions. So the cognitive science literature says that there are two thinking systems. One is system one, which is this thinking fast, and system two is thinking slow. So you might have read a book called Thinking Fast and Slow by Daniel Kahneman. So system one is causing us to have all the things I've been talking about for the past 39 minutes. But we have time to engage system two. And if you're anything like me, you pride yourself on being a rational programmer, on thinking through things and being able to come up with great solutions. And if we just take 5 more seconds or just a small amount of time to think through all the things that we have to think through, whether or not it's that logic problem or it is deciding who you're going to hire, we're probably going to end up with better answers to all of these things, and we're going to be able to make better software. All right, thanks for listening. Find the slides there. Also, feel free to tweet at me. I will tweet out the slides. All right. Thanks.
All right, everybody can head downstairs for your stroopwafel break. My favorite tweet, well, not my favorite, but one that I really like, I'd be okay if they cancel the rest of Forward.js and just have Jenna talk about cognitive science for the rest of the day. So enjoy the break.
savor this moment as long as it lasts. Let me tell you, put it back. Piece by piece. If you stayed over, I'd make it so sweet. I'd make you remember, baby, from your head to your feet. And if you go now, baby, we'll never know how it ends. Naked you, naked you, naked you, naked you.
They walk in the sky, so near and so high. They stop and for none. And when the is done, they agree that the sea is the best place to be. Wondrously free, they live happily. They know from the past, life simply doesn't last. So they live for today, for tomorrow they may not be able to walk in the skies. reaches for the stars. Music is the hero, no matter who you are. No matter who you are. They walk in the sky, so near and so high. They stopping for none, and when they is done, they agree that the sea is the best place to be. Wondrously free, they live happily. They know from the past, life so doesn't last, so they live for today. For tomorrow they may not be able to walk in the skies. Sun slips into the horizon. Moon reaches for the stars. Music is the hero, no matter who you are. No matter who you are.
lights are so bright.
I know.
That's good. Hello, hello, and welcome to the real-time panel. We're gonna introduce ourselves first, and we're gonna self-moderate. It's a new concept. We don't have a moderator, so, and we're gonna be talking about like real-time, a little bit of what we think real-time is this year, what it means, how we do it, and some of the existing challenges and innovations at the protocol level, but also at the application layer. What are the features that you want to incorporate or you must have nowadays in your front-end applications, how to get really great responsiveness and latency, how to make mobile applications really fast, and some of the current projects that we're working on and what do we see towards the future. So go ahead and start.
Hi everyone, my name is Aisha Gül. I work at Autodesk. If you don't know what we do, we build 3D applications from manufacturing to architecture and digital animation. And we have the Forge platform team here. I think you can check out the open APIs that we have. And I particularly work on A360 3D platform. It's a collaboration platform where you can upload your 3D files and comment and collaborate with other people, which is really cool. And I've been doing a lot of data visualization previously, and I did build a lot of real-time dashboards. That's me.
Cool. My name is Daniel. I'm a developer evangelist at RethinkDB, which is a great open source NoSQL database, especially if you're trying to do real-time applications. More recently, we have this new project called Horizon, which I've been working on, and it's basically a JavaScript framework that allows you to build real-time, modern applications without writing any server code. And that's been a lot of fun. So.
Awesome. My name is Guillermo Rauch, and I'm the creator of a project called Socket.io. And before that, I worked on some of the early implementations of WebSocket for Node.js. More recently, I started a company called Zeit, where we are trying to create this idea of real-time deployment, which means as soon as you start deploying your project, we give you a URL that shows you the build in real time, and then when that completes, or if it errors, you get that feedback immediately, and that page refreshes, and then you have your deployment live instantly and in real time. So I'm going to start by asking you, what do you think real time is today, or when people come to RethinkDB, how does the storage part compare to the real time features? Where do you see real time being a core part of databases in the future? What's your thinking about that? How do you prioritize the real time aspects of the database versus the core parts of the database?
Well, we don't make any like trade-offs or sacrifices. The real-time part of RethinkDB kind of was born out of there are these background processes for RethinkDB allows you to scale really easily via like this web UI and basically say, I want a cluster of 12 RethinkDB instances. That backfilling process that would go split your tables up across those 12 nodes, people were saying, well, you know, actually, I want to be able to do that myself in my application. And it was kind of a crazy idea. So we introduced this concept of change feeds. And basically what you can do with your backend drivers is say, you take this same query that we'd write that in a kind of like request response model, you just add dot changes to the end of it, and now you have an open stream from your database of anything changing, it's going to be pushed to you from the database, so you don't have to request it anymore. So that's how that kind of happened. So we don't make any trade-offs. We have lots of excellent, you know, CRUD operations that you could do, but change feeds is definitely like probably one of the most distinguishing features about RethinkDB.
And what do you think when it comes to implementing like a real-time application today, which we can get more into what each of us think about a real-time application today, but how do you see the importance of, for example, the protocol versus making it a feature that you get out of the box from the database? Because what you're describing, the change feed of a database, is a part of how almost every database is built. For example, we implemented something similar to Horizon a few years ago, built on top of the MongoDB oplog. Because when a database is replicating, what it's doing is sending, okay, this query or this change to this document is being sent to every node in the replica set. And we took that from the browser. So the browser can become a node in this replication endeavor. And so if you were, for example, uploading an asset to your application and you represent that as a document in your database, you're interested in whatever change happens to that document on the back end. For example, when the upload completes, or you might track the progress field on your data backend of that upload process, and whatever change happens to that field you are interested in. So real time is a lot about keeping track of these changes that happen to data backends. My question would be, what happens if you're tracking many different databases? What happens if RethinkDB or MongoDB is not your only source of truth? How do you move beyond that? How do you try to do you materialize views that come from different data sources? Do you end up duplicating data and taking care of that? Because maybe that's the price you're paying when you merge database and real-time capabilities, right?
So there's a couple questions in there. First, what is real time? Real time is getting the data from where it sits to where it needs to be in the shortest amount of time as possible with as much native, very easy developer operations, and as few as possible. So with RethinkDB, it's a very natural part of the query language. It's not like something you build on top of the oplog, or it's not natively built into any of the drivers that you have there. To answer your other question about what if I have data that's not in a database like RethinkDB or MongoDB, one of our customers, NASA, actually, who use RethinkDB, they have a giant Oracle database. And they want to shape that data, whatever they'd like. So they actually copy it from Oracle, put it into RethinkDB, and then listen to those change feeds, make changes to it, put it back in, and then use a different change feed to push the new data back into Oracle. And that way they don't have to deal with Oracle and that kind of all the cruft that has happened there. So.
And can you tell us more about what your experience has been at Autodesk? Have you implemented a database with real-time capabilities, or have you done more of a manual approach where you set up your own communications backend and you keep track of the subscriptions to different data sources? Tell us more about your experience.
So one thing that I built was the health dashboard of our services that we are providing. So it was all of the data was coming from our databases, so I have to manage it myself. But we also have all these really interesting real-time applications that we are building at Autodesk that I'm not working on, which is being able to track what's going on a construction site, for example, through drones, and get the data in real time and being able to take a look at it.
Awesome. So I think something else that's very interesting.
I got a question for you. Why did you build Socket.io? What wasn't there that you saw and said this?
I wanted a lot of GitHub stars and Hacker News comments and flame wars on Reddit.
Perfect.
Done. No, I think the absolute main motivation for it was there was no such thing as the real-time web because it was too hard to do. So I think you mentioned a little bit about it has to be very easy. And frankly, even the origin of the Node.js project is very interesting because Ryan Dahl was working on a client on a Rails project, which is really interesting. And he wanted to track the progress of an upload. And this is why I always talk about this simple concept. Because before we had the upload event coming from the XML HTTP request object, how do you get the data about the completion of that upload from the backend? It's actually quite a difficult endeavor if you didn't have WebSocket. Surely you could have reinvented long polling, but that's a really long, you really have to think a lot about your backend and the how much load you're adding to them. It would be something that you wouldn't even consider to do. But you did want that API of I'm listening to a source of events from the backend. So that was the main motivation. We thought by providing this really nice API, I think there can be a lot of innovation in what you can build with applications. And our first use case was a Etherpad-like type of document collaboration engine. And I think this also can lead us into the next philosophical question, which is when we're talking about real time, we're always talking about minimizing latency, but I think a lot of us here have had a lot of success also with updating at a threshold that perhaps doesn't require this sort of like very intense push, like listening at the very change from the server. So how do you draw the distinction between like, it's good enough to poll for new tweets every 5 seconds, but I absolutely need to know where this drone is because it's gonna hit my head. So how do you decide for each application, or do you think what the future holds is every backend architecture is a push architecture, which might mean we have to rethink REST and HTTP. If anyone here has used the Slack API, at the risk of going on a little bit of a rant, they've had to create a REST API, and then they've had to spec out their own real-time API on top of WebSocket. So does the future hold a push-only future? And if so, do you think we have to rethink the fundamental protocols?
I think it does. I have also used said API, and yeah, it's quite weird to make an HTTP request, grab that WebSocket URL, and then make the WebSocket connection, and then you have to listen to all the different events. I don't think that it's like an end-all, be-all, but I think it's definitely an important part to have some sort of like push architecture. As to how fast that is, I think that, or like how fast it needs to be, that's definitely like application specific, but yeah.
Well, I mean, we are using different approaches. Like, if you're getting tweets from Twitter, you really do need the WebSockets, but our applications are huge, and we need to know the upload happens, but also we have to translate all these files, and it takes a long time. And it kind of wastes of WebSockets in that case, so that's the reason.
Right. Sometimes, obviously, request response is not enough, especially if you have very long backend processes. So converting a file in the backend is another example where you really want to be notified of things that are changing over time and perhaps map them back to a document or something like that. And so going back to WebSocket in particular, so when Slack decided like spec out their API, they had to sort of reinvent a protocol, because what WebSocket is giving you is this bidirectional channel, and the payload is up to you. So when you all designed the RethinkDB channel, I understand you use WebSocket, right?
We do use WebSocket.
So how do you face this problem? Like, did you create a new type of object from scratch?
Well, so just to differentiate, we have like RethinkDB exists solely server side, and you have this idea of change feeds.
Horizon. Yeah.
So Horizon is like the front end, or it's like the middleware built on top of RethinkDB. But we also have like a client library, right? So we manage the whole WebSocket connection for you, like you're saying. And yeah, we did come up with our own protocol to manage like the data and the events that occur between the two sides.
So do you think there would be some value to standardizing that?
There could be. I don't know if it fits everybody's use case. I would hope so. Someone has already taken it and built a Swift client actually on top of it versus like having one only exist with JavaScript in the browser. So that was pretty cool. So I imagine it's flexible enough to handle like lots of different endpoints, but it'd be nice to have like a larger, very like community-wide protocol that's accepted or worked on.
Something that's interesting when we talk about changes over time to a source of truth. This is happening obviously in your database, it's happening throughout your backends, but more and more is happening on the front end, because you have these stateful applications where in some cases the approach to building front-end applications is querying your own little database on the front end. In other cases, it's you being in control of this state shape, and when events or actions come, you decide how to change that state over time, and perhaps you can go even back in time and analyze how this has changed. So for example, Redux has such an approach where each change to the state is typed as an object with a type field, an action name, and then an arbitrary payload. And then middleware functions can alter or look at this payload. So I think this is interesting because there is sort of a parallel. When you're sending these Flux events to your store, dispatching them is very similar to when you're sending these WebSocket packets back to your backend. So perhaps what we could see in the future is some sort of standard for how to send these actions over time, how to introspect them. Because I think something that I've faced personally is WebSocket tooling can be insufficient. You have this little, like, very, like, this frames view with arbitrary payloads. It doesn't understand content types, right? So also, where does HTTP2 come in? What's your view on this? So when we're talking about data payloads and sending JSON over a WebSocket connection, you have this implicit agreement about the content type, right? You're saying client server understands it's JSON. REST and HTTP have already solved this problem because they say there is a content type field that declares what kind of body payload you're sending. There is a length, which is obviously also built into WebSocket. So when do you decide for your applications to use REST, perhaps over HTTP2? And how do you decide to use WebSocket? Where does event source come in?
I mean, it totally depends on your application. For Horizon, we stick to WebSockets solely. And you play with WebSockets without even realizing it, and you're getting data straight to the client, pushed to you after you've set up the watch and everything. But yeah, we were sold on the WebSocket. We did use Engine.io for a slight moment, though.
Well, there's no one-size-fits-all solution for any of these, unfortunately. So yeah, we have different solutions for each one. Do you have any good examples? I can't think of any.
Yeah, so I see a few patterns in WebSocket type applications. One of them is, in a lot of cases, you are trying to encode stateless request-response cycles inside WebSocket, which can be very interesting because if you look at how HTTP2 works, it's just as it's perhaps even a more efficient protocol for sending requests and response, but I think a lot of applications try to do everything over WebSocket. One of the implementation details that we have to take into consideration is each WebSocket channel or instantiation is nowadays being mapped to a TCP connection. So if you're designing a highly modular or component-oriented application where different parts of the application might not know about other parts, and they auto-populate. If you're relying solely on instantiating WebSocket connections, you're at risk of using resources not too carefully. Whereas with HTTP2, every time you're sending a request and response, no matter in what part of the application you're in, they get multiplexed over one connection. And the other, perhaps, disadvantage would be if you're on a mobile device, you already, the very first payload you're receiving, that initial HTML payload with scripts and styles, is already an active connection that you could reuse to receive further events about what's happening on the back end. But if you're instantiating a WebSocket connection later on, you're paying this price of another round trip, another handshake, another perhaps even SSL connection, especially if you're using different subdomains. So I think there are some interesting trade-offs to be considered when it comes to resources usage. And you have to think about maybe my application is better off with sticking to a RESTful architecture over which most of the request and response cycles go through. And then you could initialize a consumption of events, particularly that's only in one direction. So you're listening only on incoming events. And the configuration of this event subscription is determined by you by potentially making other RESTful requests, perhaps with a parameter, perhaps with a query string.
I think the other interesting thing about HTTP2 is server push. I'm really interested to see where that's going to go. I think it'd be really neat to see if you, from an application standpoint, can I trigger server pushes?
Absolutely.
You can set it up with Nginx, 1.9 and above right now, where this index.html file is going to call these CSS files and these other JavaScript files. So the moment someone makes this request, also push these. But what about this blob of JSON I also want to send up there, or they've been looking at the website for 5 seconds. Now I want to push this extra data to them, or something like that. Where
Absolutely.
Is that going to be possible?
And I think what's interesting there is, you mentioned Nginx, a lot of applications are not going to be serving or speaking HTTP2 directly, at least for now. And what happens is, you can't do that push directly, because your application is still serving HTTP 1.1, and then it has a layer of a load balancer or proxy that understands HTTP2. So there has to be a contract between that load balancer proxy and your HTTP 1.1 backend to say, if you return this header that points to this other resource, I'm going to push it. So I think we haven't seen too much of this yet. There are a few implementations of reverse HTTP2 proxies that do this, that give you this a few headers that you can respond with to send more data. And there's also this idea that you could automatically decide what data to push. So there have been some statistical approaches that look at if you're requesting a resource with a certain referrer, the backend can learn that, you know, if the majority of requests that go to your site.com/index subsequently request logo.png or events.json, and based on that referrer information, they can automatically say, okay, I'm going to push this as well. So I think there are some interesting approaches also to usability. But when we're talking about subscriptions, what do you think are the best ways to manage this on the client side? Because when you're dealing with a lot of concurrency, when you're dealing with data coming from many different places, or perhaps even as you're scrolling through your application, you're only interested in a subset of the data. And that means if you're interested in only a subset of the data, now you have to be subscribed to only that subset of the data. Otherwise, you could be at the risk of being oversubscribed to every single data point that the user could be interested in, and that has a lot of resource consumption penalties for both backend and front. So how do you look at this with Horizon applications?
Well, first of all, I want to know when I'm on my cell phone and I don't have Pokemon Go open, why doesn't it tell me the Pokemon that are near me that, you know, are active and I can catch one, right? Like I have to have the app open. Like, was that a design decision, or just were they not able to implement something like that? But with Horizon, basically, it is possible, but like I think it leaves a lot up to like the view layer, basically to communicate that like I only want to watch these certain elements or the data that backs these certain elements, and it's definitely possible. So basically, change feeds on the back end with RethinkDB, but with Horizon, we have these like watch queries. And basically, if anything happens on the back end, you're going to receive like a callback and be able to handle that new data and put it where it needs to be. But as you're scrolling, that's a pretty tough challenge.
Have you?
Yes. Well, before we've been using some promises to handle new user requests, and our files are huge, being 3D, and we transfer a lot of data. So some users will click on a file, and then we will start uploading it, and then they just go somewhere else. You know, they just don't want to look at it. And if you have a promise, then that promise is still going to return, and that's huge. It's just blocking your rendering. So now I'm super excited about RxJS and can't wait to implement it, because you can watch for the changes, and if the user clicks somewhere else and wants to go somewhere else, you don't have to load that data. You don't have to render all these things.
Yeah, so am I, actually. In particular, the observable primitive is promising, no pun intended, to promise, because it encodes the idea that the cancellation comes with the resource that you're subscribing to, right? So the cease of observation means that the resource or watching or whatever you were doing, or even a set interval that was polling your server, gets shut down, essentially. Whereas with promises, you're saying, give me this value and notify me when it resolves. But later on, if the semantics of that subscription change, you can't really do anything about it. You can't send a message into the promise to say, I'm only interested in a subset of the data now. You just have to ignore it. Cancellation semantics are being retrofitted now into promise, which would allow us to abort it. But now I think a lot of us here have already been bitten by the fact that fetch, which is a new shiny way of making requests and responses, doesn't have an abort method. So I think it's also interesting to think about what concurrency primitives or what asynchronous representation primitives you're working on your application. I think some applications have this need for, you have to be very, very careful about resource consumption and what you're subscribed to at any given moment. And I think Observable and RxJS are really good options there because of their composability capabilities as well, and because of this built-in de-observation callback that you get built in.
And it's easy to reason about the whole thing, because it's like always you're just working on a stream, and you're manipulating that stream from the moment it starts, up in the mountains, down to your rendering layer, wherever that is on the browser. And it's really great. We use observables heavily with Horizon. Also, you should definitely check out MobX, which I've heard a lot of good things about, managing state. But the observables like API is excellent.
It's interesting because there are different approaches nowadays, and I think one has to look at all and understand trade-offs and pros and cons, because when you're looking at simplifying your UI, simplifying your application, at the end of the day, each component on the screen is mapping to a resource that's identified typically by some sort of unique identifier that has relationships to other objects that are on the screen or perhaps not on the screen. And one could imagine that the future holds a declarative way of saying these are the data dependencies of this one component, where you're not really saying this is how they're retrieved. You're just saying this one piece of the screen requires that we get a user object, and in particular I'm interested in the nickname and age. And perhaps another part of the screen is interested only on the nickname. So if it's being declaratively mapped, what you end up with is if the component that was interested in both a nickname and age gets unloaded or removed or unmounted, then the subscription automatically persists, but only for that one field, which is age or nickname. I don't know which one I was talking about. But the idea is essentially that you could diff the fields that you're subscribed to as elements on the screen are being appended and removed. And then you're basically abstracting out how that data is actually being fetched, which could be RESTful, which could be WebSocket through Horizon, or your front end as it evolves. You don't really want to be tied into one way of doing data exchanges, right? You might want to query a third-party data service at some point in the future. So I think it's important to also think about this declarative, pure way of declaring your data dependencies.
What are you building next, Guillermo?
So what I'm doing is a combination of all of this. Our approach at Zeit is we serve all your deployments over HTTP2. So we let you decide what the best message patterns are, and we support them all. So WebSocket, event source, request and response. I think, I always come back to this idea that HTTP2 has made everything really fast and much easier to implement without changing too much about how your application works, and very efficient specifically on mobile connections. So our approach is at the present moment very agnostic. When it comes to designing my backends, I always think about microservices. So whether it's a RESTful request and response cycle, I set up a microservice that does that one thing, or whether I'm listening to an event source, I set up another microservice that is giving me events only about this particular thing. And I compose them from my front end or through intermediate backends that also query other backends. So I try to keep these concerns very separate, usually. And when it comes to the declarative approach that I was describing, we might go away from this idea of microservices to micro schemas. So your backends would be only designed to resolve these specific data dependencies that different components in your front end on your front end would have, and that perhaps needs some rethinking about what the widespread common protocols of the web are. Perhaps REST is not the best possible fit for that one approach.
This is our time, actually.
All right, so thanks a lot, and if you have any further questions about all of these topics we covered, we're going to be hanging out right there. Thank you.
So just a quick update on the schedule. Our next fireside chat here about serverless architecture is going to start about 10 minutes late. Also, unfortunately, Andreas Gall had to cancel. So if you want to hear Justine Lamb's talk about bookmarklets, that's going to happen in about 5 minutes up in the lodge. Otherwise, hang out here, and our serverless panel will get started at noon.
But I guess you got to know. Didn't mean to tell you. But I guess you got to know.
You will find each time you listen to this recording that you relax deeper and deeper.
I think that we're going to get introduced. Or at least, like, in a very coarse sort of like, this is starting now kind of way. Yeah. Hi, everyone. Is this on? Ah, yes. No. Hello, 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 hello. Hi. I think we are about ready to get started. I'll introduce myself briefly, and you can do the same. And we're excited to have a conversation about serverless architecture, which is something that we both care a lot about. And I wanted to say, if people want to interject or scream at us and tell us we're wrong, et cetera, that's actually welcome. Just make sure you scream really loud so everyone can hear you, and we'll repeat the screams for everyone else's benefit. But definitely consider this an interruptible presentation. With that said, my name is Ben Sigelman. I am presently one of the co-founders at a company called Lightstep, which is doing real-time distributed tracing of large-scale distributed systems. And I also work a lot on a project called Open Tracing, which overlaps with Lightstep in some ways, but kind of has its own charter and will probably end up being its own entity at some point. I was at Google for about 9 years. I mostly worked on large-scale monitoring at Google. I started and built out the Dapper project, which is a distributed tracing system that's in use in production in that environment. I also worked on Google's large-scale time series monitoring for high availability systems. So that's my background and area, but I thought a lot about serverless architectures before they had a name, I think, and I'm excited to talk about this.
My name is Alex Salazar. I am one of the co-founders and the CEO of Stormpath. We are an authentication and authorization service for developers. My background's a bit more varied. I've worked on large-scale cloud-based healthcare systems, media systems on both the engineering side and the sales side. So I've been on the light side and the dark side. and we have a fair bit of experience with serverless, both by serving our customers who are trying to build serverless applications, and then we ourselves actually went through a very large evaluation implementation process for our own architecture, which we can talk about in a bit. But.
Great. So, yeah, I mean, I guess we could get started just for people, I actually did a Google Trends search before we started on serverless architecture, because I know it's a buzzword, but I wasn't sure exactly how fresh it was. It's very fresh. You can look it up. It was essentially an unused term until about 6 months ago, at which point it became like there's sort of a trickle, and then in the last 4 or 5 months, it's accelerated and is now on this insane growth curve as a buzzword, possibly to replace microservices. I think it's actually more accurate. But what does it mean?
Well, so it is a trendy buzzword, and I think the problem with it is that a lot of people are taking it to mean many different things. And from my vantage point, I see people referring to two different things with the same term. One of them is what we sometimes refer to in our company of like API-driven development, where instead of me building something in my application, I'm going to go find a vendor like a Stripe or a Stormpath or a Twilio who just does this stuff for me, and I'm just going to plug it in, and therefore I have minimal amounts of server architecture. But I think the other definition, which I think is the one that's a little bit more accurate, is, and so the first one I would just refer to as backend as a service. And I think that's not necessarily that new. It's been going on for a long time, but people still refer to it as serverless sometimes. And then the other one, which I think is more new, is functions as a service. That is you writing a very small modular piece of code that you then drop into something like AWS Lambda. And you don't have to run a server. You don't have to do any kind of server stuff or have a server application. You're just calling out to a function that just does something very, very atomic and stateless.
And so you think of that, and by calling a function, you also mean a function that your business is writing, as opposed to
Yes.
as a client thinking of just normal SaaS backend.
Yeah, absolutely. As awesome as I think some SaaS backends like us are, we're not really new. Our models have existed for quite a long time. I think where all the excitement in serverless is today is really your ability to write some business logic that's specific to you and have it run in an environment where you don't have to manage anything that even remotely looks like a server.
Yeah, that makes a lot of sense to me. I think what I've observed, people have become accustomed, thanks to companies like yours and Twilio and so on, to the comfort of writing a client API call that's going to make some sort of RPC or request another service. And it's nice, it's awfully comforting to realize that you don't have to run that thing and you don't have to keep it up and make sure that all the chef scripts are written correctly and so on and so forth. And we've grown accustomed to that. And as our own monolithic applications have been broken into smaller pieces, the task of dealing with just the lifetime of a VM, which is I think what the server is referring to, has become overwhelming for people. I kind of think of it in terms of cooking, which I'm really bad at and don't enjoy. And so it's a perfect metaphor for me in that you've got, there's a world that's still, many of us are living in it, unfortunately, where if you want to cook a meal and build your back end, you're not just cooking your meal, but you're assembling a camp stove and like buying gas and plugging it in and making sure that when the flame goes out that you have to like blow on it or knock it. I don't know if people try to cook when you're camping, but I hate it. And I think that's what we're all doing with our services right now if we're not in this sort of Lambda type of world. It's just a silly thing. Like you shouldn't be building camp stoves when you're trying to cook. It's stupid. And when we're all assembling stuff at the VM level, that's what it feels like to me.
Well, I feel like the exciting part of so I think in the camp stove example, you know, Heroku is an example of you're still using a stove yourself. You just didn't build the stove.
Exactly. Nor did you keep it.
Nor did you keep it. But I think what makes serverless exciting is that the stove is there, but you aren't actually using it. You're taking your recipe and your ingredients, and then there's somebody else who's actually cooking it for you.
Yeah, that makes sense. I'd also say that it's one thing to cook a meal and you have 3 or 4 pans, but if you're trying to build microservices, you've got like 1,000 camp stoves, and it's just completely unreasonable. And so you have, I think Heroku is a perfect example of a company that was doing this before it had a name, at least in spirit, although I think you're right, it can go further than that. It can go further than what Heroku is doing, and Lambda is like the perfect example of that. But.
Yeah, no, I think it's an important distinction. I mean, we've been following Heroku. Since day one, and we're big adopters of microservices as well. And I see serverless in the Amazon Lambda, paradigm as being fundamentally different. In Heroku, they've done a great job of automating server, work, but you're still engaging with a server. Right, you're still managing a worker. They call it different things and they wrap it in APIs, but you still have to worry about server application. You're still writing a Node.js application or a Python application or a JVM application that is your back end. You just abstracted out the managing of the iron.
How would you think about something like, I don't think it was the product has a lot of issues, but how would you think about something like Google App Engine, by contrast?
I think Google App Engine, Heroku, and a few other companies that tried to do this, like AppFog back in the day, and Parse. I think all of them were really trying to be platforms as a service. They were trying to enable you to still create a back-end application, to a degree, a monolithic application, just on their infrastructure. I think what serverless in the Lambda model, which I think is where a lot of the excitement is, it's fundamentally different because you're not building a server application. You're building a set of very finite, discrete functions that you're calling in a stateless fashion. Is it better or worse? I think that for some people it is, especially people who are client-side developers who don't want to muck with any of the back-end stuff, it is a superior model depending on your use case. For people who are traditionally building server sides, they may not see the allure initially until they start using it, and they're like, oh, I don't have to worry about this stuff anymore.
I'm curious, so you said that at Stormpath you have adopted an architecture like this. I assume that involved a migration just due to your company's been around for long enough that it probably didn't start with this exact architecture. Is that correct?
Yes, absolutely.
So can you talk about that decision process and how you evaluated it?
Yeah, so Stormpath, again, we're an authentication authorization service that other software developers use to offload this kind of work from their plates, because authentication authorization is fairly well defined and fairly commoditized. Why build it? So when we built the company, we made the decision to build a JVM-based application, Java, mainly for performance, scalability, and security. And so at the time, the way you built Java applications was you built one monolithic Java application. It was a very good way of doing it. And about a year ago, there were some features we were going to build which really kind of enabled us to change our architecture, give us a good reason to try and rebuild to a more asynchronous microservices type model. When we did that, we were like, okay, well, let's go look at Lambda. Right? Lambda looked really exciting. And we actually went through a very intensive proof of concept. We actually ended up building a lot of the functionality out as part of the proof of concept. We were working really closely with the Amazon Web Service, Amazon Lambda product managers. And the vision was, again, if you're comparing it to having a backend, the dream is that I can now redeploy, maintain, and update modular pieces of my code without having to version the entire system, right? Because deploying a large-scale backend is a lot of work. I mean, we have dedicated DevOps guys, and many of them, who do nothing all day long. But if I can just update one function, then everybody's happy, right?
Yeah, I mean, I think there's some issues if that function's doing something important about doing blue-green deploys and so on and so forth, but that almost argues more strongly for this architecture than less strongly. There's,
yeah.
It scares me a little bit when people move to CI and CD with lots of microservices and really take a lot of pride, and there should be a certain amount of pride in, our company is doing 100 deploys a day, when I was brought up and brainwashed in a model where you thought of a deploy as the most likely time you're going to have an outage. And certainly if the incremental deploys are small, that's great, really seriously great. But my God, it's just terrifying in my mind, if I'm thinking about reliability of a system, to imagine that every time someone submits code, I am relying on their test coverage being so good that any possible, not just semantic regression, which I believe you can catch with good tests, but interference effect between systems was thought about ahead of time and predicted by the developer who just decided to merge their PR because they're about to go to lunch, scares the shit out of me, totally terrifies me. So this is something where I feel like the pendulum is going to swing back. I'm hoping to there's going to be a daily deploy or something like that. But anyway, I'm rambling.
No, you're right. I mean, I think and this is actually where I think people get caught up. This is, I think, where some of the risks with serverless exist, and where people get really caught up in problems when they start building production-grade systems with larger teams. Serverless is not a panacea, right? It is not a silver bullet to you not having a DevOps team. And so, having good hygiene around how you deploy, having good hygiene around CI and CD, having, high code coverage, you can't get away from that. And in fact, to your point, it actually gets more complicated with serverless. Because in a monolithic app, as the other end of the spectrum, there's only one version, right? I deploy my one version of my monolithic app, and every time I redeploy, the whole thing is guaranteed to work with itself. When you start to deal with microservices, or on the more extreme side, functions as a service, you don't have to worry about n number of different pieces that all have their own set of versioning issues. So if I version Lambda function X, what happens with Lambda function Z that is consuming or calling that function and something changed in the interface? Now I've got to make sure that this whole graph of communication is somehow intelligent enough to capture that versioning update. Or I have to go redeploy everything all at once like a monolithic app, but now more complicated because there's more deployments. So it cuts both ways.
So when you all made the decision to, flip the switch or pull the trigger, whichever metaphor we're going to use, who were the voices that were saying, this is a terrible idea, don't do this, and why did they lose?
I was that voice.
Oh, perfect.
And so actually, let me take a step back. So we tried to move to the Lambda model, and it didn't work. We actually couldn't make it work.
Let's hear about that.
Yeah, so one of the big problems with serverless, we talked about the complexity of deployments, and interoperability sometimes between these things in large-scale production systems. The other thing people don't talk about very often is latency. One of the big problems with serverless is that these are stateless pieces of code that are being spun up and spun down as needed. And so if you have a function that doesn't get called very often, or you have a function that might see big spikes in traffic, you can see a lot of latency. And even if you don't have one of those, you're still seeing latency that can be in the tens of milliseconds. And if you're working in JVM, it can be up into the seconds. And for us, that was unacceptable. And so we actually had to build out our own. If we went from serverless to actually having many more servers as a result, we had to actually spin out our own microservices architecture using Samza to approximate the same architecture, but we ultimately had to actually adopt more infrastructure, not less, to achieve the same thing.
Yeah, that's really interesting. One thing that I think about with this trend, let's just talk about another trend, actually not related to server or serverless architecture, but related to databases. I don't know, what was it, 10 years ago, 8 years ago, that NoSQL databases became a big trend. Definitely a lot to be said for them, for sure, but there was such a hype machine around that transition, and the benefits, which are numerous and legitimate, namely around maintainability and scalability is linear with NoSQL, and that's a totally valid benefit. But the thing that's unfortunate is that the hype machine did not successfully communicate the drawbacks of the technology. And I don't think that helped NoSQL databases. I would actually argue it was really harmful for them in the long run. I mean, I hope there isn't anyone working at Mongo who's at this talk or they'll throw tomatoes at me, but I think that Mongo is actually a really great technology that's totally appropriate for a wide variety of use cases, but they market it for a wider variety of use cases than it should have been marketed for. And so you had people who would have been perfectly satisfied with like a hosted MySQL or something on RDS or whatever, who moved to Mongo and found that a lot of the semantics of their application broke, or that they ended up with these weird Heisenbugs. It's unnecessary, and it was because they didn't communicate the drawbacks of the technology. So stepping back to what we're talking about now, I think it's a huge issue right now that the move to Lambda specifically, in my mind, is the absolute extreme of where this movement will go. I think there's something in between that hasn't been fully realized. The closest thing I'm aware of really would be gRPC or maybe Thrift, although I think Apache Thrift has a lot of bugs. But gRPC or maybe Finagle or something like that, if people can find a way to make gRPC services, which have many methods, as a hosted service with some opportunity for inter-request caching, that's a very different animal. And can I indulge myself? So what I'm getting at is that, well, there's the old joke, and I apologize to 95% of the people who've heard it before, although the other 5% will think it's hilarious, I hope, about computer science, that there are only two hard problems in computer science. One is naming, the other is cache invalidation, and the third one is off by one errors. And I think that joke is really apropos right now, because the cache invalidation thing is a big problem, right? It's like if you have a Lambda service, and this goes right back to your point about latency, anytime you have latency issues, the way you solve it is with caching. I'm just going to say that. And let's talk about caching within a VM versus caching off of a VM. So let's assume you're on a really fast network and you've got like a 1 millisecond round trip, which is probably unrealistic. It's probably more like a 5 to 10 millisecond round trip in the 99 percentile. And so you use Memcached. Great. That's an option that would work with a serverless architecture. Let's talk about doing caching on localhost or within a VM. You're talking about a memory, like a cache miss at the CPU level. You do a fetch from main memory. That's 150 nanoseconds. So it's 1/10 of a microsecond. So that's like 1, 2, 3, 4, possibly 5 orders of magnitude difference between those two lookups. And people think of them as being the same thing. I would argue there are a lot of people programming in Rails and Node who don't actually know whether or not their cache is local or remote. And that's like a huge, huge difference. I'm not saying one is better than the other, but if you end up needing that in-memory caching and you don't have it, your system is going to be super slow because you're going to be serializing these like 5 millisecond hits for every single lookup you do. And I don't know, to me it's like there are definitely situations where Lambda is appropriate, just like there are situations where MapReduce is appropriate or anything else. But I feel like it's this, when you've got that hammer, everything's looking like a nail and people are going to get totally burned by it. So I guess my TLDR is like, if you think you're going to need to cache anything between requests, you probably shouldn't use Lambda for that service. Does that make sense?
Yeah, I think so. I mean, and I'll even get like a good tip and sniff test to add to that that as well. If the word performance ever comes up in what your application needs to have, if that is like part of the requirement set, I don't believe that serverless is ready yet, right? Microservices is, and so which is you will still have to probably deploy your own infrastructure if you've got a large enough team. But microservice is ready for that. And that's like a really natural stepping stone, I think, towards this model. But serverless isn't ready yet for performance systems or real-time systems. The other check is if you need to chain these functions as a service, then that's probably a good sign that you may want to rethink whether or not this is applicable to your application, because that latency starts to compound as you start chaining functions and chaining these Lambda functions. And that's where you can start seeing the crazy spikes that people talk about. Like at one point we were seeing 10-second latencies on a request because we were doing 4 chains. I think it'll all get there, and I think in maybe a year or two we'll all be having a very different conversation. But today it's very good for very specific kinds of applications that don't need to worry about latency.
Well, that was something I was wondering about. I mean, where do you think things will be in 5 years? Maybe you just told us, but I'm curious.
Well, look, I mean, I think if you look at the history of computing, right? Abstraction has just been this never-ending drumbeat, right? It's just whatever you're building today, there are parts of it that are going to get abstracted away. And the thing that's always going to be yours is just the raw business logic. And anything that's not raw business logic will always be further and further abstracted. And it'll start out really slow and really painful, and then a year or 2 or 3 later, it becomes quite nice and the default. I believe microservices are already starting to get there. I look at serverless and in particular the functions as a service paradigm, and I just see it as a natural evolution. I think we'll get there, or there'll be a different model. I think the only thing that worries me with functions as a service is that the development paradigm ends up looking radically different, where I actually wonder how hard of a learning curve it'll be for people who are not native to it.
How was it for your developers to just adjust to that model?
Well, because we were ourselves an API service, through our own customers' eyes, we had already adopted that paradigm. So intellectually, it wasn't that challenging. I think from an implementation perspective, it was actually a little bit hard. Not so much because our guys had to bend their minds to kind of get around it, more so because we had to invent a lot of stuff. Like a lot of the things that we needed to really build production-grade applications in that kind of model just didn't exist. And so, how we were doing testing, how we were doing messaging, how we were doing, authentication between our own services, like a lot of this stuff had to be custom built to meet our requirements. And that was probably the hardest part.
Interesting. I've been thinking about this a lot in the last, I'm actually skipping out on another much smaller 15-person workshop that I'm supposed to be at right now. It's specifically talking about distributed tracing, which is basically like the academic term for understanding the causal relationships between events in a distributed system, which is of a lot of interest to people who are trying to understand the performance, reliability, and even behavior of large distributed systems. And we've been talking a lot about JavaScript, actually, which is relevant to this conference, of course, with respect to promises and futures. And in some ways, I think the Node community is actually better positioned than almost any that I can think of, possibly excepting Scala, although I think Scala is ridiculous. But the Node community is very well positioned to accept this sort of paradigm because everyone has already got it burned into their head that you should do everything from callbacks and you should expect everything to be asynchronous. It's a really great way to be thinking, I think, if you expect to write like reasonable code in the next 5 to 10 years. I'm really pleased about a lot of that development, and you can imagine something that you're writing a future or a promise in code in a Node application. you can imagine not caring about whether that function runs locally or remotely. You can set expectations and requirements around how quickly it has to come back. I was talking yesterday with the guy who wrote the Q library, which has, I mean, it's kind of has a end timestamp on it as a library because ES6 now supports promises, but for now it's a really useful, popular library. And I was talking with him about how that should be adjusted to support this sort of systems we're talking about with functions as a service. And his point, which I think was really valid, is that promises need to have more features around deadlines and expectations around behavior of peers and so on. With those small tweaks and changes, I think that the way that people are writing code in JavaScript is actually a better fit for the way systems are going to be built than virtually any programming language I can think of. And that's a really great and powerful thing. But I would encourage people to move to a mode where when you are deferring work to some other functional unit, and you could imagine that functional unit eventually living in like a separate process or in a service, to think about how you can codify your expectations around the behavior of that service. It's a real anti-pattern to wait forever on anything. Anytime you're waiting on something that's not like in process and CPU bound, probably should have a deadline and so on and so forth. But if people can get into the habit of doing those sorts of things, your brain is already thinking in the right way to take advantage of the architectures that will be prevalent in 5 years, I think.
Well, as a quick plug into the JVM, because I have to do that here.
Of course.
A lot of the things that Scala's done in the JVM for asynchronous and what they refer to as reactive applications is evolving really quickly, but also it's starting to make its way back into the core Java. And so I think that Java is well on its way to, actually I think it already is well on its way to supporting asynchronous development. I think the biggest challenge in most communities is that Node doesn't have. I think you're right in that Node I think is well positioned, but I don't think it's technology anymore, or less so. I think it's more that JavaScript developers are already in the paradigm of asynchronous development.
It's nothing to do with the language, it's the idioms. I mean, it's the idioms that were established early in Node happen to align very well with this.
And I think the average JavaScript developer, even above the idioms, is fairly comfortable with the notion of asynchronous development. In the JVM outside the Scala community, even though Java 8, for example, has a lot of support for a lot of these great things, and you've got Netty and Jetty and things like that, the average Java developer still hasn't wrapped his head around this stuff yet, even though the tools are there for him.
That makes sense. Where do you think Stormpath fits into this whole picture?
Everything needs authentication. I mean, look, when you start building out microservices or functions or anything, the authentication burden actually goes up. And so, obviously in an end user facing application, you have to authenticate the user. And you need to authorize the user after the authentication process to make sure he's accessing the right data in your application or seeing the right views or whatever. But when you start moving towards a world where there's multiple services that are they're doing more than just managing a user, you don't have to worry about authentication and authorization of those services, machine-to-machine communication, if you will. And when we see people moving to these more distributed architectures, that's actually the thing where they're struggling with the most. And we fit there as well. So it's either authentication of the functions themselves or authentication of the user.
Yeah, I think that makes sense. It makes a lot of sense to me. The tooling that people have right now through Amazon and I guess to a certain extent through Google is often exposing concepts that are at kind of level 3 in the OSI stack, like it's like TCP level control over things, or I guess the equivalent thing in the compute stack would be VM level control over things, which unfortunately, I pair your point about people just wanting to care about business logic is neither here nor there. And so you have people, doing all of the security through what port you're talking to, which is really wrong-headed and ultimately, like, just kind of fundamentally it's not the level of abstraction that security should be enforced at. It makes a lot more sense to me to try and do as much of the stuff at the application level as you can. And to me, a lot of what this whole conversation is about with serverless and with things like auth and with things like monitoring, for that matter, is there's a need to push up to the application layer, both because it's what people want, and also because when you have like 10,000 containers running your distributed system, it's completely unreasonable to try and manage things at that level of granularity. The signal to noise is so bad that you'll just confuse yourself in your tools by operating at that layer. So I think it makes a lot of sense to push to application level anything, auth, monitoring, provisioning, orchestration, service discovery.
Yeah,
all that should be at the application layer.
Yeah, I mean, I think boiling it down even further, it just comes down to speed to market and cost, right? If you're building out anything that you don't absolutely have to, that means your developers, which nobody has enough of, are spending time building, but not just building, but maintaining it. Whether it's billing or messaging or monitoring or authentication, the more people you have on your core business logic, the faster you can get your app out.
I think that we're running pretty short on time, and I'm disappointed that no one has screamed at us. I'm curious if there are any people who have things they want to say or correct or whatever.
We've wowed the audience.
I've bored them, I think.
Oh wait, I see a hand. There you go. That's a good question.
Can you repeat the question?
The question was, how do you manage the business risk if you're depending on other vendors for parts of your application? Did I capture that right? Okay, dependency risk. This is actually really important. It is a very real risk. Whether you're using services like ours or whether you're using Amazon Lambda, it is something that the business teams and the architecture teams need to think through. I don't know that I have a silver bullet answer for you. I would say that it comes down to doing diligence with the vendors you're looking at. What are the performance uptime SLAs that they're going to commit to? What is historical uptime? What does historical performance look like? Is this vendor a vendor you can trust? Do they have a good track record? And do you feel comfortable with it? I would say that in the history of computing, you're always depending on vendors. I think that dependency is currently a little bit higher right now in the world of SaaS services, because you're not just depending on them for logic and code, you're also depending on them for operations. But I think it like any vendor you work with for any tool, it's just a matter, I think, of diligence.
I would agree with that, and I would say if the vendor is participating in a distributed system that has more than a dozen pieces, you should demand to have a SLA around high percentile latency as well, because these things compound. So if a request that matters to your business touches 10 services or touches 100 services, the latency is going to be the max of all the latencies involved. So if you touch 100 services, the P99 latency across those services is what your user is going to see. So you need to make sure, I think a lot of people are signing contracts right now with really terrible SLAs where it's about uptime. Uptime doesn't mean anything. It doesn't mean anything in this system. I mean, if you need to maintain low an SLA of your own, I think you need to be demanding actually high percentile latency SLAs.
Well, I will say that I think depending on the service you're talking about, I think uptime, not necessarily the SLA, but the historical uptime is really critical to understand.
Oh, it's an and, not an or.
Oh, okay,
yeah, uptime also important. That infinite latency when it's down, so that's really bad.
Fair enough. Any other comments or questions? Okay.
Go ahead.
We had one last one, and then we'll cut it.
So the question was, would a monorepo / mega repo like what Google has make this sort of thing simpler?
I think I don't think the juice is worth the squeeze. Yeah.
I was brainwashed in that model. I started at Google as an impressionable 23-year-old, and it does have some advantages. The only one that I'd really point out is that all of your dependencies, if you do a weekly deploy, or hopefully more than weekly deploy, all of your dependencies get pushed out every week too. That can be accomplished in a normal, non-monorepo model too, but it's essential to keep your dependencies up to date if this sort of system is going to stay healthy. That's the only real advantage I see.
but I mean, regardless of what approach, I mean, I think it all just comes down to your team having processes and ideally automation to make sure that everything's being tested before it goes out, so that integration testing is the way you keep yourself from blowing yourself up.
I think that we've been told we're out of time. So thank you, everyone, for staying awake if you did. And if anyone has any questions, I'm sure we'd both be happy to talk about this stuff offline or later or whatever.
All right, so now we're breaking for lunch, which is downstairs. We've rearranged the tables, so hopefully fewer lines. And a pro tip, there's a staircase there, and there's also another staircase in the back.
gone for good. Yeah. 'Cause when it's gone for good. Let me tell you. And if you stayed over, you know we would. If we could put it back together. Make it good. If I breathe in the future, breathe out the past. Yeah. Savor this moment as long as it lasts. Let me tell you. Put it back. Piece by piece. If you stayed over, I'd make it so sweet. I'll make you remember, baby, from your head to your feet. And if you go now, baby, we'll never know how it ends. Make it good. Make it good. Make it good. Make it good.
done, they agree that the sea is the best place to be. Wondrously free, they live happily. They know from the past, life simply doesn't last. So they live for today, for tomorrow they may not be able to walk in the skies. Sun slips into the horizon, moon reaches for the stars. Music is the healer, no matter who you are, no matter who you are. They walk in the sky, so near and so high. They stop and for none, and when they is done, they agree that the sea is the best place to be. Wondrously free, they live happily. They know from the past, life simply doesn't last. So they live for today, for tomorrow they may not be able to walk in the skies. Sun slips into the horizon, moon reaches for the stars. Music is the healer, no matter who you are, no matter who you are.
Hello. Hey. Hi, how are you? Good, perfect. So my name is Maximiliano. This is going to be the web meets the virtual and holographic worlds. First, who am I? Basically the one that is going to fight against your app. Okay? So please try to not get an app right now. So I'm a mobile web developer. I have been doing web since 1995. Right? I'm from Argentina. And I have been doing mobile stuff since 2001. I have been doing trainings on different companies, and I have written some books, right? Some original books, and I have some translations also. The latest books are High Performance Mobile Web, that is coming probably next week, and Programming the Mobile Web from O'Reilly Media. And questions, yes, please. I'm not sure if we are going to have time here, but anyway, I will be here the whole day, so if you have any questions, that's fine, or by Twitter if you are in the live streaming. So we're going to cover the new words that we have on the web, how the experience looks like, some APIs, some specs that we have right now that are useful for this, what we can do today, and the possible future and challenges that we have there. So in terms of the new world, so far, the web has always lived inside like a 2D rectangular box, right? Even from the beginning, okay? So I remember that. So my first time with the web was like 22 years ago with that browser. It was just like the rectangular area on the screen. Then we had the first window-based browser, our friend IE. Then we move into other square rectangular areas such as, in this case, WAP, the WML, and web browsers. Of course, we had the first iPhone. Okay, even the Google Glass had like a browser. And it was basically another rectangular area where your browser was rendered. So sometimes it's not rectangular, okay? But anyway, it's still there. The web is like trapped there. And it seems to be the time for free the web from that box, right? And now we have some abilities to do that. So in terms of the new worlds that we have today, we can think about the physical world. That's the world basically that we know, that we are living on. That means that we can now talk to different devices, IoT devices, right? Smart home devices from the web. This is starting right now, but now it's a world that we are getting into. We have, of course, virtual reality. You know what it is. And now we have mixed reality, or the holographic world, that is like mixing the real world, the physical world, with a virtual one, or with holograms around us. So in terms of modes that we have for getting into those worlds, we can have like the normal world, like, okay, we can be seated or we can be in any other mode anyway, but we are not moving ourselves. We are just like looking around us. We have room space mode. So for example, HTC Vive supports this feature where you can basically walk around the room. It's going to detect every movement that you have. It detects in your walls. It detects in everything. The same happens with the HoloLens. This is the HoloLens. So in this case, the HoloLens doesn't need any external device to make that thing. So it basically has some cameras that will search your environment and recognize the room where you are. Inside, I will show you some demos later. But probably you're thinking, we are web developers, right? So that has nothing to do with us. That's, I don't know, C++ code or even OpenGL or something like that, or even Unity. But, well, we have good news, because now we have specs. We have browsers that are there or are coming to these new worlds. So we will be able to do stuff from the web to these new worlds. You can say, hey, come on, it's useless, right? So who is going to browse the web using these devices? Well, let me tell you something. It's like the mobile web 10 years ago. So I was hearing basically the same thing. Who is going to browse the web from a mobile phone? It was like crazy. Who really wants to do that, right? That tiny screen. So probably we are in a similar situation here where some people are saying, hey, who is going to use this? But probably not in 10 years, probably in 2, 3 years, we will see more devices out there. It will be more common to like get into these experiences at one point. I'm not saying that the web will shift directly to these new worlds, but on some situations, it will be a good idea. What about VRML? I'm not sure if you have heard about that. you can say, hey, that's basically dead. VRML, Virtual Reality Markup Language. Sounds good, right? The thing is that was 20 years ago. I even remember a Yahoo version using VRML, right? The idea is that you were like walking inside like a shop or something like that. The problem is that it looked like this, right? It was 20 years ago. So it didn't work. Yeah, we are not talking about VRML anymore right now, because now we have different technologies. So now we have evolved, so now we have hardware, we have software, we have APIs to make things much better. In terms of the experiences that we have available right now, we can create flat web content, and that's basically what you're doing right now. So every web content that you have right now will work on the HoloLens, will work on any other VR device. It will work on, for example, the Rift, the Oculus Rift. But you can also create 3D worlds where you really perceive the 3D, right? Like on a 3D cinema. And on those situations, you are going to create games, you are going to create full immersive experiences. You can create 360 still or animated content, so probably you know that. For example, now on Facebook, you have a lot of 360 images or even videos, right? So you can do that if you use one of these devices. You're not going to see just a flat web content. You're going to move around that area. And in terms of how you're going to create those experiences, we have, again, the same problem of should we create apps or websites, right? And to be honest, I'm not sure that apps is going to be the way for the content. Probably it's going to be the way for most of the games. But in terms of content, I don't know, New York Times sometimes, for example, releases some kind of VR solutions that you can see. I mean, they're in the Middle East or something like that. They record some 360 videos there. They create an immersive experience. I don't want to install an app to see that experience, because then I want to see the experience from other newspaper. I need to install another app. And right now, it's working with apps. This is going to be like the web. If I want to see just one content that probably a friend is sharing on a social network, I don't want to install an app to see that content. Here I'm seeing a lot of advantages if progressive web apps will get into this space. Of course, we can create progressive web apps for some platforms right now that can take advantage of VR. Not on every VR platform, but that is also pretty cool. And we can mix this with also the physical web and Bluetooth beacons and many other stuff. So in terms of how we are going to use these apps or these websites or these web apps, so if you have never played with these solutions, there are different kind of human interfaces that are available. We have the gaze. That's probably the most used solution right now. That means that you will use your head movement to select things on the screen. So basically, you're moving your head, you are selecting things, just pointing with your head. You can use your voice, right? Now, for example, on the HoloLens, you have Cortana, right? On Samsung, you have also voice recognition systems, so it depends on the platform. You have touch controls, so in this case, the Gear VR, that is also from Oculus and Samsung. It has a panel at the right, so you can touch there, so that's another way to scroll, to have some gestures. The question is, can we recognize those gestures from JavaScript, for example? We have clickers, or remote controls. So the Oculus has one. That's the one you're seeing on the screen. I have another one. This is for the HoloLens. So these are basically Bluetooth clickers. So instead of just touching with my finger or instead of looking with my head, I can just have these things here in my finger and clicking in a different way. On some platforms, you have controllers, optional controllers. On some other one, like a HoloLens, I can use directly my body, mostly gestures with my hand, right? And I don't need to install anything on my body, right? Just a gesture with my hand. And even we can install a mouse and keyboard, Bluetooth mouse and keyboard. Of course, installing mouse and keyboard doesn't feel like something natural for virtual reality because I'm not seeing the keyboard, but it works for mixed reality, for example, with the HoloLens. So basically, we can be doing web development directly, right, from an augmented reality experience for a mixed reality experience. In terms of hardware, Oculus Rift, that needs Windows, mostly. HTC Vive, the cardboard. So this is the cardboard that you probably know. I have a lot of stuff here behind the scenes. So the cardboard can work with basically iOS, with any iPhone or any Android device. Of course, it's probably the simpler solution, but it's there, and you can do web content for the cardboard right now. But we'll see how in a couple of minutes. We have the GRVR. So the GRVR works with some high-end Samsung devices, such as the Galaxy S6 or the S7. There are 1 million users, more than 1 million users at least, or the GRVR. So you have a lot of people out there using the GRVR right now. LG has a new one, and there are also others as well. So these are virtual reality headsets that are connected to a computer, mostly on Windows right now, or to a phone. It can be an iPhone or Android. And then we have HoloLens as probably the most different device. I'm trying to get one from here. So basically, this is a Windows 10 running on my head. So I don't need to connect this to any computer. That's probably the biggest difference with the other devices in terms of where you're going to develop. In this case, you're going to install the app or the web app directly here, right? And this is a mixed reality solution. I will show you a video of how it works later. So in terms of the new worlds, right, we have virtual and mixed reality. We have also access to the physical world, so we can connect to Bluetooth devices. I can even talk with the lighting system, for example, with WebMidi. That's another API. There are different immersion modes, so I can be just placed in one spot. I can move over the area, right? Or I can have a mixed reality. There are different human interfaces controls that you need to be aware of when you are creating these kind of experiences. And of course, we have different devices out there, and probably in the next year, we will see much more. In terms of the user experience, so how does browsing the web using these devices looks like if you have never played with this? So for example, with the cardboard, okay, the simplest one, on iOS or Android, it can be Safari. On iOS, it can be Chrome. On Android, it can be Samsung Internet Browser or even Firefox. This is how it looks like. Probably you know this from like the Facebook native app, but this is a website, right? So you can move your phone around. This is not in VR mode yet. It's just using the accelerometer and gyroscope to recognize your position. And you can put your phone inside the cardboard, right? Oops, sorry, that was my clicker. Don't press the clicker more than you need. Like there, let's go there. So, oops, you don't want to see that. Huh? Okay, one more time. Don't use videos on conferences, right? Okay, do you want to see that? Come on, you can do that. There. So that's how it looks like when you put your phone inside the cardboard, right? And that will give you like the 3D experience and an immersive 360 experience. So that's for the cardboard, right? You can try that directly on your phone. If you don't have the cardboard, of course, you're going to see the double screen, but it's not going to make any sense. You need a cardboard for that. Then you have Samsung Internet Browser, right? That's the browser that is coming inside most Galaxy devices. And there is a version for the GRVR that is available in the Oculus store. So when you have this Samsung Gear VR, right, it's pre-installed, so you already have the browser there. So this is how it looks like when you put this on. Like there, right? This is like the menu, the Oculus menu. And when you're there, right, you move your head, and then you enter the browser, and this is how the browser looks like. Of course, now you are in a fully immersive virtual world, right? You can move around and see. It's like you're in a cinema or something like that. So far, the web is still a box. It's still a rectangle on the screen, a 2D flat surface. You can use your voice, you can type on the screen, and that's the Forward.js website. That was this morning, so the live stream was on. So you can get into a video, for example. I think the panel with Guillermo Rauch was there. You can go full screen, and when you go full screen, you can get into a 360 mode if that video is 360, right? Or you can change the mode into 2D, right? Or 2D but 360, or 3D and 360. There are different modes to do that, right? And you have the options to make it work properly. It depends on your content. And there are some specs we'll see those specs in a couple of minutes, that will let you define that information. So metadata, so in this case, sample, that browser will recognize which format to use. And then we have the HoloLens, right? This, again, was this morning at my hotel room, right? That's the start menu. I don't know what's happening with the videos. They're being paused. Okay? So you click with your finger, right? That's the window. That's Microsoft Edge. And you can walk around the room with that. I'm just using my finger. You can see all the 3D space being recognized, right? The room being recognized automatically. And that's Edge. And I can basically type a URL. I can use my voice and talk to Cortana, or I can use that thing there. I can use a clicker, or I can use a Bluetooth mouse too. I can take that window with me. That's a hologram. And basically, that hologram is floating, in this case, in my room, right, in the 3D space. So you need to try it, right? So even the experience is far better than when you see that on the video. That's how you scroll, okay? Oh, yeah, that's me there. Hi, me. I think, I don't remember if I tried the video anyway. But this is how you zoom in. That's kind of weird, right, having a zoom in tool, because if you want to zoom in, you can just walk into the window. You don't need to really zoom in. When you are wearing this, you just get there. And finally, I'm here looking behind the window, right? That's kind of cool to see behind the websites. I can open a new tab, and the cool part here is when you open a new tab, you can get that tab out of that window and create a new hologram, right? New window there. So for example, I can take Netflix to my bathroom. How cool is that? Huh? So then I can set Netflix there, and it's going to be there always. Now, later, if I go back with my HoloLens in my room, Netflix will be there because the device is recognizing each room, so it knows, oh, that's your bathroom, Netflix was there, right? So that's how it works. So that's the YouTube video. So you can see videos too as well there, but right now you don't have the full 360 experience, even if it's 360 video. So that's how it looks like from a user's point of view. Okay, so now let's talk about APIs and specs and what we can do, right, later in terms of frameworks that you have available. And if you want to start with this, okay, how can we do that? So in terms of APIs, we have WebVR. That seems like the most important API for this, but we also have Web Bluetooth and other APIs that are APIs that will help WebVR and Web Bluetooth to work with these new experiences. In terms of WebVR, you can verify or query about data about current capabilities. So you can, for example, detect if you have room scale. That means if the user can move in the room or not, because of course it's a cardboard, it's a different experience that is an HTC Vive or if it's a HoloLens. You can check pose, that's basically position, acceleration, right direction. You can get those values from JavaScript. You can verify the room scale data, so how big is the room, for example. And you can request VR mode. It's like the full screen API. So instead of full screen, you can request, okay, I want to go VR now. And when you go VR, you will ask the user to basically put the phone inside the headset if it's a phone-based VR system. There are today 2 versions of the API. There was a first draft of that API that was available for 2 years in the market, but now we have a final 1.0 version. So you will find examples on the web on both versions, so be careful. The last one is from, if I remember correctly, from March of this year. And the API 1.0 is optimized for WebGL content only, right? So if you want to do other kind of experiences with that, you need to do it yourself. So it's for WebVR only, at least right now. So WebGL. So WebVR works with WebGL. So this is quick code, just to understand how it looks like. So you can bind to some events that, for example, where the display was connected or disconnected or activated or deactivated. And then you ask for VR displays It's using promises, and you will get an array of displays, and you just take the first one. You can get display name. The post will give you different objects inside with position, acceleration, and so on. And you can get, for example, information about each eye when you have devices with that support. And with the state parameter size X, it's basically the room. You have X, Y, and Z. That's just a quick idea of how it looks like. So WebVR, it's basically to get information from these devices. That's all. So WebVR is not drawing on the screen, right? For that, you are going to use WebGL probably. So WebVR right now, it's on Firefox Developer Edition. It's on the last icon, by the way, if you don't recognize, that's the Samsung Internet Browser. So it works here in the Gear VR, but you need to enable the flag to make it work, the WebVR. On Chrome, it's coming on Chrome 54. If you want to try it now, there is a special build of Chrome for desktop and for Android that will support that. It seems like from 54, it will work on Android only. I mean, officially, that version. But fortunately for us, we have a polyfill, right? Using device motion and device orientation. Those are those APIs that are available right now, even on iOS. So with the polyfill, you can make it work on most of the browsers out there. So for example, it can work with iPhone and the Cardboard. So you can start using that API today. In terms of Bluetooth, right, you can say, okay, what's the deal with Bluetooth here? Well, if we are going to create an immersive experience, sometimes you're going to connect with some Bluetooth-based devices that you have around. They can be any kind of devices, right? IoT devices, the lights, right? Anything that you have at home or in the room, and you can talk to them using web Bluetooth. You can scan Bluetooth low-energy devices. You can scan the services that those devices are exposing. And you can connect to those services to send and receive data. That's basically how it works. It's a very experimental API, to be honest, right now. So in terms of the code, it looks weird because Bluetooth, it's complex in terms of how it works. So in this case, I'm using ES6 with arrow functions. So that's why it's not so weird, but it's even weirder without that. But basically, you request a device connection with a filter. So you ask which device do you want to get from the wireless network. You connect to the device, you get the service, right? You connect to one characteristic of that service, and then you start listening for data, for example, right? So you have a lot of code and demos out there, so you can just search for them. So unfortunately, web Bluetooth right now is, again, experimental. It's on Chrome only, but under a flag. So you need to go to Chrome flags and enable web Bluetooth, restart your phone. It can be Android or it can be desktop. So you can start playing with web Bluetooth right now. In terms of other APIs that will help us working with these new worlds, we have ambient light, and it says, okay, what's that? Well, let's see that. GameCAD and speech. And finally, web audio. So ambient light, it seems like it has nothing to do with VR or these new worlds, but it's to get info about current lighting conditions, right? You can try it. Right now, it's there. It's working on Chrome under flag. It's working on Firefox today. It's working on Edge. So it measures basically the lights around you. And this is pretty cool, not probably for VR, but for mixed reality, okay? Because our content can be different if there are too much light or if we are in a dark room, for example. So from an API point of view, it's really simple, right? Just a new event, and you will get the data, and that's all. And it's working on, it will work on Edge. It's working on Firefox, and it's working on Chrome under flag. The Gamepad API, it's useful if you want to connect with those clickers or the controllers, right, available for some of these VR devices. So you can get info about Gamepad and controllers available. The API is also pretty simple. You register an event listener, GameCAD connected, and then you get, for example, buttons. You can also get axis. You can get touch connection if the API supports that. That is not so common right now. So in terms of support, it's on Chrome, Firefox, Opera, and Edge. But if you want to get touch and pose is acceleration, for example, how fast I am doing this. And touch is because some of these controllers on, for example, the HTC Vive, they have a touch interface inside. Unfortunately, it's not there yet, so you can use the same build of Google Chrome that supports WebVR is supporting this extension to the Gamepad API. So if you have an HTC Vive and you download that build, you can try this, right? You can have like the full WebVR experience even with the controls. Then you have a speech that has like 2 versions, synthesis and recognition. The synthesis part works on most browsers out there, and the recognition not. But it lets us interact with the user with the voice, because when we are in a VR environment, that's probably a good idea in both ways, right? To talk to the user, so our website, our content can say something to the user, or to receive actions from the user. So the synthesis let the web speak, and the recognition part let the web listen to the user. So this is how it looks like. This is how you speak, right? You create an object, you set some variables there, and then you say speak. That's all, right? You can try that directly, even on iPhone, right? Even on Safari on iOS. To recognize, it's not so complex, right? You set a new speech recognition. You also set some properties there. And finally, you listen to the result event that will send you the text, the transcript text, right, automatically. And you get the text and with a percentage of confidence. It seems like the user is saying the thing. So today, speech synthesis has like pretty good compatibility. The recognition is just Chromium, so that means Chrome and Opera, for example, Opera on Android. And finally, web audio is because when you are in a VR environment, right, or even when you are in a mixed reality with a HoloLens, right, you want to use audio, and probably audio that will work in the space. So if I have a hologram talking to me there, I should listen that it's there, right? So that's the whole idea of using web audio. It's a well-known API today to generate dynamic audio. We can create 3D audio, so that means spatial the audio. So basically, it will work really great with, for example, HoloLens. And you can also use this to communicate with other devices. This is pretty cool. There are some pretty cool solutions out there that it will let you like send even ultrasound messages from one device to another device that is in the same room. And in terms of 3D audio, this is the solution, right, that I recommend. It's a new one. It's an open source solution from Google, right, Omnitone. It's based on web audio. And the idea is like bring these kind of new experiences in terms of audio on the web. And web audio is available everywhere, right? So that's good news. So in terms of API, right, we have WebVR, Web Bluetooth, other APIs, and that will let us communicate with these devices and with the physical things that we have around. Let's talk about what we can do today. So far we have been talking about devices, about how the experience looks like. And so if you want to start doing something right now, so you can create flat content. That's basically what you're doing right now. 360 content, VR, full 3D experiences, or even holographic experiences. For flat content, it's just a normal website, right? So any website will work on VR or in the HoloLens. But we are still in that 2D box, right? But that box is inside a 3D environment. It's like a frame that you have hanging right in the air. For 360 content, right, you can use device orientation or touch and mouse, right, to move that image, right, and create the experience of 3D or 360 even without a device. That's what, for example, the Facebook application is doing on desktop. Or you can use something like this, VR View from Google, right? So if you use, it's an open source solution, right, that it's a viewer that is basically using these device orientation events, and they're using VR solution. If you are in a compatible browser, you just create an iframe, right, with the URL of your image, some other metadata that you can set up. And then when you get there, right, you will see something like that. And if you put a cardboard or a Gear VR, right, you will get like finally that experience. So that's VR View, right, something that you can use today even if you don't have JavaScript experience, right? Just adding that iframe and that's all. There is also Visor Editor. It's also a pretty cool tool. If you go there, visor.io, you will have an editor that you can just start creating your 3D environment pretty simple. And if you already have a 360 image, you just drop and drag that image and it will create the 3D experience for you. In terms of video, right? So I mentioned before that when you're using the video element for the Samsung Gear VR with more than 1 million users right now, you can use this extension of HTML5 video known as dimension type, and you define exactly what kind of video do you have. There are different types available, right, that you define directly in the type, like after the MIME type. So you can say if it's a side-by-side 3D video, it's a 360 video, right, or if it's just a normal video. So basically, the browser will start the write mode automatically. To capture 360 content, right, so you can use hardware, special cameras that are around. So here I have, for example, the Theta one. So for example, I can take a 360 picture right now, a smile, right, and we can post that later. In fact, from this camera, I can take another one. Right? I can also stream. So we can do 360 live streaming with this. But unfortunately, the live streaming in 360 is not working right now for most of these browsers. So the only way to make it work right now is to stream through YouTube. And in that case, the user will need to probably use the YouTube native app, today at least. Okay, in terms of web, streaming 360 live content doesn't seem like possible today, at least. Okay, this is probably changing quickly. Also, if you have an Android device, you can install the Carver Camera app from Google, right, that will let you create also manually, right, these 360 experiences. And then there is an online camera converter. So you need to use a special type of JPEG file. It's just a JPEG file with some specific sizes. And after you use this app, you just drop that image here, and it will give you the final JPEG file that you're going to use inside your web content. For VR 3D experiences, it's mostly WebGL. So if you want to do that right now, it's mostly WebGL. But fortunately, there are a couple of really good frameworks if you don't know WebGL, or if you don't want to play with that right now. For example, A-Frame, right? It's an excellent tool that will let you use a markup. It's like web components for VR. So it looks like this, very simple, right? That's an HTML. And inside the HTML, you set a scene, and then you set different elements with different properties in that 3D scene, and that will generate basically a VR experience automatically for you, with even support for WebVR on Cardboard, right, on any other device. Also, you have 3GS that has VR support, right? It's pretty simple to use API for creating 3D content, and it has WebVR support. And in terms of holographic experiences, can we create holographic experiences right now? So let's talk first about the HoloLens. Let me show you how a hologram looks like in terms of 3D. That's, again, my hotel room. So that's a satellite there. You can see that I have a ballerina also there, and I can see the ballerina from every angle. Yeah, that angle too. And basically, that's pretty cool, right? You can set these 3D holograms around your space. But this is just, for now at least, just native, right? We cannot do this from the web, at least today, right? So probably we still need that part, probably an update. However, we do have something that we can do today that is pretty similar to that idea, right? AltSpace VR, it's like a social network on VR. It's available on different solutions. It's a native app. Okay, so it's a native app, a native social network, but they have an SDK. And with the SDK, right, you can use 3JS applications. You can write 3JS. So here, that's not me, that's from YouTube. Someone is basically writing code inside a VR environment, right? That's CodePen. And when you run it, you can see that 3D box being animated in 3D in your environment. So now that web content is out. It's a hologram that is out of your 2D box. So that's how it will look like also on HoloLens when we get that. And by the way, you can talk to other guys that are in the same room as well. Well, anyway. So today, we can create flat 2D experiences, 360 experiences, or fully 3D. And holographic experiences, probably it's more for the future. And that's the last part, the future. So first, we will have new devices. Google has came with Daydream in the last Google I/O. Daydream is a spec for devices and headsets for the near future. So we will have Daydream-compatible phones and Daydream-compatible headsets. So in the future, probably most of the Android devices or mid and high-end devices will be Daydream compatible. That means that most of them will be able to have VR inside. But I would like to talk to you about challenges more than devices. For example, pixels. What do they mean now? Right? If I say 100 pixels, what is that in a VR environment, right? In fact, we need to think how we think about bitmaps. So look at this. So that's the one of the halls in my hotel, right? I have a window that is far away. So if I can't read that, I can just walk in, right, and get that information. So the question is, what is a pixel there? What is a pixel? So 100 pixels, what's that? So we also need to think how we define bitmaps. There is a concept that we can create responsive images based on distance, that is usually known as mipmaps on VR. That means that, okay, if the content is far away, probably we should use a very low resolution image because I'm not seeing that thing, right? And while I'm walking there, I should probably change that image with a better one. And there is a new format, I'm not sure if you have heard about that, right? Google that, FLIF. That is pretty cool, and it can be used for this. So on FLIF, you can deliver the same image in different resolutions, but in the same file. So basically, you can stop downloading that image at one point, and you will get the very low resolution image. If you continue with more bytes, right, you get the mid resolution and then a high resolution. So these new formats will be probably most useful, more useful for these kind of new experiences. And that's an idea, right? So we can have something like media queries for this. Okay, if the user is far away, probably want to change how that web looks like. Or if the user is within 1.5 meters, well, I'm sorry, I'm from Argentina, I use meters, so if you want, we can change it, right? But anyway, it's something new, so we have new challenges. We will have new challenges when we are doing responsive web design, right, and web design directly. Even we can have a viewer direction, so if the user is, so if this is a website, so if the user is looking at this directly in front or from an angle, right, or from here, right, and we can change, for example, what we are looking based on that, right, like an angle, a direction, and so we can emulate a window. I can pick what's inside that window. That's something that you can do with holograms today, but not with web content, because we don't have events or data coming from these new sensors, these 3D environments. Then what about the viewport? So if I increase a virtual window, like a hologram, what do I want? Do I want to see the same but bigger, or do I want to increase the viewport? So it's like having an iPhone and stretching the iPhone. Now I have an iPad, right? So if you look at the HoloLens, right, I can adjust the window as much as I want. I can make it wider, larger, right? I can make it bigger. I can make it smaller, as big or as small as I want, okay? So we need to think about that. Now, probably it's too small. Should it be like the mobile site because it's too small, right? Physically on the screen, so we don't know. So new challenges that we have. Also augmented reality and let's say new Google glasses, probably not from Google. You should check LaForge Optical. So they're coming probably next week. And using Web Bluetooth, we can probably connect to devices around us. And we will probably need much more from Edge and Windows right now. So Edge on the HoloLens, it's just a flat right area on the screen. For example, on Edge, we don't have WebVR support. So that's probably something that we need. So on the future, we will have definitely more challenges. Daydream might increase usage from next year. And we will start thinking about responsive VR. So that means we need to create an app, a VR content that should work everywhere. Right? On cardboard, it should work even on desktop with the mouse if you want. So it should work everywhere. So we will have really hard work. So we have seen the new words, how the experience looks like, the APIs, what we can do today in terms of frameworks and things if you want to do some VR right now, and the future. So as you can see, we have exciting times for the web, and that's all perfectly on time. Thank you. And you have my Twitter account for wherever you want, anyway.
But I guess you got to know. Didn't mean to tell you, but I guess you got to know.
You will find each time you listen to this recording that you relax deeper and deeper.
Welcome everyone to the animation panel at Forward.js 2016. Woo! Woohoo! So I have an awesome panel here. Unfortunately, we are missing Sarah and Rachel. Sarah had a small health issue she's recovering from, and Rachel couldn't make it either. But we still have some awesome panelists here. I'm going to have them introduce themselves, specifically with the question of how you got started with animation, and share some of the things that made you passionate about this and your early experiences with them.
Should I go first? You go first. Okay, my name is Estelle Weil, and I work at a company called Instart Logic, and we do performance. And I've been doing animation since the spec was first supported in WebKit. In 2007, in June, the iPhone came out. A week later, I had created at a hackathon a little widget. It was like Twitter and MLB, which is Major League Baseball. I knew nothing about baseball. I learned something about baseball, and I created the box score, which, but the players would like animate down onto, we had this little rectangle called something sports related, but I don't remember the name. It was basically a sports ball app, and it was the funnest thing to create in the world. And then in 2010, I worked at Apple as a subcontractor. And my job was to create videos when there was basically no supported video player, or the video player wasn't that well supported, but it was interactive ads without using Flash. And so my job was to animate for a single browser. It was the best job ever. So I basically played all day with animations back in 2010. And last month, or in May, this came out. It says Transitions and Animations in CSS. It's a chapter of the CSS, the Definitive Guide. If you ever have insomnia, I realize that you all are here because you're interested in animation, but if you ever have insomnia, this will still put you to sleep. But it has every single quirk. You know, like if you put an animation, the same animation name multiple times, what happens? That kind of nitty-gritty. So it's a pretty good resource.
Hi, I'm Swizats, and I work for a company called Yup. And I actually need front-end engineers, so if anyone needs a job, ping me after the workshop, after the panel, not workshop. Workshop was yesterday. Anyway, I actually am very, very new to animation. I don't think I've ever made a CSS animation before, but I've been playing with JavaScript animations recently, and I found that React is surprisingly good at giving you a game loop that you can do complex animations with. And it actually, if you try hard enough, it's fast enough to animate, I think, 15,000 elements on a phone.
Awesome. So something we'll talk about for sure is mobile, because there are certain restrictions there that have to do with the format of the phone, right? There are some gestures that are inherent to the user agent. You can't do everything that you could do with a native application, or maybe you don't want to do everything you do with a native application. But before we get there, let's walk through the entire process of how you look at animation, how you spec out animation before you sit down and code it with CSS or JavaScript. What are the best tools to envision what it's going to look like before you get to play with it? Or do you have an approach where you get your hands dirty? I tend to browse CodePen and copy and paste a lot, which is a good idea as well. So tell us about how you look at this.
This is going to be an interesting panel because we have two completely different perspectives. Yep. He's JavaScript, I'm CSS. He's like, let's animate 15,000 elements. I'm like, let's animate none. So my favorite tool is Sublime, and I hand code an animation, and then, or I do it in CodePen, and I watch it, and I go, wow, that's too much. Let me take away 16 features and make it really subtle. So I actually just prototype directly. I don't have any tools other than something like CodePen so that I can see it right away.
Yeah, I also actually do a lot of copy-paste programming. I think it's the quickest way to get started with something, and it's also great for getting ideas, but then usually the way I think about animation is I just kind of try to visualize it in my head, what it's going to look like, and then I first just start prototyping, I guess. But I use Emacs. I don't know if anyone here uses Emacs. Are we allowed to ask questions of the audience?
We're not. Sorry, just kidding. No, we certainly are. And if at any point you all have questions about animation or gotchas that you've encountered, like you were mentioning animation name, and what happens if you said the same one? Something I've encountered is restarting an animation that's ongoing because that user action comes later on. So like you were fading out a notification and you have to restart that. I found some gotchas with CSS when it comes to that. Like, what are other gotchas that you've encountered, and how do you solve them on a day-to-day basis?
So I've encountered almost every single gotcha because I tried to encounter every single gotcha. So you're probably not going to encounter some of the gotchas, but one of them is if you are in the middle of an animation or transition, let's say. So this is actually more of a transition gotcha. If you're in the middle of a transition and it reverses direction, some of the animations will, how long will it take to reverse the animation? The animation is actually in the reverse direction, supposed to wait the delay. So if you have a 17-second delay on something, and then it's supposed to be 2 seconds, and after 1 second you remove your mouse, it is supposed to wait the 17 seconds before going in the reverse direction. And then some will go in the reverse direction over 2 seconds, and some will go over 1 second, whatever was left. So that's a gotcha. And I could open up this book and find out which browser it was, because that's the kind of crap I don't think worth memorizing ever.
And how about in the React world where we have this render loop that gets called time and time again, and then we need a declarative way of specifying animations. What are some of the difficulties with that model?
Well, the difficult thing with doing declarative animations is that it's very easy to do complex animations where you, on every frame, you just re-render and change some properties, and apparently...
Like a position of an object.
Yeah, you don't have to really think about it that much. If you change X 60 times per second, it looks like an animation, and it's actually fast enough. But then when you do transitions, it becomes really difficult. So in the React world, strangely, it's harder to do simple animations than to do complex animations.
In the React world, you can still use CSS.
Yeah, you could, but then I would have to learn CSS.
There was a tweet yesterday. CSS is like riding a bicycle that's on fire, and the ground's on fire, and everything's on fire because CSS is hell.
Yep. Yeah, that sounds very familiar. Yeah.
So my next question would be along the lines of, you mentioned 60 frames per second performance. So what are the difficulties that you've encountered with, you plan this animation and you test it out, it works really well on your computer, but later on it doesn't work well on a mobile device. So what are some recommendations or guidelines that you follow when it comes to performance?
So I'm very lucky that I test most of my code on a new MacBook with 16 gigabytes of RAM and infinite cores. But then I sometimes open my phone and nothing works, just like you said. And so really the best thing to do is to try to reduce what you're actually animating. So what I do is I try to take cues from the gaming world, from making video games, where if something isn't seen, you just take it out. If something is covered by something else, you try not to render it. Most work goes into removing elements from the page. So you're animating less stuff. I don't know how useful that is in most cases, but when you're doing toy animations where you're just experimenting, it's a very useful tip.
How much time do you spend looking at the timeline pane of Web Inspector to understand, okay, the DOM is being changed too often, or I'm spending too much time recalculating layout? Or do you go more on a experimental basis where, if it just feels smooth as butter, you go with it? Any of you can answer that.
Yeah, I've only recently discovered that the inspector can do profiling. And I usually do a lot of guessing and trying things out. And there's some general guidelines. Like if you have a lot of elements, try using Canvas instead of SVG. if you're making a new copy of a 30,000 element array every frame, maybe you shouldn't.
Right. You mentioned in terms of number of elements being animated at a single time, something that we always have to pay attention to is if a certain animation is being GPU enabled or GPU accelerated or not. So can you share some of the guidelines there?
So I guess back to how many DOM nodes you have, the number of DOM nodes you have, basically when you repaint, when you reflow the page, it has to measure every single DOM node. So when you're using React or some framework that is, a lot of people will, some people know how to use React, and they create the code that they want to see presented, and other people want to use frameworks and don't actually know or care what the code is that they're producing, and that's where the problem are. So I don't normally animate several elements because I'm not, like the games that I create are like, here's a card, let's flip it. That's two elements, I mean, it looks like 2 elements, but it's actually 6 because there's the back, the front, and the div around it. Wow. So you can animate 6 divs at the same time using, you know, well, here it's flipping it, so obviously you have to use a transform, which is on the GPU. But even if you were doing a left on 6 elements, you could probably get away with 60 frames per second in that world.
Yeah, for example, I was referring to, you tend to not want to animate properties like margin. Instead, you try to translate the element. Something that's interesting that's happened recently is Servo has actually made a lot of optimizations to perform most of the CSS work on the GPU, which means some of those guidelines, like don't animate height, don't animate margin, could actually change in the future. In the same way that with HTTP2, we don't worry so much now about bundling your JS and CSS because the transport optimizes for it. I think a good guideline to keep in mind is some of this performance guidelines for animation are also subject to the understanding of what the engine is doing, what the framework is doing, and if you're not paying attention to those, you might be, you know, misusing some of these best practices. My next question has to do also with, you know, you're mentioning, well, I'll just animate fewer elements, and that reminds me of sometimes animation can be overused, right? So when it comes to user experience and UI, what are your like general recommendations on when to use animation, when not to use animation? Sometimes just presenting the content without any bells and whistles is actually better, right?
So like if I'm developing a client's website, I first do it statically. You know, I prototype the whole thing statically, and then, you know, the UI is like, well, I could add a transition here, so when it opens, it takes 200 milliseconds. And 200 milliseconds is a good amount to take, because if an animation is noticeable, then you're kind of defeating the purpose. You know, it's no longer fast. If it's noticeable, it's not fast. So those are the types of animations that I do 99% of the time. But the thing that I do is I first make it static. I mean, not static, but no transitions. And then this is what IE6 gets. I mean, it works. And obviously, no one's still programming in IE6. But if your JavaScript doesn't load, or if your JavaScript is thrashing, like you have so many lines of JavaScript that you're thrashing the main thread, you know, you don't have JavaScript.
Not adding extra work.
Yeah.
That's a good guideline.
So it's basically, you know, animation should be a progressive enhancement in a website. If you're doing a game, it's the gist of it, and you really need to think about performance. I mean, you need to think about performance all the time, but you really want subtlety 99% of the time. If you're doing a game, you don't want subtlety. And sometimes you want something to wiggle over here because you actually want their eye to go over there. So you don't want subtlety. But you don't want something wiggling all over here. We just put out this game. At my company, we're trying to build a database or a data set that computer scientists can use. So we have this game out right now at Speed Perception. I guess it's speedperception.com. And there's 21 sets of videos. There's 2 videos at the same time, and they're both loading. And then you say, which one did you perceive was faster? And when people have animated GIFs on the homepage, I actually feel like what I was noticing when I was playing this game, it's not really a fun game, but please play it because we actually want as many people to
Can
play
you
it.
say the URL again?
It's speedperception.com or .org. And it redirects to an AppSpot app. But we're basically trying to create a data set. So please do it because the more people do it, the better our data set will be. But the reason I brought this up is when someone has a pop-up after 2 seconds of load, it actually feels like it hadn't finished loading. And it makes me feel like the site is slow. When someone does an ad that is animating, it makes it feel like it's slow.
That's fascinating. It reminds me of this other study that I read that if your app uses spinners that have been designed by the app themselves, like they're custom spinners, people will tend to blame the loading time on the app, like the app is slow. But if you use the operating system spinner, it's Apple's fault. So that's a pro tip. So do you have any...
Yeah, I wanted to say that on your point of subtlety, I actually really like that in recent years, web developers and designers have started using less animation than they did when the animation spec first came out. Because I remember a couple of years ago, everything was just bouncing everywhere and buttons were rotating and stuff. And I'm really happy that people don't do that anymore. It's
yeah,
annoying.
I think one of the, to your point, one of the advantages of animation, you mentioned 200 milliseconds. That's about the time that you want your backend to respond. There are obviously some thresholds for attention and what are the thresholds that people consider instant, etc. So masking network latency is a great use case for animation. If you know you have a very expensive backend long-running task, you want to perhaps use more animation. But if everything on the backend is immediate and you force a 500 millisecond animation between every action, you're doing yourself a disservice.
Can I add something to that, though? Because one of the things, when you said a gotcha, one of the gotchas with animation is it is the lowest priority on the UI thread. So if you're doing something with JavaScript and you're actually doing it on the main thread and not using a service worker or like a background thread, and it's not on the server, if you're using the main thread for whatever you're doing, the animation will actually not hit 60 frames per second because it will.
Because it has lower priority.
That's a major gotcha.
I also think a lot about how CSS made this idea of animating so much more accessible, easy to share, easy to inspect. You see a cool animation anywhere, you can just right-click, inspect, see what easing function they're using, see what it looks like, what properties they're animating. So when it comes to I think syntax is a really big deal. It really just either makes it approachable or not approachable at all. So what are the things that, do you all use any transpilers like that allow you to like chain animations more easily, like Sass to less to CSS, or do you wish for syntactic evolution of CSS when it comes to animation? What do you look to in the future?
Sublime, vanilla, CSS. I'm a little bit quirky. I like to get my hands dirty, and that's why I write these boring books, because I like to actually get my hands dirty and write myself and fully understand it. So I'll use Sass, for my variables, and I'll use Sass to manage my CSS. Like I have, keyframe _keyframes.scss where I keep all my keyframes, and then that might just actually pull in my various animations, but I actually hand write all the animations. And in terms of, having one animation come right after another one, that's also a gotcha. So if you say, like on page load, you have an animation that you want one animation that's 2 seconds, and then you want the second one to start right after the first one finishes. If you say animation delay on the second one of 2 seconds, and the page loaded, but it was still parsing and executing the JavaScript, so it didn't start right away, the 2-second delay will expire. So if it takes more than 2 seconds, that will expire, and then you'll have both animations starting at the same time. Wow. So my solution to that is on page load, changing the class of the page to can animate and basing it on that, or using on animation end, attaching an animation name to the element.
So you use JavaScript merely to orchestrate that flow of animations.
Yes.
Cool. On that point, I think what would be great is if we had better developer tools for animations. Because I remember in the Flash days like a while ago, you had this system where you could develop tweens by saying start here, then go there, and then do this and that, and it would calculate its own stuff. It would be really cool to have a tool like that, but that generates CSS animation syntax stuff.
So there is the animations API,
Mhm.
and I don't think it's well supported at all. I don't know if it's in any browsers. And so what's cool about that is it basically uses exactly the same syntax as CSS. So if you learn CSS animations, you learn 90% of the Web Animations API. The only thing is the Web Animations API is actually purely JavaScript.
Oh, cool.
So you can do the calculation. So if you actually want something to go over here, and then the third time actually, curve like this, you can control it. But what I prefer is actually just doing, let's attach this animation, and when the animation end happens, then attach a new animation, because then you have all your animations in one place, and I prefer, and that's actually supported already. So
cool. So we'll also touch on this idea of how do we get better tools, but how do we also make it easier for someone who's getting started with animation? What are the main recommendations for resources and ideas and tests they can do, and general advice?
that's interesting about doing like test-driven development when it comes to animation, because I actually have never thought, I'm naughty, I don't test enough. There's tons of tutorials out there on basic animation. I think there was one where, oh no, that was a Flexbox one. We have like a frog. I did a talk in 2010 called Making It Snow, and if anyone doesn't know basic animations, I make it snow in San Francisco without JavaScript. It's a page that's blue and lighter blue, and there's snowflakes that come down, and it goes through the process, and it's old. It's the same stuff. It hasn't changed. So there's hundreds of tutorials. There's lots of little books. And then there's CodePen. Just go to CodePen, type in some stuff, and play with it, and it'll be live for you right away.
How about for someone that's moving to a framework like React, where the approach is sort of opposite, it's not imperative animation definitions or event callbacks that you invoke more code? What are the best practices for someone that's using React?
So it's still kind of hard to get started. The basic concepts are simple, but I think it's easier to do tests for it, because you can test your logic for doing animation separately from the actual rendering. But I think the main test for animation is still just looking at it and seeing that it's good.
Do you use CSS Transition Group?
There's something called React Transition Group, which is like a subset. I think it's lower on the spec than the CSS stuff, and it gives you basically more control about what's happening.
And there is React Motion as well. Have you played with that?
React Motion it's a cool library. I've tried it. It doesn't work with thousands of elements, unfortunately. And it actually uses CSS, I think, transitions to do the animations. And it's really cool. It works well.
Can I ask a question? When would you use thousands of elements?
When would you use what?
Like
React Motion.
Right,
what are the scenarios where you found the
Right.
bottleneck is in how many elements you're animating concurrently?
The bottleneck is when you try to see how many elements you can animate concurrently.
It's for tests primarily.
No, but I think if you're trying to develop a game, you can very quickly get to a state where you're animating thousands of elements. But please don't do that on a website. On websites, do what Estelle said. Try to animate as few things as possible. But when you're making a game, you can very quickly develop a world that has a lot of moving parts, a lot of things that have to move. And it can become a bottleneck. But then, no, actually, it's only a bottleneck when you try
Something
to push
to
it as
consider
hard
as
as
well
possible.
is you can combine these techniques.
Yeah.
So, for example, recently I added a plugin to my terminal for doing particle effects. So instead of rendering the particles as DOM elements, I layered a canvas that covered the entire screen in front of your terminal. And then I calculated the coordinates of the caret. and then the particles are drawn around on this transparent canvas that's in front by only querying the coordinates of that caret DOM element. So these techniques you can plug and play, no pun intended. And
can I add one thing? Sarah was unable to make it here, but she would be giving a huge plug to greensock.io. What, anyone use GreenSock?
I haven't.
No, I haven't.
So if you want to do animation, look at GreenSock. I've never used it, but if anyone has ever seen Sarah's work, it's just amazing. And she uses GreenSock to help her animate.
Something that's also on my to-do list to check out is Framer, because like I mentioned earlier, something that's difficult with animation is like you have an idea for a really cool animation. Sometimes it takes a lot of work to actually make it work.
Mm-hmm.
But if there are tools where it's much easier to design the animation and play with it before you actually write it, so that you can sort of test it like a lab test. So Framer is one of those tools that enables that sort of workflow. And we're trying it out now for Hyperterm because we're animating our notifications, and we're like, maybe we can collapse them, maybe we can extend them to take up less real estate of the screen, and Framer is a promising tool to accomplish that. So if anyone has any questions, please raise your hand, and we can have the panelists answer them.
I have a question. There's one over there.
Oh. Did people hear him? He basically said if you use shaders and you have basically, you put all of your, let's just say JPEGs or PNGs onto the GPU, you'll actually run out of GPU memory. And so sometimes the CPU is better. And I have a similar story to that. When I was at Apple, I was animating a runway show. So there were different JPEGs of women walking down the runway, you know, and it was basically a flash, and then the next one would come, a flash, the next one would come. And just in case the image didn't load, the background was an image of the stage with an inset shadow that was 46 pixels wide. So this is 2010, and browsers have improved since then, but I got a beach ball on my phone. Actually, no, on the phone, on the iPhone 4, which is what we were using at the time, it just crashed. So on my desktop, which had 8 or 16 gigs, I was getting the beach ball. So I spent 6 hours debugging my JavaScript, and finally I said, okay, there's an infinite loop somewhere, I don't know where it is, and I pulled out all the JS, and I still had the beach ball. And what happened was I had 3 JPEGs on top of each other. One had an inset shadow on it. The browser at the time, and I don't know if the browsers still do this, but it was painting, it was calculating what that inset shadow would be, and then painting the image, painting the inset shadow, painting the other image, and painting my animation on top of it, trying to do that within 16 milliseconds, and failing miserably. And so I was getting that beach ball. So sometimes people think that to put everything on the GPU, you know, the GPU is faster, so let's just do a little star hack and go star transform z-index 1 or whatever, or 0, and that puts everything on the GPU. It does indeed put everything on the GPU, but when you put something on the GPU, it actually uses, I think, 4 times the amount of memory of the GPU. So you are going to run out of memory there, basically.
That seems, is that intentional? Is that, because it seems like a very big design flaw that rendering graphics on a GPU would take more memory than doing it on CPU.
Well, there's always the transfer time also to the GPU, the copy time that you're concerned about. And there are 2 parts to that as well. So shaders, CSS, there was a CSS shaders spec being pushed by Adobe at one point.
Is that the filters? Yeah.
Yeah, that would allow you to add programmatic filters. So, for example, you could like map a div that had a lot of text and then animate it and like make it like a paper that's being collapsed or folded, and the text would be still selectable, for example. But that didn't seem to get a lot of traction because to me it was really exciting because what you're doing essentially is elements on the DOM are no longer rects. You could, for example, make text flow around a circular shape and then change it with a WebGL shader, for example, but that didn't seem to get a lot of traction. So the other thing about like performance and like saturating GPU buffers is you have to consider the limits of each device that you're working with. So sometimes the performance advantages of the GPU can also have the drawback of saturating those limits or spending way too much time passing them from the main thread to the GPU. So those are things to consider as well. And going back to the tooling, visualizing this and understanding these limits better is definitely somewhere where we need a lot of improvement, I think. Does anyone have another question? It's hard with the bright lights.
To go on a little bit with the shaders, so there's also like CSS filters, and I've never tried to animate these filters because I can't imagine. I never tested their performance, but just the idea of it goes, oh my God, the performance must be terrible. But you can do like WebKit -WebKit -filter :sepia and actually make your JPEG sepia colored or black and white.
I try to animate blur,
yeah,
which is a really cool effect that you can do. For example, like when you're loading something progressively, what we try to do for the VideoPress player, you would have the ability to share a video before it's done converting. So you upload it and like the upload completes, but then it needs to be transcoded. So what we did is we would show a progress bar, and as the progress bar went from 0 to 100, we would reduce the blur. Like the data is coming in, and like this effect that there's now more visibility. And we did run into a lot of issues trying to animate filters. So we just relied on JavaScript updating that filter value over time. And since it wasn't happening too frequently, we could afford the performance penalty. And it was an effect that was semantically meaningful to the user, which is the user is understanding that more data is coming in and there's progress being made. So
I did also totally not animation related, but you were talking about basically the text not being in shapes. I gave a talk here last year. For some reason, I speak at every forward except for the first one. And 2 times ago, the title of the talk was CSS WTF, which can mean what you think are just wonderfully terrific features. And one of the features I showed was using shapes. So you can actually like draw a circle or a rectangle or a polygon and say, wrap the text on the outside of that. So if anyone is interested in doing text that flows around a drawing, you can do that with CSS shapes.
Would you ever use that on an actual website?
Yes.
Cool. 'Cause I haven't really seen that in the wild a lot.
Okay.
I've seen it in examples.
So if the page doesn't load, is it okay that we not get off animations? Because
it's wonderful.
Okay. So let's say you have a floated image to the left. That's what IE6 will get. And I just say IE6 as in any old browser, I don't care which one. You floated the image to the left, and the text wraps around that. In a modern browser that understands shapes, you could actually look at that image and say, it really is a circle, so let me clip the path into this shape of a circle. And so that image now has the shape of a circle, and the text will basically come in like this. So if your browser isn't supporting it, it might be there and you just don't see it because it's a rectangle. But if the browser supports it, hey, it looks really awesome.
Yeah, I can imagine.
And with CSS shaders, the promise is or was that you could even, for example, wrap text around a 3D sphere, for example, while being able to select it and animate it. So this might still be possible in the future with CSS Houdini, because they're exposing the lower level constructs of CSS and rendering and painting for JavaScript developers to access directly. So I think that opens a whole new spectrum of possibility when it comes to layout and animation as well.
I just want to say one thing. these are great ideas for CodePen, but some of these ideas, if you actually put them on a website, you should be shot. I mean, or
I
fired.
think what happened as well is with the skeuomorphic versus flat trends. Adobe at the time was showcasing a lot of examples that looked like the physical world. So for example, animations where you would fold pages. So iBook on the iPad has this cool like book, or used to have this cool like book-like stuff that we couldn't really do with CSS because we couldn't like fold a page and like map text around it, etc.
Do you know how they were doing it then? How were they doing it then? How were they?
Oh,
they
natively, of course, they
Okay.
could. With the CSS shaders spec that they had an initial implementation for, they could do demos like that. But I think the trend then moved away from that to a lot of simplicity. So with flat design, we're now using a lot less animation than we initially got excited about, and we're using much simpler layout models that have a performance advantage, that have a user friendliness advantage. So that seems to be the state of affairs nowadays. I think we have time for one last question, if anyone feels so inclined.
If anyone really likes me, I'm doing the next section in here, and it's going to be on accessibility and performance.
Okay, and the last thing is get transitions and animations in CSS at O'Reilly.com. If you use the coupon code, is there a coupon code? If you use the coupon code RouchG, it'll get rejected and it'll be the full price. So thank you so much, and you'll be able to talk to the panelists later on if you have any other questions. Thank you.
Thanks. We good? Hello. I'm louder than you are. My name is Estelle Weil, and this is a talk about inclusive code. The slides are up at instartlogic.github.io/p/inclusive markup. Basically, just remember the company name, InstartLogic, and go to the GitHub page. And these slides will be up in a similar version. They're probably going to be updated a little bit over time, but 90% of it will stay the same. So a little bit about me. My name's Estelle Weil. I don't know why my name isn't showing up. Oh, because it's there. And I blog at Standardista, and I also blog on my company blog called instartlogic.com/blog. I'm a Twitter whore. I have actually 5 accounts, but I'm only putting up 3 because 2 of them I ignore completely. If you want to reach me, follow me at EstelleVW. It's much faster than email or anything else. And the reason I speak at conferences is because I like to know I have friends and followers. And then I've written some books, including this one that came out last month, and Flexbox book, which is part of the CSS Definitive Guide, should be coming out next month. That's what I do in my spare time. In my real time, I work at this company called InstartLogic. We are a performance a performance service, and we make it really easy for you to make your websites or web applications or native applications fast, secure, and easy to operate in terms of you're responsible for your own UX, but we will make it easy to get it to the user faster. One of the things we do is JS and HTML streaming. So what I'm going to talk to you about today is how to write in a performant manner. So you won't need our service, but since most of you won't listen to me, you might want to check us out. So what I'm going to talk about today is accessibility and performance done simply by using web standards. So you all know that performance is important. You all know that accessibility is important. You've been given some prescriptions as to how to make these things happen. I worked on this website where it was really important for it to be accessible and really important for it to be performant. And there was a queue of bugs out the wazoo because what they did is they used prescriptions and they didn't really think outside the box. So I'm going to show you what that site was and what some of the features were that they needed and how I came up with solutions that weren't necessarily prescriptions. So before we really start talking about that example, I want to talk about accessibility and performance. So if you are visually impaired, this is what, also it looked like the light went out, and I realized that's because my screen is black, except for this word called click here. If you don't put actual content in your link, this is what a visually impaired assistive technology screen reader user will see. They will hear click here, click here, click here, click here. That has no value. If you don't put captions on your video, this is what it will look like to someone who is hearing impaired. If you are in a session right now like this and you want to watch a video of cats, which I think is a good thing to do, luckily cats don't talk, but if it was actually like the DNC or something like that, this is what it would look like. You can't hear it because you are temporarily auditorily impaired. If you have cognitive disabilities or are colorblind, you would not be able to read the word color. 1, because it makes no sense to use a font that's made out of stained glass, but 2, because about 10% of the male population is colorblind, and most of them are red-green colorblind. So disability is not, like someone who is in a wheelchair, not necessarily someone who's in a wheelchair or someone who is completely blind. Disability is a mismatch in the interaction between the features of the person's body right now and the features in the environment in which they are right now. So we are all sometimes visually impaired. We are all sometimes auditorily impaired. And sometimes we are also cognitively impaired. If you just had some really bad news, you might be depressed and crying, and you might have a harder time understanding how to book a flight, even though that is what you need to do right now. If you are working or going to the bus station and you want to look up the itinerary, you have the sun's glare. You're temporarily have visual difficulties. If your headphone broke, or if you are watching a video right now, you are auditorily impaired right now. So the ADA was passed 26 years and 3 days ago, and the symbol is the wheelchair. And so we usually think about the wheelchair. But we've all benefited from the ADA because we've all ridden a bike, carried a suitcase, pushed a stroller, or somehow needed to get up onto that sidewalk. Because disability is a spectrum. There's some permanent disabilities, like a quadriplegic, but similarly, someone in stilettos is going to have a hard time walking through a grassy field, just like they would have a hard time riding a wheelchair through a grassy field. So I already mentioned sun glare, distracted, holding the baby, forgot your headphones, or maybe you broke a leg or broke an arm, or you broke a finger and you can no longer use two hands to type with. So there's permanent and situational. Most people think about accessibility, they think about assistive technologies, like screen readers. And for screen readers, we have something called ARIA, Accessible Rich Internet Applications. That is basically a bridge between when we don't have a semantic element or a browser doesn't support an HTML5 feature, how to tell the screen reader that this is a new and different feature. The thing to note is the first rule of ARIA is don't use ARIA. If you can use a semantic element instead of using ARIA, that is what you should do. So let's cover performance a bit. Someone who is named Stephen Gundy, and I don't know who this is, and I don't follow him, and I have no clue how this passed through me, and it only has one little heart, which must be me. But it's a great quote. It says, "I remember when 3G was primarily mobile speed. It was slow, but it still worked. So why now, when my phone says 3G, it becomes completely useless?" When a website doesn't load on your phone, most times we blame the network. We blame our telephone company. The thing is, when 3G was the most popular, was coming out and very popular, websites on average were 700 kilobytes. In 2010, the average top 1,000 website was 7,002 kilobytes, a seventh of a meg. In 2016, that has gone up to 2,300 kilobytes, or 2 megs. That's a 339% increase. So with this image, I kind of cheated, and I did a radius that is 339% bigger. You could also do the area being 339, it's less impactful. But a few things to note is, it's basically the same distribution. That big chunk is images. Those are the lowest hanging fruit. JavaScript, if you look up in the top right quadrant, that is approximately the same percentage. The big difference is we now have fonts before we had Flash. And we now have videos and before we had Flash. So that's where these two come in, whereas before we had just this. So we have these prescriptive solutions. Knowing that images are the lowest hanging fruit, we are taught to optimize our images. Optimize your images. I'm not saying don't optimize your images. This is actually a resource, so if you go to the website and look at this deck, there's a lot of stuff hidden in this deck. Just mouse over these. One thing I do want to note, if you do include an image that is not just not a background image, but if you include any foreground image, even if it's for presentation, include an alt attribute, even if it's empty. Presentational images should have an empty alt attribute. If you have any information that's useful to the user, put something in that alt attribute. So we know these prescriptions. We know to optimize our images. Page speed gives you some very good rules for optimizing. These are all the prescriptions. Minimize the request size, minify your code, optimize images, leverage caching. We know these. Again, there's a lot of detail behind there. They also have some usability rules, such as avoid plugins and configure the viewport. Please always remember to put in a viewport meta tag. So meta, name equals viewport, content equals width equals device width. Otherwise, I mean, that's like 90% of you're 90% of the way there in terms of making your site accessible on responsive, or at least usable on mobile devices. So we also, just like we have prescriptions for optimization, we have prescriptions for accessibility. In 1998, WCAG came out, and it said use text alternatives for images or any auditory or visual content. Don't use color by itself to indicate that something is important. Don't rely on color because people are colorblind. Or people might have a glare behind them and not see the difference in their color. So situational colorblindness. Don't make something time sensitive. If it is time sensitive, allow ways to opt out of that. In 2008, 10 years later, they came up with the second version, which is basically the same stuff, plus they made it basically more robust. And they categorized all of their rules, and there's tons of rules behind here. I'm not going to go through any of them, but they basically said make your content perceivable, make your UI and your navigation operable, make all of your content, all the information you're trying to present understandable, and make it robust, which means make it usable on assistive technologies like screen readers. There's also, I added this slide in, or these two slides, because there's a nice little poster that gives you these guidelines that I encourage people to print. So if you go here, right here, there's a link to getting the poster. It has these 12 rules with an explanation of them. But again, make sure your links are recognizable, not using just color. Good idea to use a skip navigation. It doesn't have to be visible to the sighted user without tab navigation. So I'm actually going to go back to the first page of this slide, because I forgot to show it earlier. So here's the first page of my deck. My deck is inaccessible to people who are using assistive technologies in the current state, because I'm co-opting the right and left arrow, and then I'm hiding content. So every other slide other than the first, you can't see it, right? So if someone tabs in here, you can see that that tab has focus, right? You can see the blue line around it. If I tab again, I get this hideous button. Do I care that it's hideous? No, because the only person who's going to see it is someone who's using tab keys, and they need to see this if they're visual. If they're using assistive technologies, they will see it as well, but they won't see it visually. And so it doesn't matter. But what it does is it gets rid of all the CSS, so all of the slides are visible. It's an ugly deck then, but at least it's accessible. So similarly, I don't know if I can go directly to 26. No. Sorry. Okay. So basically, what I did there is on focus, visibility was visible, and not focus visibility was hidden. You can do that with a skip link. If they're going to tab, make it visible. And that will allow someone to not have to tab through your 400 level, your 3 levels down, 400 link navigation. Okay, so Visa created this form. Has anyone been to this page? It's a form. That's all it is. It's a form. It has enter your email, enter your password, checkbox, and 2 buttons. One is create account, which is actually a link to a create account page, and a sign in button, which is to submit the form. This takes 8.5 seconds to load and has 55,000 lines of JavaScript. And there's a timer on it, which if the user is in the middle of filling it out, the time expires even if you're typing 1 character per minute. So for them, accessibility is really important. So while they have features like ARIA to read out the titles and everything else, they don't have basic accessibility in other features. What they did, and the reason they have 55,000 lines of JavaScript, is what I call resume-driven development. So I think I'm at the same time as a React presentation, so they're not going to hear me like React to React. I think the next new framework is going to be called Overreact. So reason we have over 55,000 lines of JavaScript is because they have 41 dependencies. They also have a post CSS and a prefixer. I don't think there was any feature on that page that needed a prefix in any browser. It was a form. So here is their performance test. Oops. And you can see it takes 8.5 seconds to load. And this pink line is DOM content loaded. On my version, that pink line doesn't even show up because it's so thin. But there it is. It takes a half a second for DOM content loaded to be fired and actually figure out how many DOM nodes there are, or something like that. I don't know exactly what it's doing. And then here is the CPU utilization. And so here the site has loaded, and the CPU utilization is fully consumed for another 5 seconds. So what did I do? I gave notice. I was expecting a laugh there. But then after I gave notice, I recoded their entire website in 3 weeks. And I don't know if you guys have ever given notice. I don't know if you put much effort into your work after you give notice. So part-time for 3 weeks, I recoded their entire application in less than 1,000 lines of CSS and less than 1,000 lines of JavaScript. And it has the same features. When you go in here, it lifts up the same way. It has a little picker right here where you can change the country code. The only difference is I don't have any interactivity with the backend. So it's not like it's the exact same website, but let's look at mine. So in my version, it loads in 8.2 seconds. And I don't see the DOM content loaded anywhere because I actually put HTML on the page and there wasn't any DOM nodes to be created. Let's compare the two together. This is a web page test, and it's comparing the two. So the top version is mine, which loaded within 1 second, and the bottom version, oops, I have to go in here, loaded in 4. Because it only goes up to DOM content loaded, and then it stops. So here's the comparison of the two of ours, and you can't really see it. So I'm going to go to theirs, which is complex. And you see the wide DOM content loaded with the other stuff happening off the screen. And you see the CPU utilization thrashing it, right? My version is slightly different. Less than a second. And yes, the CPU is being utilized when I'm loading the page. But after the page is loaded, my main thread is now available. On the other one, the main thread is not available for additional 5 seconds after page load. So it's fine to use frameworks. Use one. Don't do resume-driven development. The way I like to think of frameworks and plugins is that they're a scaffolding. When I'm prototyping the site, I can add all the weight in the world. It doesn't matter because I'm prototyping the UX and I want to see how the flow goes. But I don't put all of that cruft into production. I removed all the stuff that's not necessary. So let's look at this. I already showed you this thing right here, the little picker. But I also have this thing. It's a carousel. And it works like a carousel. And then there's also input masking. So these are solutions. They obviously had a problem. They had features that they needed. And I thought outside of the box a little bit, and I came up with some solutions. Oh, this is the page I missed. Okay, this is what I want to show you. So input mask. It's a React site with Backbone and 41 other dependencies, and one of them is jQuery. They pulled in jQuery for 2 reasons, for cookies and for input masking. So cookies, if anyone has ever written a cookie script, it's approximately 1 line of JavaScript. Set cookie. What the cookie name is, 2 parameters, and the value. Really don't need a framework for that. I one time did a talk called You Don't Need a Framework for That. That just reminded me of that. Okay, so they pulled in jQuery at 37.7 minified, and then they put the input mask bundle at 29.6 minified, which comes out to 67.3 kilobytes for input masking. So what is input masking? Here's a little demo. I'm going to make it bigger. Apologize if it breaks. Yeah, it broke. But I want you to see this. So this is an input mask. It's in black, and if I type in 5 for the day, it goes to 05 because there is no day 50, and then, I can put 12 for the month. You'll notice a few things about this. It's black, and when I type in numbers, it moves a little bit. No biggie, but it is 67.3K. So I thought outside the box, and I created the exact same thing. And you'll notice here, the mask is pink. I could make it green because I styled it with CSS. And then when I go in here, I type in 12 for the month, and then 16 for the year, why not? Or I'll do that 5 again. It gives me 05, 28. If I do a zip code, I can type it in. Here, the Canadian zip code, you might not be able to read it in the back, but it says, there's a title that says 6-character alphanumeric zip code in the format A1A1A1. When you have a required pattern, always include the title with instructions on how they're supposed to fill it out. So in this case, if I type in the wrong characters, see it's not working? Because I need to type in a letter and then a number. And I can cut and paste, and it still works. So this works, right? But I did it in 2 kilobytes. I saved 64.7. And 2 kilobytes is actually bigger than what it was originally. It was originally 1 kilobyte, but I had it auto-initialize and be a little bit more robust. So before I cover how I did it, let me just cover HTML5 forms. These are HTML5 input type, and you'll see a lot of green on this page. Everything is well supported. The 2 things that aren't supported are date time, because that was removed from the specification, and multiple on range. You can still not have 2 sliders on one, 2 thumbs on one slider. But everything else is supported, such as pattern and placeholder. So, what does my HTML look like? The HTML for the zip code one was label for zip, and that value matches the ID of the form control. Always include a label for accessibility reasons. And it says input ID equals zip, which is used by the for attribute and by my script. Type equals tel. I use tel because I want the number keypad on the mobile device. I didn't use number because I don't want it, getting to 94115 or whatever the zip code is here on a spinner would take a really long time. But typing in 94115 on a mobile device is better user experience. Class of masked, because I'm going to style it. Placeholder of XXX, that is the placeholder that you saw. Pattern, 5 digits, and title, because I've required a pattern. I used semantic HTML. If my JavaScript does not load, this form works perfectly well. It just will have a placeholder that is gray instead of the pink or green mask. So what did my JavaScript do? That 125 lines, or now 2K of JavaScript, it puts a span around the input and precedes the input with a span that is hidden from screen readers. ARIA hidden equals true. It has an I in it, and then it has the placeholder. When I update it, when on key up, the current value of that input goes into the I right here. You see that right there, right? 1, 2, 3, XX. The remaining characters get appended. So on every key up, I write to this, span. What I do with the CSS is I placed it, because it came before, I placed it behind the input. I gave the input a background color of transparent, and then the I is visibility hidden. That's a few lines of CSS. So this is basically the creation of it. I'm going to skip that. But I have the shell span. So the shell itself is position relative, so that I can absolutely position the span in the right place that has the mask in it, which is behind the input. The only drawback with this is the input has to have a display, the background color of transparent. If your design requires that it not be transparent, that it actually be like, say, green, you can put the span after the input and then use pointer events :none in your CSS so that it goes right through. Okay, so in terms of accessibility, I said use the label. Label has been supported since forever. First version of HTML, first version of screen reader understood label and understood the input. So all of this is accessible by default. And it's fast by default because this is pure HTML. There's no whistles and bells. This is semantic markup. Use the label. You can also use ARIA features, but remember the first rule of ARIA is don't use ARIA if you don't need to. But if you need to, you can use ARIA label by and point to one or more nodes, and it will read those. These are the IDs of elements that it will read as the label when the person gets focus into the input. Or you could directly put ARIA label this, like right here. If you put it inside the label, instead of telephone number, if I do this, oh, that doesn't look good. Okay, so if this is what it would read, if this was my code, it would actually read, when I go into here, it would read read by screen reader instead of telephone number. Because the order of the assistive technology is ARIA label by. If that's not there, ARIA label. If that's not there, label, which is what you should be using. If you don't use label, it will use the placeholder. If you don't include the placeholder, it should read the title, but not necessarily. If you don't include any of those, you should be fired because you, for no apparent reason, made your application not accessible. So this is the gist of what gets created. I'm just going to show you the background, what happens if you do input background green. I don't know what the CSS is in there. So you see you can't see it there. You would have to reverse the order and then put pointer events none in there. So let's just get rid of this. Okay. So originally I had an example of this in production because Visa actually implemented what I wrote, this input masking script, except for they wrote their own React component and didn't do it correctly, and so it doesn't actually do pattern matching. I tried. I really did. Okay, so another feature that I created for them is their carousel. So here, if I hit tab, you can probably barely see it, but around the first radio button, there's a square around it, and it moves along with it, and it shows that it's highlighted and has focus. And right now I'm using my right and left arrow to move this. And now I am using my up and down arrow to move this. And if I want to, I can also click on these, but when I tab to the page, it goes directly to here. These do not get tab focus. They're purely decorative for the screen reader and for the person who's typing, using the keyboard only. Okay, so how did I create this? This is how Visa created it. They didn't do what I said, or what they should have done, and they used ARIA. So they have div soup with a div role option, tab index, ARIA selected, ARIA label, and then right inside that they have a data carousel with ARIA label of the exact same thing that was previously, with a bunch of paragraphs and spans that are empty for no apparent reason, and I don't really know what they were doing, but that's neither here nor there. So let's just, that's what it looks like for 2. That has 2 values. Oh, wait, I need to go a little bit. Okay, so that's theirs. This is mine for 2. So I'm going to make it legible. And I use way bigger font for this one, because I could. I used field set. Native, supported in HTML since 1996, supported by the first versions of assistive technologies. I have a label with the for attribute of address 1. And then I have an address of my company, which is in Palo Alto. So if anyone is looking for a job and you want to work in Palo Alto, let me know. Little plug. And then down here, I have an ordered list of inputs with address 1 and address 2, and they have values. And I could have put value. I don't know why I put data value. Let's just change that right there. No, I can't change it. Okay, 1.1 kilobytes to make this carousel work. So how do I make the carousel work? I changed the name of the parent class. I changed the class name of the parent so that I can change the left value, and then I transform it right here. I transition over 200 milliseconds the left value, and I used a SAS function so that I could do 20. You could use a SAS function to do 6, or you could handwrite 6 and do left 0 equals left 0, class name left 1, colon, or left equal colon negative 164, the class of left 2, and so on. So the only thing it does is there's an event listener on the radio button, the whole group, and when the value of that name changes, the class name changes. So let me show you another example. Oh, wait, no, I'm not going to show you another example yet. So is this a carousel? For a carousel to be accessible, these are the web accessibility tutorials, it has to have structure that looks, and there's correct structure that is accessible structure. It is an unordered list of labels. Functionality, you can select. Animations are controllable, yes. And full content, all the content is there. You saw the content, right? It was all there. So let's show you another example. Here is a horse, and if I right-click, if I go up and down, so the nifty thing about this is, because it's the same name group of radio buttons, the right and left arrow work by default, and tabbing into it works by default. I did not have to program anything in JavaScript. So here I have a carousel working without any JavaScript to control the carousel. Now the right and left arrows are added only if there is JavaScript. I don't know why I did that. I don't think I needed to. I think I'm going to take that out. The reason that they do not get tab, like I can't tab to those, is I don't need to. They're decorative. If you're tabbing to things, you can use the radio buttons, right? And the other reason is, if they did get focus, then I would have to add in all of this JavaScript for the assistive technology to change the screen and to read to the user the new screen. But the content is all there for the user. So it looks like a carousel, but it is not actually a carousel. And if you know the thing that ceci n'est pas une pipe, ceci n'est pas un carrousel. I don't know if it's supposed to be une or un, but whatever. It's a merry-go-round. And the reason I couldn't call it a carousel was because the content by default is accessible, and for people using screen readers, they would get confused if it didn't break, and you called it a carousel. So it's a merry-go-round. The GitHub repo is right there. You can totally use it, and you can see how few lines of JavaScript there are. So there's one last feature I want to go over, which is this right here. And there's no GitHub repo for this because it's 3 lines of JavaScript, and the only thing the JavaScript does is open and close the footer. But this is what Visa did. They did a section with a row of list box with an ARIA label, and then a bunch of sections with a row of options with tab index with ARIA selected true or false. So because they were using ARIA, they had to control everything. And we remember that the first rule of ARIA is if you can find a semantic element that will do what you needed to do, use that instead. So this is what I did. I created another field set with a legend of select your country and a bunch of inputs and labels, and the inputs are the country, the values of the country, and the label is the name of the country, and it's completely semantic because when someone tabs into the first button or right arrows, it says Argentina, and they tab to the next one and it says Australia. And what the CSS does is it takes the one that is checked by using CSS check property :checked and putting that up top. And that's all that it does. So it's just basically, there's nothing special here. The specialty is the JavaScript open and closes the footer because that's the look that they wanted, and that's maybe not the look that you want. So I don't know if you need JavaScript for your version. So the gist of this talk is think outside the box. don't don't over-engineer, because the point of engineering is using the simplest tool for the job and making it as simple as possible. So when you're over-engineering, you're not engineering. You're resume-driven developmenting, or whatever you want to call it. And when you need it, there is ARIA. So if there is something that you want to create that truly is not covered by any, you just can't figure out how to, you try thinking outside the box and there really is no element that does what you need to do, there are roles and properties in ARIA that can probably indicate what you need to do. So I don't know if I have time for questions. What time is this over at? I have 5 minutes? I did this talk yesterday, it took 2 hours. So I did good. I did at a meetup. Okay, so are there any questions? Don't see any. Okay, so resources. I added some resources in this deck. There's the WebAIM resource list, the Mozilla Developer Network list of ARIA resources. The thing I used was called Web Page Test, and there's also a website called Performance Rocks or Perf Rocks. And then the repos for the 2 projects, and then I said the drop-down select, check back soon, because I don't think I'm going to repo it, but I might put some examples in a repo. And that's all I have to say about that, so thank you very much. Oh, there are cookies downstairs in like 10 minutes.
course of our nation's history, the people of Boston have rallied bravely whenever the rights of man have been threatened. Today, a new crisis has arisen. Citizens, hear me out. This could happen to you.
so it doesn't really matter. Yeah.
I feel like we're movie directors.
I know.
in these chairs.
Got really quiet in here. Hello, everybody. So we're on the browser panel. Do you want to maybe go through and just introduce ourselves? Whatever? My name is John Kuberman. I do a lot of work around dev tools, web performance, education around those things, and accessibility.
Hi, I'm Yanzu. I am a technology fellow at EFF, and I work at Brave Software during the day. We're a new browser company, hence why I'm on this panel, I think. And I mostly work on security, privacy issues. Yeah.
Hi, my name is Jeff Carpenter. Up until recently, I worked at Braintree on payments SDKs and JavaScript. So if you want to talk about the PCI DSS v3, please come and chat. And then I'm also a contributor to JS DOM.
My name's Jen Fong. I'm an engineering manager on the DevTools team at Mozilla. And you guys didn't do your Twitter. My Twitter is Edna Piranha, if you know how to spell piranha.
What? I don't. Yeah.
Twitter is deprecated.
Twitter is not deprecated. Twitter is up front and center right there, right now.
Just kidding.
I'm JKup on Twitter, JKUP.
I'm bcrypt.
I'm JCarp.
Nice. What do you want to talk about first?
Browsers.
Sweet.
The future.
Yeah. So as somebody that's developing a new browser going into the future, what do you think of the current landscape? Are more browsers a good thing? Are less browsers a good thing?
Obviously, I have a very biased answer to this, but I think I think more diversity in browsers is good because people. Well, so let's go back to what a browser is, right? A browser is a user agent. And what that phrase means is that it's supposed to act on behalf of the user. And users are, people are very, I don't like calling people users, but, people are very different. Like, we all have diverse interests. Like, some of us care more about security. Some of us care more about, speed and performance. And so our browser, our user agent, should be representing what we want from the web. And there's only a few major browsers most people use, like Edge, Chrome, Firefox, etc. But I think there's really space for new browsers to come in and say, well, we're going to do something different. I saw a really cool demo a few weeks ago of just a student who had built this new browser from scratch using Electron in less than a week. And basically, you know how when you go to a site like dictionary.com, there's ads on this side, and then there's more ads on the other side, and then a lot of elements on the page that you don't care about. Like when you go to dictionary.com, what you actually want is to look up a phrase or look up a word. So basically, he made a browser where you just take that element and you put it on your desktop, and it's just a widget. And you can open 20 pages like YouTube and just take the video element and put it on this page. So now this browser isn't this rectangle with all these tabs. It's just a collection of elements hanging out on your desktop, and each of them has just the functionality you want. So I think lots of interesting ideas there. And with things like Electron, it's becoming easier to just make these new user agents. And that's really exciting. Any other thoughts?
I think we already have new browsers are awesome, but we already have so many of these compatibility issues between Chrome, Firefox, Edge. There are these this test suite called the Web Platform Test that do test compatibility against all those. There's a JavaScript suite and also a rendering suite that does pixel by pixel tests. So that it sounds like building the Web Platform Tests, it might be a way to enable more browsers to come up.
So I guess my kind of question following up on that is, are new rendering engines a good idea? Or as long as they're using the same rendering engine? Because it's the cool thing with Electron is sweet, build as many Electron apps as you want, because they're still on their libchromium or whatever it is. Is there, I don't know, kind of thoughts on that? I guess for me, my thought on that is that that's, I guess, where I'd like worry a little bit more about it maybe. Like I think a bunch of Electron apps are cool because they're really like more of a surface level change or a preference level change. Because I think like the hard time we've had is not about that level of stuff. It's been about like the actual, JavaScript engine, rendering engine, that kind of stuff. So I don't know. To me, it seems like the more the merrier, as long as we're not adding a ton of new rendering engines.
Yeah, I mean, I think that's what the W3C kind of exists for in these like standard communities. So if you're making a new rendering engine, you should try to conform to these standards. Otherwise, you get like frowned upon by the W3C. That's bad.
Then you have to make a new browser with a cool new name,
Yeah.
like Edge. That's awesome.
Yeah.
I love Edge.
But I think what's important is the ability to make a new rendering engine, right? Like I think monoculture is bad. Like having people locked into, if all of us had to use Chrome forever, Chrome's rendering engine forever, like we were giving a lot of power away to Google, and so I think it's good to have competition in that space. Yeah.
Yeah, one of the things I like to think about, and it'd be interesting to ask people in the audience what they think. So if you want to answer something, we might be able to give you chocolate. You want to, is the idea of like what we think about in terms of what a browser is for the past 20 years. Is it going to be the same in 5 or 10 years? Or are we going through a stage where things were sort of going, with standards and everything, and it serves pages and you do things with pages, but what if our definition of pages changes then? Like if we take AR and VR and whatever comes from that we haven't figured out yet, or it's being figured out in some corporate labs research right now under an NDA, it's like, would that change what we mean by a browser? And then we do have to rewrite it.
Yeah, there was like a cool talk a little while ago here about like VR. And like one of the things that I always think is really interesting is like you have this like really cool VR capable of anything, and then you look at like a website and it's like still in a box, right? Like which is like kind of purely like a mental bit of tech debt that we're in. Like this is what browser looks like, this is what sites look like.
Like I think about when you use something like A-Frame or 3JS and you're navigating in a 2D world, 3D, and it's very non-intuitive. But if you're thinking about, I'm wearing these goggles and I'm moving around in 3D space and I'm moving stuff around to change the page or experience because I know where the X, Y, Z coordinates are. And it's like, is that better than what we have now where we're going, is Z here? Let's refresh that. Oh, wait, too close, too far, and it's like we're wasting time spinning cycles in a different dimension.
That's pretty heavy.
Yeah. Anybody want to come on the stage and spice things up? I'm looking at someone who works with me right now. Do you want to come up?
Uh-oh.
No?
Okay, so I guess another question in the meantime is I was curious what you all think of like with it being really easy to make new browsers right now, like where do you draw the line between what would make a really good plugin or what would make a really good browser? Because I feel like I'm seeing a lot of Electron apps that are like, this is really cool, but I have a lot of things in my applications folder right now, and like just kind of curious on that.
I was wondering with all these Electron apps coming up, is that are there like 3 or 4 APIs that browsers could implement that would obviate the need for a lot of these Electron apps?
Yeah, so that's a good question. I spent a long time as a browser extension developer. I wrote lots of HTTPS Everywhere and Privacy Badger and the stuff at EFF. The main problem back in, at least a year ago, was that there was no way to write a cross-browser compatible extension because Firefox had this add-on system that was completely incompatible with Chrome's, but they're actually moving to web extensions. So hopefully that will make that issue easier. Yeah.
Yeah, I think that's like
that was a big part of
the number one thing I'd like to see is being able to just write one web extension and then share it between the browsers. I mean, that's it's always frustrating starting over. Like you go to a new browser and it doesn't have your favorite plugin or whatever, even though it's it should, right? Like it's and I think I saw a talk from the Microsoft people once that like Edge was coming up with like some kind of like automated service, I think, where you could like give them your Chrome extension and they would like spit out Edge extensions. But I'd really like to see that in the next like couple of years, where you could just take all your favorite extensions with you.
The things I've seen people do for like in Electron browsers, not that I've seen that many, but that can't be done as extensions are, so for one, Brave, the browser I work on is an Electron app, and we do ad blocking, but we do it a bit faster than extensions can because we actually do it in like the core C++ part of the browser rather than in like the JavaScript part. So for performance reasons, yeah, it's better to have an app sometimes than an extension. Also, if you want to just totally like change the browser UI, like you want to reinvent the way tabs work, or like change the URL bar or something, like browsers don't, like extension systems don't give you that much power, because you could do really malicious things such as like pretend someone's going to bankofamerica.com when they're actually going to like your hostile website.
Is that just a hypothetical?
I mean, there are malicious add-ons that have done things like that, so it's not actually a hypothetical. But I think moving forward, like extension frameworks are trying to limit those powers rather than grant more of them.
I have like unlimited questions if nobody else is going. I'm curious on the Firefox side, like y'all have been doing like a ground up rewrite for a few years now, right? Like this, like I thought it was like a really bold move. Like everybody's using Firebug, then you came out with your own like Firefox dev tools, and it was like pretty feature light at first, and then like over the last couple of years, it's been like really gaining speed. I was just a little curious, like what's that been like? Like was that a really big undertaking, and like are you feeling really good about it these days?
I've been on the team for, I think, just almost 2 years, so I wasn't really there for the bulk of this stuff. But yeah, it's been interesting. Like currently, they're moving all the
Another
core
rewrite.
tools to React and Redux, so everyone can help contribute and, you know, not pull their hair out. But do you want to contribute? Come on. Get off this
hop
chair,
up
but I
here.
feel like I'm going to injure myself. Oh, never
You just gotta
mind.
jump. You're not a speaker. You can't come backstage. You gotta jump up.
So what am I saying now? DevTools, Firefox DevTools. We just got source maps. I feel like I should say it because I did it. But more than that, it's really interesting because we are working with the debugger.html project, which is open source. And that's really exciting for me because I get to work with a lot of smart people all over the world. And they all work with React and Redux, and it's all the same technologies we're all using. So it's really easy to bring it to the same level in terms of how, because we are looking at Chrome, we are looking at Firefox, and we are making sure that the experience is similar. And it's easy for developers, first-time developers, to be able to get into that very quickly and contribute faster, I guess. So I guess it's all about the community.
Cool.
What are you looking at me for?
No, I was
What's
just
going on?
thinking about more questions.
Oh, I was like, did I miss someone? Did they want to?
We had talked a little bit about the new payment API coming through. Does somebody want to talk about that? Because I think it's really interesting.
Yeah, I've been looking into the new payment request API recently. It seems like, obviously, like a lot of consumers are moving toward mobile, but as most of you probably have experienced, mobile checkouts are really crappy. So Google and Apple are starting these initiatives to start to offer like a browser-based payment API. And Google's working on this standardized API called Payment Request. And there are positive signals, I think, from Firefox and Edge. And Apple just introduced Apple Pay for Safari. And so those are, I think both Apple and Google are looking to try to get those ready for like the holiday season 2016.
So I don't know too much about it, but is one of the benefits that you'd be able to have like your credentials kind of just stored on your browser and then use those with anybody using this API? Is that like, I think that I read that was like one of the kind of neat things that you'd be able to do. You know, like if you had your stored Visa card or Bitcoin account or whatever it was, like you would actually just be able to like, you know, everybody would be using a standard as opposed to like whether you're using PayPal or Stripe or Square or whatever. I don't know, it seems kind of interesting, but it also seems like in some ways it's like seems a little bit far from what the W3 like normally implements. Like it's interesting that they're moving into like this like consumer payment space or whatever. I don't know, it just seemed like it was a little bit interesting.
The interesting thing about stuff like that too is what is the end user experience going to be like? Because in theory it sounds like, oh, you just pass in this array of whatever and then you do the stuff and you do the standard stuff, but how does that get executed on the front? Because someone implements the code for that interface, but it's not like a PayPal or a Stripe interface that people are used to. So it's like, do people start creating like React payment widgets, or do people start experimenting with wacky ways of screwing you up so you end up paying more than you should, you know? Dark UX? I'm really positive.
Yeah, I mean, I guess to me, like, the UI aside, because right now UIs are all really different for payment anyway, even if you're, like, using PayPal or Square or whatever, but I guess the thing that would be, I think the two things are, like, one, do you have some security features that you can take advantage of that you can't right now with JavaScript, you know, because the browser would actually be able to support, like, some tokenizing and some cool stuff, and then two would be, like if you could have kind of your like trusted source and it would be able to recognize like this is legitimately using the standardized payment API, load in your Visa card or you know whatever, like similar to password management, something like that. I think that would be awesome.
I think if it hits the major browsers and both of the main phones right now, that's the most important thing, because if it gets into Chrome first on Android but still has some time on iOS Safari, it's completely, everyone's just going to go back to their usual. I thought you had a lot of questions.
Oh, I do. I have more questions. Don't even worry. I was just giving it a 3 count to see if anybody else wanted to step in. Could we talk a little bit about where we're at with HTTPS, specifically on maybe, but open to everybody?
Sure. So how many people here have heard of Let's Encrypt? Yeah. So, oh, well, not as many hands as
Is that
usually.
how we're doing? About 50%?
Yeah, yeah, about the percentage of people who raised their hands. That's how the percentage of encrypted websites on the internet today. Actually, it's roughly true. I don't remember the stat. Well, so I can say that HTTPS deployment has generally become easier in the last year. It used to be that there was no automated way to renew certificates, well, get certificates and renew them for free. But this project called Let's Encrypt, which is from a nonprofit formed out of EFF, Mozilla, and University of Michigan last year, 2 years ago, has this new protocol called ACME that automates certificate management and renewal. And they have their own certificate authority, which will issue these certs for free. Do you happen to know like the Firefox telemetry stats for HTTPS recently?
I don't, but
okay.
if I went on IRC on my 5%
Can you just go on
battery
IRC
left
right now?
laptop,
Go on
I
Mozilla
could ask
IRC.
someone.
Yeah, it's been going steadily up. It's nowhere near 100%. If I had to guess, I'd say it's like 40% of the Alexa like top 1 million or so.
Do you think we're gonna see, like I've heard a couple people talking about like maybe Google, bumping you in the results if you're not using HTTPS, and I know that like Chrome on their dev tools added like a security tab. Do you think we're gonna see, now that there's really no excuse, it's like a one-liner, do you think we're gonna see like some really aggressive pushes to get everything over that?
Yeah, I mean, that's starting already. For instance, I think the search engine, the Google search engine prioritization of HTTPS has already been done. I'm not sure what their algorithm is, but I definitely see like HTTPS results more highly ranked. And Chrome 52, which just came out, has these new security indicators, which makes insecure look a little bit more scary. The idea is that usually, in the past, browsers have always just shown HTTPS with this lock icon. So If you notice the lock icon, you can say like, good, okay, now it's secure. But what we should actually be doing now that more sites are moving to HTTPS as the norm is show insecure sites as really frightening. So imagine if every HTTP site just made your browser like flashing red, you know, and like played a really scary sound or something. Obviously that's pretty extreme, but then you can imagine sites would want to move to HTTPS ASAP.
But do you think that maybe in like, let's say 5 years, that everyone would move their websites to HTTPS, even if it's just like a hello world? Or is there some sort of line we draw, like that stuff doesn't matter and then this stuff matters?
I don't know much about the history, but it seems from an outsider perspective that HTTP was a mistake in the sense that it wasn't encrypted. Like that's wrong. That's the wrong way to do it. So it seems like what I'd really like to see is like web hosts not offering HTTP as an option. Yeah. You know, like if you just sign up with your like one-click builder or whatever, that it would, especially now that with the certs being free and automatically renewable, I would like to see that not an option anymore.
I agree with that. I think even if you're making a Hello World site, it should just be HTTPS. Like, why not? There's no cost, and it's like infinitely more secure. Also, on an interesting point about HTTP versus HTTPS, Tim Berners-Lee actually said about a year or two ago, he thinks the S was a mistake. Like, really, it should just be the same protocol. Like, so people don't have to keep changing their links to say whether they're secure or not. Like, there just should be some automatic way you upgrade. Yeah.
I think Chrome is starting to incentivize this more by deprecating APIs in HTTP
that's
too.
true.
Like
Yeah,
I think the
that's
full
also
screen API is going
Yeah,
away.
geolocation no longer works over HTTP
Yeah, and like
in
all
Chrome.
of service workers.
Yeah, service workers. There's a W3C spec called Powerful Features, which actually defines like what it means to be powerful enough that you're only allowed on secure origins. So I think like Bluetooth and stuff and NFC are also in that category.
Still have more questions. Nobody else has anything? I'm learning a lot. This is great. What's going on with ads? What's going to happen with ads? There's like, we had ad blockers, and then we have like ad blocker whitelists, and then we have like ad blocker blockers, and like Forbes is sending me like weirdo messages about I need to pay their bills or something like that. What's the state of advertisements? Like what are we doing?
I have a feature request. Great. I want like ads that I care about. Like I'm into synths. I want to see ads about synths, but I don't want to see ones for the one I just purchased.
Sure. Yeah, well, so let's just do a poll. How many people use an ad blocker of any sort?
That is more than HTTPS by
It's
far.
more than the people who use HTTPS. How many people like pay for any sort of subscription service to like New York Times or Forbes or any kind of web content? Significantly less hands. How many people like click on ads and buy stuff ever?
Just
I've done it a
Facebook
few
ones,
times, yeah.
Man, they're so good with the targeting.
Yeah. So I think with the percentages of people who raise their hands to each of those questions, we can see why like the newspaper industry is really worried about ad blockers, because sure they can turn on these banners that say like please disable your ad blocker, but we've already seen people release like ad blocker extensions to block the ad blocker blockers. So it's just this like war of attrition to block each other.
So
Yeah.
what's the, like, to me the solution is renegotiating how ads work, right? Is just being like, okay, it's not the fact that you have some picture, it's like, it's that you're tracking me, and it's the fact that that stupid picture blocks my page from loading, and it's that you're like bootstrapping like 8 gigs of JavaScript to like track where my mouse is on the screen. You know, it's like those kind of things. Like I don't mind seeing, even a targeted ad, I don't mind seeing. So is that kind of the future, is like just renegotiating? Because it kind of seems like that's what like the ad blocker whitelist is like, allowing like good ads or so, I don't know, something
Yeah,
like
sure. Let's talk about like interesting things that people have done to try to solve this problem, because I think there's a few. So you mentioned like it would be nice if we could all just see relevant ads, and somehow that hasn't happened. I remember Mozilla had a project kind of along these lines to like show ads in the tiles. Like basically it would use your browsing history, which is totally stored like on the browser and not sent to random ad networks, to figure out what you were interested in. And and like show you those things.
I also think about, along with what your team is doing, but also just ad networks have to survive because they are a business and that's where a lot of people make their money. So it's like they've kind of used an old model that isn't really working out. So maybe pressure from browsers like Brave and stuff will help them think about a better way to do it. And what is a better? Does it mean throw everything into a neural network, or does it mean like MTurk? I don't know. Like it could be anything, but I mean, it has to be more, it has to go beyond just maybe what you visited. Because if I visit a bunch of people's GitHub profiles, what are you going to sell me? Like Sublime 5.0? Like, I don't know what you're going to do, but that doesn't make any sense. But there's things, sometimes people make me click on links that some stupid Reddit thing or something, and it's like, don't sell me anything from this subreddit. Like I have no interest in it. I'm just looking.
Is that like what incognito mode is for?
I use that for...
Don't alter my ads based on
I use that for New York Times, don't tell them.
I think it feels tricky, right? Because it feels like, ethically I don't want to use an ad blocker necessarily, but then it's like, they're really invasive, they're really slowing down my page load, and they're really bad in a lot of cases, right? Like, I mean, it's like these like deceptive ads or, and it's like, doing a lot of like the site performance profiling, it's like almost always ads that are making like a significant, like a multi-second impact on page load. So it's like frustrating that there's no like minimal acceptable criteria to be shown an ad or something like that. Like you can just do anything you want. And I think a lot of times content owners don't even know how bad the experience is really, because they sign up with some company and the company's paying them and, they put like an iframe in and then, like gigabytes of like tracking code is being, it's just like, it's kind of a bad scene.
I mean, I guess in the ideal world, it's like you can't put an ad in our thing unless it's like under this size. And then they have to really think creatively, like, oh, I can put it in here, but how do I maintain that size? I got to be clever, and then that's their problem.
Yeah, and I think some of the interesting things I've seen is Google's AMP project. So they allow ads and tracking pixels, but they don't allow anything to be synchronous. Like nothing can block render. So you can do your stuff, but all JavaScript has to be in an async tag, which is kind of interesting.
Another interesting idea from Google was Google Contributor. Who here uses Contributor? I'm the only one. Okay, awesome. Oh, one hand. Cool, we're pals. It was this project where, so Google has all these ad partners and like they show ads on Google sites like Blogspot, etc. You can do this thing. This still exists. You can sign up for it. It's called Contributor. You pay Google $6 or $7 a month, and you basically become a bidder in the ad wars. So if you win with your $6 a month, like your bid wins, then the ad is instead blocked, and what is shown is this placeholder that says like, thank you for being a contributor. So basically, instead of just being an ad blocker and like blocking all those ads, you're actually paying the sites directly by like putting your money against the ads, right? So I did this for a few. So there's limitations. Like this doesn't work on every ad. It only works on like Google sites or Google partner ads. And it also only works if you're logged into your Google account and have third-party cookies turned on, which I don't usually do. But I did this experiment for a few months, and it was really surprising because I found I was only paying sites like a few cents a month at most, and I was blocking these ads, but this was like a very, very small amount of money, per site. And Google refunds you if you don't use the whole like $6 or $7. But I think that's a good model. It's just like let people directly pay, pay to make up for the lost revenue that they're causing by ad blocking, which isn't actually that much revenue. And that's kind of what Brave is trying to do for every website, not just Google sites.
So you brought up the AMP project, and I was wondering if I could get your opinions on like, it seems like the AMP project is really cool and it loads sites really fast, but it's owned by a company, Google.
Yeah, I think that's tricky. I think we're seeing this model kind of a lot lately. You see it with React too, where it's like completely open source, but it's definitely company owned. So that's the same thing. Like all of AMP is open source, like the validator, all that stuff. But yeah, it's definitely, you know, it's owned by Google for sure. I think it's interesting. Like, I guess my take is that it really stinks trying to run a purely open source project and nobody gets paid and it's just everybody burns out and it's like really hard. And so it's like, for maybe some of the negatives that come with it, it's great that like Facebook and Google are like, I mean, that's like a lot of money that they're paying, right, to keep React open source and like friendly and like, you know, same with Google. Like I kind of like it in a sense that it's dangerous, right? But it's no more dangerous. I mean, like Google controls everything with their search, right? Like if you get bumped from Google search, you don't exist on the internet anymore. So it's definitely a dangerous amount of power, but I like that everybody can kind of stay happy. Like they're paying people to work full time on it, handle, you know, triage issues and things like that. I think it's a really cool standard. But yeah, I have some of that skepticism. But I know a lot of people that make like no money and work on open source all day, every day. So it's nice, you know.
Do you want to, here's a kind of, well, if you want to ask a question, you should go ahead. I was just going to ask, what do people think about DRM in browsers? It's been a really controversial topic, at least in W3C. So do people remember the W3C DRM problem? It was a few years ago, but so there's this proposal to standardize DRM using something called encrypted media extensions in HTML5. And groups like, there were a lot of groups that were really against it because they were saying like, you know, DRM is bad, right? Like we shouldn't standardize it. But on the other hand, like companies like Netflix really need DRM in order to be able to provide content. And it was better that, they argued it was better to have this like in an open source standard rather than having like these kind of shady plugins that like no one knew what they were doing.
Yeah, I mean, I think that perfectly sums up the problem. I mean, it's like we have services like Spotify and Netflix can't survive without it, right? Like that's like a very common type of service these days. There's like a ton of owned private stuff that you literally are only paying to, you know, rent and stream. But the thing about DRM that's terrible is now all these use cases where you should own stuff you don't anymore, right? Like, you know, if you buy your like Amazon Kindle book, there's no reason for that to have DRM on it, right? Like I mean, if you buy the paper book, you can do whatever you want. So I feel like I guess I'm unfortunately on the side of standardizing. It would be awesome.
Yeah.
And I think like when you think of all the stuff that it used to be difficult to do, like make movies, make music, all that stuff can be in just software in your own home, and people are becoming YouTube stars and stuff. Everyone wants to get paid. So they're going to be like, I want to share this stuff. I want to make a startup where I do heavy media stuff, but I don't want to lose, like, that is copyright because, you know, I want to be prepared when I have partners going into discussion. So having that base is unfortunately, like what you said, I think needed because right now, what are they doing? If someone is some person who's just starting something from, you know, at home, but then people are finding all different ways to like scrape everything from them, and they're just like, you know, they're just trying to get something up and have the protection. It's like, are we not going to talk about their considerations?
Well, yeah, I mean, I think that there's an open question of whether, you know, people can make money without having copyright enforcement. I mean, there's lots of successful authors that, I think Cory Doctorow is one of them, but he just releases content like under Creative Commons, and it's popular enough that he gets.
Kyle Simpson did a really good job with that too, with his books, which are all like totally free on GitHub. But then, you know, has been selling them.
But if we all work towards a post-work society, we won't have to worry about this.
Yeah, basic income is the first step.
Yeah, no, I think it's just really tricky. Like I want content creators to be able to make. I mean, this is essentially the same discussion as the ads discussion, right? Like I don't want all these sites to go under, right? Like I read the New York Times and sometimes accidentally Forbes, and like I want those things to stay around, like, but I don't want to be abused, right? And it's like the exact same thing. It's like I would like a way that I don't need to be like able to keep all my Netflix movies, but I hate that I can't like move a Kindle book onto my computer or something. You know what I mean? I hate like when you start feeling that kind of entrapped where it's like you paid money for this thing and you own nothing. Like you own what they say you get to own. You know, so I think it's just like, I think it's just tricky because obviously content creators need to get paid, but all too often, I mean, it's like, I don't think the worry is, like, people like illegally torrenting is like one group, but I think there's a larger group of people that just want to honestly use stuff and are being really limited by DRM. You know, I think it's got like, that part really stinks. I have more questions. I always. What should I do with my passwords? Like, should I be using browser password keepers? Are those things safe? I never use those. I only use like LastPass. But then I always get prompted. Do you want to save your password? Where do those things go?
Did you see the LastPass vulnerability this week?
I did. Now I don't use LastPass.
Yeah,
now I write them down and I stick them underneath my desk.
Also, LastPass, like, sorry for anyone who works there, but like they had a problem before the hack or whatever. It was like it couldn't detect some forms on some pages. And then I was like, God damn it. And then I switched to 1Password and now it detects everything. And I don't know. I don't care anymore. I just want to
do you like
do my shit.
Store your 1Password password in LastPass? Like, just
no,
so
I manually ported it and then they effed up the ordering. So now I have to manually.
It's brutal though. Where should I put my passwords?
Piece of paper and a notebook.
I'm pretending like I have multiple. I only have one.
Yeah. You only use the same password. You won't have this problem. I guess I personally don't trust any password managers. I guess my corporate environment uses 1Password, and if they're cool with that, I'm cool with that. So we use 1Password. For work, for personal stuff, I have, I just like GPG encrypt all my stuff to myself, and I like manually move them over local networks, and I don't like use Dropbox or anything. But I know it's like not very practical for most people. One thing I do like that services like Slack have been doing so these magic links. Like the most annoying part is having to type your password on your phone with like, your like 128-bit password. It's like really long and has like a bunch of symbols. You just don't want to do that. So if you make an app and you have like this magic link thing where someone just, you just email them a secret one-time use link and you click that and it logs you in, that's awesome. Like more people should do that. I think that would get rid of some of the use cases for password managers.
So there's two things I've used in personal apps lately. It's the one costs money because I'm using the Twilio API, and then I just generate a random pin that lasts for like a TTL 5 minutes on the server side, and then they try to log in with that, and that becomes their identifier. The only problem with that is the cost, because that adds up if your site gets popular. I wish there was a free way of doing that somehow. Like then you could do 2FA easily or something.
Yeah.
The other one is, I guess, I don't know if there's a Node module or whatever for this, but maybe
there
like.
Is. Before you finish.
The email, and then it
I don't
sends, but then the problem is when you plug in your email, you have to plug it into a third-party like mailer, right? Unless you want to run your own mail server, which I advise not to do.
I mean, pretty much every service has this password reset button that goes to your email. So I know some people who just like never pick a password they remember. They just like type something random every time and reset their password. That works. Yeah.
And then it really all comes down to how secure your email is.
Yeah,
right?
so as long as your email's secure, you're fine. You can always just reset your password every single time you log in.
Where should I keep my emails if I don't want the NSA reading?
You should use one of those one-time email generators.
I write those down on paper and I stick them
under your desk
too,
also.
Nobody ever responds.
Oh, that's sad. But people should use I guess I have 2 tips for people who are concerned about password security. One is always turn on 2-factor if it's an option, which it usually is. And 2, there's this site called haveibeenpwned.com. And my friend, well, not my friend, but someone I kind of know on Twitter runs it. And you can put in email address, all your email addresses, and it will alert you when any of those show up in a breach. So, like for instance, when LinkedIn was breached, I got emails from the service before LinkedIn emailed me because they were pretty slow to do that, I think.
Everybody's just always getting breached.
Yeah, I actually had never had my main email in a breach until LinkedIn this time. Yeah.
I use
Or breaches are pretty
Fastmail,
often.
and then I have like all these aliases for multiple domains and folders, and then I just honeypot things now. That's how sick I am. I'm just honeypotting things.
I've been
over, like,
using
20
Proton
different
Mail.
emails.
Has anybody checked that one out? It's really slow, which makes me think it's super encrypted because you like
Probably
type
encrypted.
your password in and it just spins there for a while. That makes me feel safe.
It
be that
makes,
fast
it
to
makes you
access.
feel safe that there's someone working behind the scenes.
I feel like
cranking those
hackers usually have short attention spans, so if it takes me like a minute to get into my email, I hope they're just gonna move on.
Yeah, I haven't used Proton Mail, but is it like a mail client or is it a hosted?
It's a hosted
so
mail
it's like
solution,
webmail,
yeah. But it's cool. It's like I can't remember which university, but I was
It's
kind
like
of kidding. But
Switzerland or
yeah,
something?
it's like hosted offshore,
Yeah.
and it's like you get your email password, and then you get your your master encryption password. It's like kind of similar to if you use any of the password
Yeah.
managers, but for email, it's kind of cool.
Honestly, I'm pretty paranoid about webmail because you just don't know what the JavaScript on the page is doing. Like if Proton Mail decides they want to not encrypt your email, they can just like not do it, and you can't tell, right? But also GPG is hard to use, so no one should use that.
I think the only time actually I've ever had to use GPG for email was actually Cory Doctorow. Like he just sends an email, it's just like garbledy-gook or whatever. He's like, here's my public key. Go if you really want to read what I just sent you, go at it. It's not that bad. It makes me feel cool, but I wouldn't do it
Feel
every
like a
day.
hacker.
Yeah. Kind of maybe moving away from like the security side of things. I'm curious, like as there's been a lot of really big advantages in this like web versus native stuff going on. But do you all have any opinions, like where we're at, where like the web still needs to? Is web better than native?
I think, well, this is not representative of the company I work with personally, from my experience of building apps and, well, React Native, whatever. Anyway, the thing is, I think it's not either or. I think based on when you start using a lot of apps, it starts to make sense what seems like it's appropriate as native and what seems like it should be a website. So there's a lot of news sites that have apps. I don't get that. Just keep it on the web. It's just content, right? But if it's like very media heavy, very animated, very gamey, I would probably,
Yeah, I guess my like I agree with that, but it seems like the web is moving to bridge that gap. So like ASM, JS, or like I'm really curious, like are we coming to a point where there is no okay, I can't think of a non-contentious way to phrase this, but it's like all those things that are like, oh, it's better for a native app if it does like web is coming up with at least a potential solution for all those things. So I'm kind of curious, like do y'all feel like it's getting really close, or do you feel like even if you have your like compile target, you should still build a native app? I don't know.
So another thing is like, I don't know what the security issues are with native stuff, but I mean, at least for websites like XSS and stuff, like, it'd be great one day where we don't have to deal with that anymore. It's like another thing, another gotcha you have to do to just put a simple like WebSocket or Ajax or whatever call. And it's like, now you have to have everyone learn this thing or you're going to get them. Because that's what we all do when we test our friends' sites. We're like, oh, let's see if we can inject this JavaScript here. Ha ha ha, got you. And you're like, damn it. And it's like
Sounds
over
like you have
and
mean
over. And it's
friends.
been like this since, I've been in this for like, I don't know, over 10 years. And it's like never ending bullshit, just.
The web.
And then when you're like, I have this never-ending bullshit, and they can't figure out which standard they're going with or whatever, you know what? This thing works. I want to go home.
Do you think that frameworks that have things like __ dangerously set inner HTML are like helping that, or is it still happening regardless?
So it depends on who your developer audience is. It's like when we are the makers of APIs, we think of a certain use case. We think like, this makes sense because we have to do it like this and this reason, and go deeper into the yak, just like in there. But then there's just people who just need to get something done under pressure, like at an ad agency, and they don't want to be working there Friday at midnight, which they might, and not get paid for overtime or something, right? And it's like, are we being fair to them? Are we being good citizens by creating things that are it's still giving them problems because we haven't, it's never going to be perfect, but if there's a better way, they'll take the path of least resistance. So we have to be aware about the developer ergonomics before we can push something forward. So there's the technical implementation, but it's the presentation at the end. Like, how many people use the Web Audio API here?
I've used it.
How about
That's like how many people know they're using it, right?
anyone ever written WebGL from scratch? You know, it's like there's all these things that are just so hostile when they're created, and I don't think they were intended to be, but sometimes we make things that get overly complicated because we're so deep in it, but what it looks like to everyone else is just confusing because I always think, like, when you make something that's user-friendly, you can understand that when you're drunk. That's like, you should hit for that because most people will
That's
skim.
why I only write code when I'm drunk.
Because it's like, if you skim the docs and they're like, well, when I was a child in 1856, and then I walked down here, and it's like, nobody's gonna read it, and they just hit the code, and then they're like, I don't know, and then they just go down, and, oh, it's lunchtime, you know, so that's how people react. Like, do you wanna read my blog? Yeah, looks good, whatever, you know, like, it's like, nobody reads anything, even emails that go in your inbox. It's just,
Cool. I think we're there on time. I don't know if Jan, if you had a last thing to add.
No. I guess in summary, the web is bullshit and no one reads. Thank you.
Thank you.
tread these waters, make our ways, yes we do. Peaceful self-preservation.
Cool. Welcome to the React Architecture panel. I think we'll just go through really quick and introduce ourselves. My name is Brian Holt, and I'm probably not qualified to be here. And sometimes I work at Netflix.
Hi, my name is Mars Julian. I work at Netflix with Brian, also equally unqualified to be here. I worked at AdRoll previously, where I spent the last 6 months building a reusable component library in React.
Now it works. Hi, my name is Ben Alpert. I guess I'm also unqualified to be here because I haven't built any apps in React in the last year and a half, but I have been working at Facebook on React. And so I started using React actually the week it was released. I saw it on Hacker News. I was like, this seems cool. And went home and rewrote my current project in React that weekend. And I was like, wow, this is less code and it's faster and it works better. And ended up deploying it to production 2 weeks later, and ended up contributing to React, and then now I work on it full time.
I'm Nicholas Gallagher, and I work on the mobile web team at Twitter, and we've been using React for a little bit over a year. And there's lots of teams at Twitter using React.
I'm Devin. I work at Apple, and I run the React.js Bay Area meetup. And I've been working on React for few years now. Actually, what happened was Ben wrote a blog post, and this guy that I used to work with named Joe Savona that works with Ben now read it, and we were like, we are sold on this React thing. And so ever since then, I've been on that bandwagon.
That's awesome. I had no idea that you read my blog post. I don't even know which one.
Yeah, I was a big fan. On Change. That's all Ben. Everybody, a round of applause for Ben.
So it's funny, I read that same blog post of, when they announced React, and I read through it and I was like, this looks like total horseshit. I was reading through it and I was like, well, I think the reservations most people have, which is why the hell am I putting HTMLs into my JavaScripts? I just got JavaScript out of my HTMLs. And so it took me probably another year before we launched it at Reddit, because someone else came in from working at another company and said, hey, check out this React stuff. And it's like, we did, it's terrible. And then we ended up rewriting part of our checkout experience at Reddit in it, and now for some reason people hired me to still write it, so it's been pretty good.
Yeah, see, it's funny that you talk about JSX was this huge turnoff for people, because also for me, I looked at it and I was like, I don't know about this JSX thing, but React seems pretty cool. So then I first wrote React without using JSX, and then 3 weeks later I was like, I think JSX probably is actually better, and I switched. But the funny thing is that JSX was actually created in order to make React more familiar to server developers at Facebook, because in our PHP stack we use this thing called XHP, which is basically JSX for PHP, where you can embed these markup hierarchies that look like XML in your PHP code, and that's how so we built components using this on the PHP side, and so there were hundreds of server developers on Facebook who were already familiar with that syntax, and then so when React was being developed, JSX was actually created to make it more familiar to those developers, but then it had the exact opposite effect in the outside community.
I had no idea, that's crazy. Cool, I have some questions, since this is about React architecture. First of all, do any of you have any React app structuring pro tips that you've discovered in building React apps, or just something from the architecture that would lend itself really well to React?
I can go first. I think when I was thinking about this earlier, I think a lot of our architectural decisions are not necessarily tied to React, but rather they kind of work with the principle that the UI layer is going to work like React, that it's going to be a bunch of functions that project the state into the browser to some extent. So we have it at the moment split up into components, which are kind of what you might call the presentational or dumb components. So they have no connection to the state in the app. Containers, which do connect to the state, which happens to be managed by Redux in our app. Modules, which are just a place where we pile everything that isn't something specific. It's just like generic modules, effectively. Screens, which are containers that are basically route handlers. So they, at the moment, we use React Router, so they basically act as the route handlers for that layer. And that's about it, I guess. We've got like an API layer that's separate as well, and that gets injected into the Redux layer through the middleware. And even though we have this division, we don't quite organize our components aren't all entirely done, but that's more for historical reasons. But that's the kind of general approach we're trying to take of keeping a separation between the data and the UI as much as possible. So that way, if we need to migrate off Redux or React in the future, the coupling is not, there isn't too much coupling. Instead, there's a very clear interface where the two meet.
Yeah, I think like when structuring your apps, one of the best things to do is try to do it so that you can reuse just the data layer and change the UI later, or you can reuse just the UI and change the data layer, or also just reuse both of them together because maybe you have a new screen in your app and want to do that. And so just thinking about how to make that possible in the future is I think usually a good strategy for trying to figure out what things should be coupled and what ideally shouldn't be.
Yeah, I've recently started refactoring some tech debt in an app that is a Redux. It's a new app, so I don't even know why it's that technically debted. But it has, we use like Redux. Yay, Redux. And so we have our connect and dispatch methods that were kind of deeply coupled with our components in like one component. And recently we extracted out all the containers so that if at any point we decide to dump Redux and start using something else, our components never have to be touched. We just pass in the data exactly as we'd expect it to be. And so now like we're just keeping things a little bit more atomic and dry. I don't know about long livability. Like it's the web, right? Like we'll rebuild it in 3 weeks anyway, or 3 months. Doesn't matter.
In Angular 3, right? Yeah, that's so.
Like related to that, when we moved off what we were using before Redux, one of the things that we ended up doing, thanks to the way that Redux was kind of put together, was to try and create we basically every one of our containers has a function called connect, and that connect is itself like a module that has the map state to props and match dispatch to props. So we can test them in isolation. But even that seemed like a good thing, but the next level or the next stage that we're trying to go through, I think, is to move a lot of the logic that is in these connect functions back into Redux. So we get data that comes in from an API request. We have stuff like tweets and users, and tweets have tweets within them and users within them. So we try and break all of that up and have a single instance of every tweet and every user in the app. And so the Redux layer is taking these API responses or something that handles it before it gets to the Redux layer and kind of sending the users to the users reducer, sending the tweets to the tweets reducer. And at the moment, a lot of our containers end up having to reconstitute those objects, like thinking about, oh, I've got a tweet, but it's only got IDs to users, so I better go and fetch these users or select them from the store. And so we're trying to move that back into Redux via selectors. So if I select a tweet, then it comes down fully hydrated, and that makes this like thin layer of the React Redux code, which is just connecting the Redux store to our components, like very, very thin. Like to some extent, they almost look like declarations of data dependencies. So that's kind of part of the process of trying to keep all of the state management and the way that that's stored and exported in one layer, which is the Redux layer, and then having the containers be as thin as is practical of a connection between the two.
So that's really interesting. So you say you're trying to put it back in Redux, and maybe I just didn't catch this. Like, at what stage of the Redux lifecycle are you marrying those two data points back together?
Well, so an example would be if you see the Redux examples, you'll see a container, and it will do something like it will do state.tweets.users, and it knows the shape of the data that's in Redux. And so every time we change that shape, we have to go through every single container that might be accessing that data and checking that it's not broken. So we end up having tests for the containers that leak implementation details about the shape of the Redux state into those tests, because they have to know how to construct the mock store They have to know where the data is. And so if we can move that into these Redux modules that we have, then the selector is what's responsible for that. And so we can test the result of a selector in the Redux layer, which is the place where it knows about its own state, because that's kind of like part of the implementation of your reducer, right? So by kind of keeping the construction of the data and like kind of merging it all back together. So if I request a tweet or a user, I just get the tweet or the user, and I don't have to know all of those details. That's kind of where we're going to, in order to support the kind of pattern that Ben was talking about, which is the ability to reuse the data layer. So someone could access Twitter data and fetch Twitter data, but not necessarily know how we store it or any of the optimizations that we do behind the scenes.
So I think that's really interesting because that's kind of the approach we took when we built our reusable component library. We built a lot of our components at AdRoll, which was the previous job that I was at, which was sort of agnostic of any of the data layer. And the idea was to build these components so that they could be ported into applications that were actually using any type of data management framework, so Redux being one, Flux, Fluxor, and Backbone even, gasp, putting our React components in our Backbone views. And so I'm also, this kind of leads towards perhaps kind of a tangent, but I'm really curious how everyone feels about stateless components. Because something that we found was that you kind of leave the state up to the application when it comes to data, but in terms of interaction, I've seen kind of blog posts all over the map of where do you keep your interaction state in your components. And where we landed on that was that you want to keep interaction state inside of the component as long as it deals with the behavior specific to that component. I've seen blog posts that kind of mix the two, where you want to keep sort of, for example, say you have like a select drop-down with a hover trigger, but you want to keep the hover trigger interaction state inside that component, but the currently selected option is actually kept in the application layer state. And I wonder sort of where people fall on sort of the stateless versus stateful components and what kind of state to keep where.
Good question. I'm personally, I mix them, you know, like if I need a stateless component, I'll use stateless. If possible, I will use stateless components. Like it's the easiest platform to make sure that like I can test from beginning to end exactly what I want to be rendered on the page. We've also started recently writing tests where we test, we make sure that the state hasn't been mutated by the child components. So, like, if possible, I will push that state as high up as I can without like adding any additional tech. So I yield to stateless components as much as possible, and then like you keep it really dry.
Yeah, I'm a big fan of stateless components, and that's, stateless functional components, I guess we call them. And, well, I mean, you also have the class-based ones that might just not use state. But, we see React as like, you want your view appearance to just be a function of your input data as much as possible. And I think the class syntax actually distracts from that a little bit, and some people are like, oh, like React is this object-oriented thing, and it's really not that. And so we like the function syntax because I think it makes a lot clearer what the goal is of just mapping your props to your render output. But then at the same time, component state is often useful for a lot of stuff. Like if you have, especially just like UI component state, if you have a dropdown, whether it's open or not, is something that probably belongs in React application state. And when you read Twitter and Hacker News, you see all these blog posts about like how I made a completely stateless React app by extracting all of the state into a Redux store or whatever else. And like I don't see that as a goal because I mean, your app is still stateful. It's just the state is stored somewhere else. And like we added state to React components because it is a generally useful thing. And so I think people are overall a little bit too scared to use state, at least in the like Twitter HN community. Sometimes people also try to avoid state because maybe it lets you do time travel debugging, or it lets you serialize the whole state tree of your app or something like that. And in those cases, I think those are valid use cases, and we should just find ways to support that inside of React itself and make the React state tree more introspectable and that sort of thing.
Dude, the time travel thing though, that is sick AF.
A
Like,
plus.
yeah. I like taking somebody else's complete state and putting it in my instance and saying, oh, I see exactly user error that you did.
So I have a question for all of you. It seems like so far the panel has more or less everyone has discussed Redux at this point, so I think like we're kind of on the same page that Redux is kind of the favorite flavor of the UX thing. I don't even know where to go with that. When do you introduce like a tool like Redux or MobX or Flux into your application? Like, is it right away? Is it like I'm making a brand new app, I have Redux right away, or is it like halfway into it? Is it like way down the road when you realize you have too much data tunneling? When does that happen for you?
I mean, like, when do you buy mayonnaise? Do you buy mayonnaise because maybe 6 months from now you'll make a sandwich, or do you buy mayonnaise today because you're going to make a sandwich? You buy it. You buy it when you need it. No, like that's what I feel like with Redux and with anything else. Like, you're not going to introduce modals to your app unless you need a modal. So why introduce Redux until it's time for you to have like complex state management? In my opinion.
I'm going to go back to technical debt for a second. I think it depends on who you are. I happen to be hyper-organized, type A. Things are where they need to be, color-coordinated, blah, blah, blah. I think what's interesting about that question is, and the mayonnaise question is, I don't know about you guys, but I haven't been in the industry that long, but I've been in it long enough to know you're going to need the mayonnaise at some point. So it's always, I know that we talk about technical debt a lot, and we also talk about over-engineering, and some people say it's over-engineering to start, incorporating Redux or Flux when you're just trying to get Hello World to print on your page. But I've seen it enough times to know that that data layer is going to become useful probably a month from now, and you're going to kick yourself saying, why didn't I put in Redux? Where is my mayonnaise? So, I mean, that's kind of where I fall on that, but I also like to organize things a lot, so maybe I do over-engineer a bit at the beginning with too many folders and too many frameworks, but that's where I stand.
Yeah, I mean, I think, well, if you're working at a place like Twitter or Facebook, it's pretty likely that you're going to want something to help manage the data. And even if your app is relatively small, doing something familiar that you'd see across many apps would be probably a benefit. So yeah, I don't know. We don't really, I mean, I guess, yeah, if you're building smaller apps, then you wouldn't need to. But like I said, anything that I think has more than a few people working on it at some point, you're probably consuming or storing a bunch of data. So yeah, we'd use that to store app state. But in terms of the like component state, yeah, I was thinking about it a bit like how, so like React kind of flipped things around a bit and said, you know what, like the HTML or your template is actually coupled to the your logic or whatever else is in your components, and it was like about not separating or keeping everything together that's part of the same responsibility. And I think the state is a bit like that as well. Like, some things just stand alone and they need to be their own little state machine, and moving all of that up to some top level is only going to make things more complicated, harder to understand. In the same way, when you split all your HTML and JavaScript and CSS up, you have to start kind of chasing a single feature throughout all these disparate parts of your application. And so I think there's a place for both, I think, is what we would say.
Yeah, I think the key is, if you're not familiar with Redux, then you probably shouldn't sit down and say, I'm building a new app, and I need to use Redux because I heard that's the best thing to use. And you should at least first start by just doing the simplest thing, using built-in component state, using whatever you want to manage your state, and then when it starts to be a pain point, at least then you understand the problems that you're trying to solve. And so if you're building your second or fifth or 10th app and you are super familiar with Redux, then maybe it makes sense to start using that right away. But I think there's a big risk of getting turned away just because now you need to learn about components, but also reducers and stores and actions and all these other things. When maybe you don't actually need that, and you certainly don't need it on day one. And so, you use what's comfortable, I think.
I think Devin and I agree, but I also don't understand your analogy because I hate mayonnaise.
I mean mustard. I meant mustard.
Mustard.
No, mustard stays good for a long time.
Buy immediately
Butter.
the mustard.
No, milk. Milk.
Milk?
Because it'll go bad.
Well, I mean, is it all? I'm just kidding. Anyway. But I err more on the side of like introducing it much later into the app development cycle. React states are pretty robust and really, like I find it very understandable to understand like the life cycle of a React component. And one of my favorite features of React is like I look at a component on the page, I see a bug going on, and I just know that it's going to be in that React component, right? It's going to be there somewhere where that state's getting messed up, and it all lives in one file. It's very easy to track down, and you know, once you introduce Redux, then there's like where you keep your reducers, and there's where you keep like the instantiation of the Redux store, and there's just more surface area for those bugs to crop up in. And so as much as possible, I try and keep away from introducing these data stores until it actually becomes like a necessity, right? Like once I have multiple disparate apps reading from the same data, and I'm having to put it up at the root component of my React tree, at that point I was like, okay, I have this huge problem that I have to send, you know, this needs movies, this needs movies, this needs movies, and this needs movies, right? Like 5 different things reading from the same React state. At that point I'm like, okay, fine, I'll put in some goddamn reducers. But until then, I prefer to keep it pretty clean. Implying that your methods are dirty.
I think like one of the, like when I think about like how our team tries to think through problems, like rather than talking about, you know, should we be doing this or that, like we know that everything is going to change, you know, at some point in time. Like even just the last year, it feels like we're just constantly refactoring, sometimes like as we go, or sometimes because we have to do something. And I think that we just have been gravitating more and more towards patterns that allow us to test things more easily and to accommodate change, which is really what, when I was talking earlier about trying to define these boundaries and try to make the connections between stuff like data and presentational components as kind of clear as possible and have as little leaking between the layers as is practical. This is mainly in service of allowing us to change things again in the future. So I think if you're thinking about how do I write my application, then as long as, whether you're using like component state and you know firing your own API request from within like component did mount or something, like as long as you're thinking about how you write your code in a way that keeps things, you know, that aspect of things separate from the presentational part as much as possible, then you can easily kind of like upgrade or you know adopt these like systems to help you manage the data. But yeah, if you're writing spaghetti code, which is fine as well. I mean, we all do that when we're like putting something together or hacking it together. But really having patterns that are understandable and are kind of relatively consistent, so that way you can like modify whole patterns across your application. I think that's kind of a good way to approach, you know, whatever you're doing, whether it's a React app or not.
No, I totally agree with that. And I think some of the way you can mitigate that with just React as opposed to moving that into reducers is the higher order components themselves marshal that data, munge the data, and that they themselves become testable. Whether that's a higher order component or just a separate module that has some pure functions that data goes in one, you know, and it's munge data comes out the other end, right? There's a couple ways to manage that, but I think reducers are a great way to manage that as well. So I will delay buying your mustard. What's your favorite way of handling like asynchrony in React? Is that reactive? Is that promises? Is that thunks? I don't know. What's your favorite flavor to pair with React?
I mean, everybody's like, you got it. Promises are the way. I recently, so I opened up like a Twitter shitstorm about how to do HTTP requests with Redux, and like a lot of people had a lot of opinions about that. And at the end of the day, I ended up going with Axios. Have you guys used Axios? It's
the best.
Yeah, Axios is really great. So yeah, we use promises and we use Axios to handle the proxy.
Yeah, we have a promise-based like API as well. Yeah.
Promises are really nice. There's one thing that they're not great at, which is being canceled. You know, if you send off a network request and you get back a promise for the result, for the response, then all you can do is call .then on it, or .catch, I guess. But there's no way to say like, oh, I'm actually switching to another page. You should cancel that network request now. And I think there's been like a little bit of talk of adding something like that to promises, but right now it's nothing final. And so I think that's probably a significant weakness because if you do send off some network requests and then you leave the page, then you don't want to have to receive the network request and then even like call whatever handler you had already attached to it that processes your data, and because you don't care about it anymore. And so promises take some of the control out of your hands with scheduling. And actually, like if you look at the implementations of some of these libraries where you do care a lot about scheduling, like we have this library Relay for data fetching and data management, and they for some things they expose a promise-based API, but actually internally inside the library they don't use promises because they want more control over exactly when each callback gets called and canceling things and scheduling things and for high and low priority updates. And so, but I agree that most of the time promises are really nice, and especially with async await, the new syntax, which I believe reached stage 4 this week at the TC39 JavaScript committee, which means it's like basically final. So I'm excited to see that in all browsers soon.
Yeah, I saw that too. That's exciting. I do have like personal projects. I mean, Apple would never do this. Have promised like spaghetti code, like 27 nested deep, and I just have no idea where I'm at any given moment. And I just, like, looking at it gives me anxiety attacks a little bit, but I can't escape it now because I'm in a promised land or something. I don't know.
So I'm gonna plug RX because I work at Netflix, right? Woo! Ben's down there. You can quiz him next. If you desire that level of granularity, but you like that promise-based flow, RX is an interesting choice for you, because you just unsubscribe, right? And then it's done. You don't have to worry about things like cancel tokens or anything like that for promises. Like, promises are great for very, very simple use cases. Like, I made a request. I want to listen, and I want to pass around this promise so that I can .then all over the place, right? But once you move into like that more, like you want granular control, like you were talking about, I think RX really nicely fits that use case. Use RxJS. So that we touched on this a little bit. Speaking specifically of Redux, what's your favorite side effect library for Redux? Is that like Redux Thunks, Redux Saga? Do any of you have any opinions about that? No. Okay.
I have not used any of them.
I mean, I can tell you what we use.
What do you use?
We use Redux Thunk, yeah. I don't know, like, when we try and think about like how much boilerplate there is, or whatever, something that's called boilerplate, but it's just like a bunch of code that looks the same as code that exists elsewhere. Like, I think back to something that like Seb, one of the core authors of like working on React at the moment, and his thing about like when to introduce new abstractions. And in the last year of kind of rewriting Twitter from scratch, the number of well-intentioned abstractions that we've had to spend a considerable amount of time undoing, things that maybe got in the way of testing, or that simply once you introduced a new use case, they kind of fell apart. So yeah, stuff like having a bit more code to deal with API requests and using Redux Thunk, like, we're not really having any problems really at the moment with it, other than maybe the first time you write it, it feels like there's a bit of repetition. But certainly trying to make it easier for people who periodically contribute to our apps rather than being part of like core platform teams. Like, making it so you don't have too many layers of abstraction or too many functions that you have to kind of step through, and transforms that you have to understand is something that we try and keep in mind as well. So
I like that. It's like the principle of least power, right? Like, that serves your use case, and to move something like Saga is just like overkill. Like, if you have something that Saga calls for, I think that's really awesome. But keeping it simple so that it's approachable code, I think that's wise.
yeah, and it's not just approachable code. It's also just like accepting that as engineers working on Twitter, we're not entirely aware of all the problems that we're going to have to solve. So even we looked at some of the like async libraries where you just kind of have like one action creator and it kind of wraps everything up. And in fact, like someone like Katie who works down there, she was really like working on a huge amount of the migration that we did over to Redux, and just kind of like acutely aware of like all the special cases to do with like our API, or I don't know, unexpected things that we want to do to work around problems that we face or introduce new features. And yeah, so kind of not trying to add too many layers on top of Redux too quickly, just because we saw ourselves like kind of copy pasting a bunch of stuff was a decision that we made, and so far I don't think it's been too bad.
Yeah, my coworker really, coworker Sebastian really likes saying no abstraction is better than the wrong abstraction. That like it's okay to have some copy pasted code because you don't know really what all the similarities are and what makes sense to extract and what doesn't. And I think people really like to say dry, don't repeat yourself. And I think that's like actually harmful in a lot of cases because you look and you're like, oh, I see this pattern, and then you extract something out, but then you have 3 things that look the same, and then you add a 4th thing that's like sort of the same, and you're like, oh, I realized that what I extracted out does not actually serve the 4th use case, and then you just need to undo, your work to abstract it, and then figure out the new abstraction you need, instead of just sort of leaving a little duplication, and then it's a lot easier to change things. And so like my roommates last week were talking about like, can we come up with a good acronym for the letters WET? And the best we came up with, I think, was write everything twice.
That's awesome. So what frustrations do you currently have with the React ecosystem? This is the part where we shit all over React, sorry.
Well, okay, I'll start. So, people, if you read the comments, like the biggest complaint people have had by far is just that like there's too many different pieces you need to get started with React.
React Quick Create. The Create app is great. Dan's Create app is out of sight.
It's true. So I'll get there in a sec. So, it's really funny because everybody says like, oh, you need Webpack, you need Babel, you need to set up a test runner and like a bundle system and like a server and everything. But if you look at the official tutorial on our website, it literally says like, take this one HTML file that has 2 script tags, and then you just add the React code there, and it works. And like it really does work, but somehow nobody believes us that that's actually a viable way to use React. And with React, it was built at Facebook. It was built and designed to be able to integrate with this existing website that we had, and so we really weren't prescriptive about exactly which build system you have, or whatever packager you want to use. But those things are good overall, I think. Like most people do want to use Webpack or Browserify for any sizable app, and so there is a lot of truth to the complaints that it was really hard to get set up. But then, yeah, two weeks ago, Dan Abramov and Christopher Shadow, both two of my coworkers at Facebook, it was a hackathon, and they just like sat down and built this thing called Create React App. I don't know if any of you have seen it, where it's like 3 commands. You like install it, and then it's like create React app, and then the name of the app, and then you can just do npm start. And that's like all you need to do, and so we're hoping that this will get people started a lot quicker.
Yeah, I've used it a couple times already in the last couple weeks, and like when I'm sending out things, because like I like to do a little bit of teaching for the children, for the children. Like when you'll tell them, okay, follow the tutorial and include the 2 lines at the top, and then like they'll be like they'll Google something and they'll find a Stack Overflow and it's all in ES6 syntax, and then they'll copy and paste it into their source code, and they'll be like, why doesn't this work? And I'll be like, oh, well, there's this thing, it's called Babel, there's like transpilers. Anyway, so this way they can run the commands and get it up and running, and then start copying and pasting the same code that they find all over the internet. I like it. I think it's awesome. There's boilerplates all over the web. I've plugged a bunch of them over the last couple of years, and like, this is the fastest way to get started.
Well,
I don't remember the question.
We're supposed to be shitting all over React, and this is not going very well.
CSS.
Oh, that's a great question. So
Yeah.
Do any of you use like, what is it, Athena, is that what it's called?
Aphrodite.
Aphrodite. I'm getting my goddesses mixed up. Or like the Radium or any of those.
We're using CSS modules, and like it's fine. It's I mean, I like it. It's cool.
A strong endorsement.
It's fine. I don't know. Like I don't have a wish list. I can't tell you exactly why I hate it, but I do. I hate writing CSS in React, and I feel like over the last 2.5 years, like there have been 100 different recommendations of things to do, and you know, Christopher has recommended like a lot. Like some people align with like the inline CSS, and some people do CSS modules, and then Aphrodite and. It sucks that there's so many different ways to do it and that nobody's really like significantly advocating like this is the way that we should style our React components. But it's fun to play with different things, right? Like job security.
Well, like going back briefly to the ecosystem stuff, like I think like we spend, or like when I say we, I mean like our team and probably most of the people working at Twitter who are working on React apps. We spend a lot of time like thinking about what our requirements are or like what kind of constraints we have. So we happen to be working on a mobile web app. So we think about things like, should we drop React Router because it's quite big? We think about, you know, could we switch out Webpack for something that could do some more intelligent bundle splitting for us? Yeah, we think about, you know, switching out the data layer. And so although I know that there's obviously benefit to being able to use something like, you know, like Ember's kind of really cohesive, like everything's integrated for you kind of setup, and there are going to be times when that probably is really useful. For us, at this stage in the React, kind of whatever's going on in the React world, it's even if it requires more work, it means that we can kind of tune things a bit for what we're trying to achieve. And I think that's kind of the things we quite like about React, or I do certainly, is it feels like it's quite a hackable platform. And although it's just, you know, React is a small part of the overall app. It kind of affords us, yeah, like a surface area for quite a few different approaches. So going back to the CSS, like we also use CSS modules, and it's been okay. There's still a couple of times when we have to do stuff
It's
like.
also okay. Yeah. It's fine and it's okay.
There's a couple of files where we have to do something like import one component in a special order to make sure that the CSS that it loads comes in first. Another one that we're trying to debug at the moment was some styles just got dropped from the production app and we couldn't work out why, and it turns out that something in the CSS pipeline inserted a semicolon before a class like selector. And so those things are like really not fun to debug. And we just kind of, like working with CSS in this way, there's like just like a black box or some kind of line where there's a lot of hard work that you have to do to get variables kind of shared between the JavaScript and the CSS, or to be able to manipulate values more effectively. So moving more and more of that into JavaScript is one of my personal kind of, I don't know, things that I'm doing at the moment. And the area that I'm exploring this in is more like working to bring the React Native Style Sheet API to web. So although most of the JavaScript and CSS things for the web have focused on how do we keep like pseudo classes, pseudo selectors, media queries, kind of like that adds a lot of complexity and really limits what you can possibly do. So I've been quite happy just thinking about, all right, there's not really going to be, you're not going to be able to do a hover state in CSS. You're not going to use a pseudo element. You're going to use a real node. And you're not going to use media queries in a component because it sort of doesn't make sense because it's a component. It's not your viewport. So these are the justifications I use for this approach. But certainly, like yeah, CSS is definitely probably the thing that with the web ecosystem in React, it really limits the ability to share UI components between projects or in open source. Because you get, yeah, I mean, you end up with either you have to use the same styling library or you have to use Webpack and you have to use the special plugins that the library author requires you to use to build the CSS that's included in the source code. And yeah, moving all of that into JavaScript just feels like the React thing to do.
Yeah, one of the earlier presenters today said that CSS is like you're riding a bike, except the bike is on fire and everything's on fire. And
because you're in hell, right?
Because you're in hell. And so, you know, there is some truth to that in that with CSS, I think, at least the way that I used to write CSS, it's very hard to tell what CSS is going to be applied when you're reading the source code of some component or some HTML. And it's also, if you're looking at a style sheet, it's very hard to tell if a rule is even used or where it's used. And then also you get things like what Nicholas saw, where if you include the style sheets in a different order, then your page looks totally different. And so CSS does have a bunch of problems for building large apps especially. And so I think the styles in JavaScript movement is trying to solve a lot of those things. Aphrodite is written by one of my roommates and works great. And you know, I hear great things about it. At Facebook, we're not actually yet doing very much styles in JavaScript outside of React Native, but probably later this year we're going to do some serious work into doing that at Facebook, and then maybe we'll standardize on something within React itself, so that maybe we have more of a level playing field in the ecosystem instead of these 30 libraries.
The way we've chosen to do it thus far, at least on my team at Netflix, is write CSS that you can just throw away. And people look at me strangely when I say that, and it's really just because we write tons of things get A/B tested, so we write a lot of code that doesn't actually really stay in production very long. And so you either end up with a lot of dead CSS, or you write a bunch of CSS that you're able to just strip out pieces of the style sheet. And so we don't have anything like Aphrodite or Radium or anything like that. We just use less, and we have these style sheets that we can statically analyze to say, here's stuff we can throw away. And so far, it's always fun to throw away code, and that's one of my favorite things to do.
It is. I love those git commits when it's more red than green. I'm like,
Yeah.
yes.
Yeah,
So
definitely.
one of the things about moving the CSS into JavaScript is there's just things that are fundamentally different that you can do. So when I've been working on this React Native style sheet thing and talking to Christopher, one of the things I've understood is they've slightly tweaked the way CSS works. So the order of precedence is the most specific style wins rather than the order. So if I say, border color left, it doesn't matter if later on there's border color set, because the left is more specific. So you can use these kind of rules, which are much more predictable, in order to give authors an expectation of what the style is going to be. And then furthermore, when you reduce everything down to class names, so you write something with some abstraction that you get out of maybe something like Aphrodite, if it ever turns into a string before you're finished kind of working out what you want to do, you can't control what other styles someone else is going to pass through, because it's just a string and it could carry any number of styles. Whereas when you're working with a JavaScript object, your component can basically filter out all the style props that you don't want to support. So say I have something that's meant to be a box and it's meant to be 50 pixels wide and 50 pixels tall. You're not going to be able to set the height, because I'm just going to filter off your props that try and set the height. So that kind of control over the style interface is exactly what you'd expect with the props interface that you normally get. And so, yeah, moving away from strings that kind of have all this, you can't introspect those strings and find out what styles are attached to them. And so it's just one more reason why, moving into JavaScript, ignoring any potential performance issues, is just more powerful, gives you more control, gives you more predictability of what the output's going to be.
So my unfounded fear with moving all that to the JS layer is I fear I'm going to have these super long component files that half of its styles, and I don't enjoy CSS. Maybe I'm alone in admitting that that's part of my job that I really kind of dread doing, and so I like to just mentally compartmentalize that to another file.
We also have, on our team, we have an incredible luxury of having this incredibly talented CSS developer that does nothing but designs, does amazing UX and writes amazing CSS, not CS, whatever. And she does not want to touch the React code. So keeping it over here at a place where she's comfortable, not accidentally introducing a semicolon or something along those lines, is way better for us.
What does she think about working at Netflix? Just off the record.
I don't think she's into it.
Oh, okay. I was just checking.
Yeah, I think I'm kind of coming around to the CSS and JS movement as well. In our reusable component library, we kept everything separate, and at Netflix we do that as well. We have sort of like a corresponding CSS file for every component. But in an ecosystem where we're doing a lot of A/B testing, and so there's a lot of experimentation in the UI with styles and interactions, you have to be really, really well disciplined for it to work. And in building our reusable component library, you also had to be really well disciplined for it to work. So we did a lot of namespacing, but that gets really unmanageable very quickly, and that doesn't work all the time. You still have applications using your components that are finding that one class and overriding it in their style sheet with a bang important. So it doesn't solve the problem just by separating the files, and so coming around to the CSS and JSX movement or JS movement is, I think we're going to get there soon. Right, Ben?
I think so. That's our goal. So, I think it was you, Nicholas, who mentioned performance. We want to make sure that it doesn't regress performance, and that's actually one of the reasons that we're planning to do some of these next investigations on the Facebook site itself, because we have lots of good monitoring, we have lots of good tooling around that. So hopefully we can prove out something, make sure that it does have performance parity with what we have right now, but then we definitely want to bring it to everyone. Yeah, I think it's just a better way to write components and completely eliminates a lot of classes of bugs, and also makes sense if you're not already exposed to CSS. Even if you talk to any mobile developer, they don't have this weird style sheet where you can specify, these descendant chains. You just specify what you want each thing to look like, and I think it makes a lot of sense for us to do that on the web too.
Yeah, you can still break it out into a separate file. It's just a JavaScript module in the end. But it reminds me a lot of, if you look at basically every JavaScript framework now, you'll have an on-click property and you'll assign a handler to it. And it's, back in the day when that was on a DOM node, that was never do that. And I think the styles is the same thing. It's kind of like the inline style, there were lots of reasons that it was frowned upon that weren't about, how convenient or how clear it was, setting your styles that way. So I think having a node, there's an on-click handler, having a node, there's a style tag, and you can just read one line and see what is being applied to it, and then go and find out what those styles are, or functions. I think that kind of clarity is really useful. And when I was doing a little kind of proof of concept port last year of switching our styles over to JavaScript, the bit that I found the hardest was trying to work out what our existing styles were doing. So if there's some style being applied to an element that's also kind of coupled to the root node or some other node, then I have to understand a couple, 2 or 3 things I have to hold in my head in order to understand why something looks the way it does, or why it's not looking the way it's meant to. And I think so. Yeah, shifting everything towards that same philosophy of reappropriating some of the kind of original web, authoring patterns, but with these frameworks and these abstractions on top, they can be optimized behind the scenes.
Cool. I think that's all the time we have. Does anyone have any closing thoughts?
I have some vintage React stickers from the first React Conf. They're vintage. They're 1.5 years old. They smell fresh. If anyone wants.
Cool. Thanks for coming, and yeah, thanks to all the panelists.
All right, hey everybody. We're gonna jump right into our last panel. Just wanted to remind everybody that we have an after party going on immediately after this panel on the lower level, the social hall. And so there's a local nonprofit, Queens of the Castro, that's gonna be selling drink tickets. So please support them by buying drink tickets. All the money that you give them goes to their charity, which is 501c3. And they're also going to be doing a drag performance. And since they're teachers in San Francisco high schools, I'm sure that their drag performance is going to be really something. And now, as a way of introduction, Brian Lonsdorf put together this panel. And so this isn't the first time I've said this, but before we all go see drag queens, ladies and gentlemen, Brian Lonsdorf.
Hello. Hi. You guys must be so tired right now. How many hours have you been watching people talk? I want to keep it fun. Like, let's keep this fun. Everybody, you want me to start beatboxing and you do a little like rap introduction?
Drop the beat, Brian.
No, we're not.
Yo.
I was thinking more 90s, less. All right, Wiz Khalifa. What's up? So I know everybody's tired and there's a party right after this. So we might do this for 15 minutes or 20. Just when we get bored, we'll stop talking. We can go drink. So let's introduce our panelists. Oh, let me talk about what we're going to do first, right? And then we'll do introductions, and then we'll talk about it. I think that's a good idea. So this panel's on code trade-offs. Like every time you make a decision in code, you may or may not be cognizant of the benefits and drawbacks of that decision. So I think too often times people are going for aesthetics without really understanding the repercussions of their code decisions. So we're here with some experts to help you understand those decisions or tell us some really sad tales about our own decisions. So here's, Ben, you want to introduce yourself and we'll just go down.
All right, I'm Ben Lesh. I work at Netflix on the UI platform team, and I'm also kind of the lead author of RxJS 5.
Yeah.
I'm Richard Feldman. I wrote Seamless Immutable on the JS side. Any fans? No? All right.
Woo.
But I'm really into Elm now. I'm writing this book, Elm in Action from Manning. It's actually available for early access, and there's a discount code today for this conference. If you go to Manning Books on Twitter, they have a code and it applies to that book. I work at NoRed Inc., and we're hiring.
Cool. I'm Amy Lee. I work at Salesforce on a prototyping team for the user experience group. So we do all kinds of really cool stuff. Yeah.
Oh no, is it?
Hello.
Oh,
There it goes. Thanks. I'm Rachel Myers. I'm the founder of Absolutely, which you probably haven't heard of. It is the best way for dev teams to ship software. And before that, I was making very different trade-offs at GitHub, and before that at ModCloth.
All right. Yeah, so these are industry veterans that have been coding for a long time. I know it because I invited them. So let's start with our first question. Let me just try to think of a trade-off that I make often, and I think it's dear to my heart, abstraction. So when you're writing code, how far do you take your abstraction? Well, let's just say with a function, right? Do I make each line a separate function, or do I inline everything? Go. Anybody?
Always inline everything. John Carmack taught me. No.
What are the benefits and drawbacks, I suppose, of inlining and abstracting, even to class levels, you know? Does anybody have thoughts?
I mean, you can, abstractions come at the cost usually of performance, right? So if you were to write your app as one giant function, which you could do, it'd be crazy, but you could do that with some apps. Your app might be very fast if you do that. However, you're going to have a very hard to maintain app because then when you go to alter it in some way, you're going to end up pulling apart spaghetti.
Not me. I'm good at that. I can do it.
So the one unique thing is working on RxJS. I work in a library that's an abstraction for async, right? And I think that because I'm in a position where I'm viewed as being like a guru or someone that's really all about RxJS, frequently when I'm talking to people, they're like, oh yeah, so the first thing I do is I put RxJS in my app. And you don't need to do that. Start off with just a callback, and then maybe a promise if you are using a library that returns a promise, and then add RxJS, because it's going to add some performance overhead by adding that abstraction, and also some mental overhead too. So I think that that's where you have to kind of draw the line, is to decide what's worth keeping simplicity about versus do I need to add this abstraction yet?
So I was only half kidding about the John Carmack joke. So John Carmack actually wrote a really good piece on this, on inlining versus not, and performance is one of the considerations. But some of the interesting points that I thought he made were included, how does it feel to read through the code and try and figure out what it's doing? So one upside of pulling out functions is, each individual function gets smaller, so if you're trying to figure out what does this chunk of code do, that's an easier question to answer. But when you're stepping through some long sequence of things to try to figure out where a bug is, having it in all sorts of different places in your code base actually makes that more difficult. So even if you take performance out of the equation and the sort of abstract notion of abstraction as a positive thing, there is just this practical question of, I need to hunt down this bug. What does it feel like to go through the process of doing that? So my default is to just inline it and then pull things out when I have a reason to. So if I have a need to reuse some logic, I'll pull it out. If I have a need to test some piece of logic in isolation from something else, I'll pull it out. But by default, I think just preserving that experience of, I need to step through and see what this does, just default to inlining it, and then if it feels like it's getting unwieldy or you have one of those use cases, then pull it out.
To build on that, I would say your question was probably a troll question, because there's not a right answer for that one.
I fell for it.
So
All
there's
of these are, right?
what the right level of abstraction is. There's no such thing, right? What the right level of abstraction is depends on every code base, depends on the team, how familiar you are with that code base, depends on how familiar you are with that language or technology. All these things play into how abstract do you understand your code to be, right?
Right, so what happens if some of the readers of your code aren't programmers? What do you do?
I
How
would
much
say
to
less
abstract?
abstraction if they're less familiar with it.
And so we've generally kind of taken this approach, we use React a lot, so we kind of do the Yagni approach. You ain't gonna need it. You're not gonna need to abstract it all. We try to keep dry as much as possible, but when we're dealing with designers, often it's you just keep things like JSX, and you try to remove as many of the options as possible until the designers are done with their code. And then you take the code and you make it pretty, you make it better, you make it functional, but you wait until the last moment, and then you take control of it.
I think everyone here kind of touched on one thing that is interesting about adding abstraction, is that if you're going to add abstraction, you have to be prepared to properly name and organize your abstractions, right? That's part of the challenge to doing that, because you could go through and add the greatest abstraction ever, and if people can't get through your code and find these things, then you're going to have a problem, even if it is better structured or better architected.
Right, and that's I think they say abstraction, is that you can solve anything in computer science with one more level of abstraction. And it's our tool to use, but it can get unwieldy pretty fast. And if you're not really, really careful and staying on the same levels, you're jumping from 10 different functions to others, where this one workflow should have been on that same level.
So if I can solve anything, do you think then what I really need to do is write a method that names all of my abstractions and organizes them for me?
There's a name generator. 8-ball, you just shake it, and it tells you the name of your method.
I think we're onto something.
Yeah, I think
it's a SHA, like CSS modules. All of your functions are just hex code.
Right. Well, let's just keep with this troll thing going, and let's talk about constraints, maybe type systems. So, how do you feel the benefits and drawbacks of constraints in your code? A lot of people say the more constraints you have, it makes it simpler to reason about and follow your code path, and there's less possibilities. But then you can't actually do some things because you're constrained. Does anybody have thoughts on constraints?
I have an initial response, and I'm interested to hear how people respond to this. So I'm from the Ruby world, where we have no constraints. In fact, constraints are looked on with hostility. I was trying to describe, someone asked, how do you add an element to an array in Ruby? And I said, there are 8 different ways. Let me tell you all of them, which is obnoxious, but I did. And I've recently started writing in Python, and it is the exact opposite. How do you do anything in the world? There's one way. There's one right way to do everything, and it's so much simpler. It's like I've switched my way of thinking entirely.
So I have some fondness for this topic. So here are some facts. In Elm, the entire programming language, everything is immutable. There are no side effects anywhere. There are only constants. There are no reassigning variables. There's no mutable state at all. We've been using it in production for about a year at NoRed Inc. We spend almost all of our time on the front-end team writing Elm code. In that year, so we're now at about 35,000 lines of Elm code. We have not had one single runtime exception in production in any of our Elm code. And it's because of constraints. It's because the compiler is really good at checking and identifying problems and catching them before they can reach our end users. And so I can draw a very direct line from those constraints leading to that benefit, and also like an unbelievably nice refactoring experience because the compiler catches all the stupid mistakes we make before they can reach our end users. But yeah, I think it kind of, to the question of trade-offs, I don't think I can just generalize that. Like a lot of people like to draw a line in the sand and say, type checked is better or dynamic is better, but if I were to order my 10 favorite programming languages, they're not sorted that way. It's like Elm is number 1, but number 2 is not Java. I was a professional Java developer for years. Java's pretty far down below several dynamic languages like Ruby that I like better.
So number 2 actually says not Java. That's your second favorite language.
Yeah. No, honestly, I mean, it's it really is kind of all over the map in my top 10. It's really, it really depends a lot on the UX of the language. And what I love about Elm is that the way that it presents those constraints is in an incredibly user-friendly, pleasant-to-use way. And I haven't found that in other places yet. Maybe they're out there and I don't know about them, but I think it matters a lot.
So I have a slightly different perspective on this. When you think about constraints work really well for code bases that are being developed as the end user app. Constraints are actually enabled by abstractions over constraintless things, right? People don't really think about that much, but a lot of the constraints that exist in things like Elm or whatever exist because someone had a slightly more constraintless thing that they wrote Elm on top of. In RxJS, we started using TypeScript, and TypeScript was great because it added some constraints and it helped me find a lot of bugs. However, because I'm writing a library that other people want to use in JavaScript, which has fewer constraints, sometimes I run into issues where I need higher kinded typing or something like that, and that doesn't exist in TypeScript. So you kind of run a risk. It really depends on at which level of what type of application or code base you're writing, I think. It would be very, very hard to write something like Elm maybe in a highly constrained language because you might have a hard time getting the right performance out of it or other features.
Yeah, I agree with that.
The way I look at constraints is more about code clarity, like what you intended things to actually do. So whether they are highly constrained or whether you just have really good style guides, I think both you end up kind of with the same effect, although obviously, a compiler catching your errors early, that saves you tons of headaches.
Word.
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 Can we get a word?
Are we doing the rap thing? I don't know. I wasn't sure.
I don't know what that was, actually, no. Well, actually, that leads into the next question, though, or next subject that I'm just going to throw at you. So with, you kind of touched on this, modularity, right? So if you have a function that does everything for you, you just give it something and it just works, versus a bunch of pieces you assemble yourself, and now you have a lot more flexibility, right? So you have, modularity has a lot of benefits and drawbacks to it in itself. Does anybody have thoughts? Oh, I got a text. I'm gonna look at that text.
I love
supposed
modularity.
to silence that, man.
Yeah, I'm just gonna silence it. Hold on, I'm silencing it. No, she's out there though. Hi, Mom. Oh, there she is.
Modularity or composability?
Let's talk about modularity as far as a collection of pieces that allow you to compose, but flexibility in general versus the rigid, this function is taking care of it for you.
So one of the thoughts I have about modularity is that frequently people will build things to be modular. And maybe they're doing it with some architectural decision like MVC, right? That's a really, really common and popular, maybe becoming less popular.
I've been pronouncing it MVC this whole time.
They're using Muvik.
It's the internet, you know.
The,
you read
the
it.
Mivik paradigm. Because my boss told me Mivik was great. And what ends up happening is, conceptually you're like, oh, well, this module is standalone, and this module is standalone, and this module, and I can just replace them, and they don't really have to know about each other. And in practice, that never really happens. Like, you end up with this controller that knows, exactly what to call in some service and knows exactly how to scrub some pieces of data out just right so the view knows what to do with it. And it's all totally married to each other, but you've I don't know, kind of given them APIs so they can sort of adapt to one another. It's kind of I don't want to call it like the myth of modularity, because modularity is still good. It's still great to be able to pull in modules and consume them. But frequently when you're looking at like a smaller, more granular, I'm building an app and I'm going to architect it in such and such a way and make these little modules, it's very, very hard to see the ways in which those things are intertwined.
Yeah, I agree. And I also think that it's one of the most underestimated skills to have. It's like something that I thought I was really good at for a long time until I talked to people who were much better at it than I am, and then I realized how awful I'd been at it the whole time and kind of didn't realize how many of my own problems were self-inflicted by drawing the lines in the wrong place. And I think, so Rich Hickey had this great talk, Simple Made Easy, several years ago now. And it's great. I highly recommend it if no one's seen it. But basically, one of the things he talks about is coupling and how you can have two things where even though they're not technically calling one another, they're still coupled from a design perspective. Like if you change the design of one, you need to change the design of the other, or else they're not going to work well together anymore. And that gets right to that question of, with modularity, where do you draw the lines? Where do you say this module ends and this module begins? And having these implicit dependencies is a very easy thing to do, where you draw lines that are kind of a lie. Like they're kind of true, but they're also kind of a lie because they give you a false sense of security. And figuring out how to design things in a way where you've drawn the lines in a place that feels nice to use, but is not a lie and is still accurately representative of what's going on, I've found is actually way harder than it seems, and something worth working on it. And I wish there were more teaching materials out there on just here are ways to identify patterns where this can lead you astray.
Yeah. I don't want to say it comes down to experience, but was anybody in that talk on the Upper Lodge about particle systems? And somewhere near, I think it was pull request number 15. It totally broke down the individual things you can do, like translations on scale, translations on position, translations with gravity. Those are all things where it kind of made sense to draw those magic lines and say this particular function does one very discrete thing. Or there's some times where things are just a little more complex, but they all kind of relate to each other, and one's acting as a controller, and then just calling little bits of functionality. I think modularity sometimes becomes more clear when you have concise naming patterns, because then it's just kind of something like adapter. Then you know that anything that's kind of an adapter, maybe it goes in a particular folder, or maybe you have hierarchy, or naming structures, or your microservices named on certain domains. So sometimes organization just kind of falls out of just how you think about the system and how you name everything.
I have nothing to add. I think modularity is great if you can do it well. So next troll, please.
And let's start with you afterwards, because I feel like we just say everything and it gets down to Rachel. She's like, what? Thanks. Should we do 2 more questions? Is everybody ready to drink after this?
Yeah,
Show
look
your
at
hands.
Yes.
All right, let's do like two more.
I actually didn't see that many hands.
So this one, yeah, I actually didn't. All right, let's keep going all night. Who wants to go all night? All right, wow, interesting. All right, let's do it. So Rachel, this one's for you. I just totally lost my train of thought. 'Cause I was talking about
You
drinking.
have one job.
Yeah, I know. Oh, generic code, interfaces. So interfaces and generic code, they have a lot of benefits, right? And some drawbacks. And, what are your thoughts on that? Python trader. Just kidding.
Okay, what do you mean by generic code?
So you write something to an interface, not an implementation. And that interface has a generic set of methods that you can now implement many different objects with. So yes, that's what I mean by generic interfaces.
Gotcha. Okay, so that seems like a wonderful pattern to use. I feel like it has to be coupled with pulling out the right abstractions, like we talked about before. I think if you're doing that too much, then you probably haven't pulled out the right abstractions. And then I'd also want to I feel like my answer to every single question you'll ask is it depends, right? I'm not going to have this here's the right answer to any of these questions.
That's in the spirit, right?
It is the nature of this panel. There are no right answers. But I think ultimately, whether or not you have an interface that you find easy to use, that feels intuitive, and that is easy to call wherever you need to call it is that's the goal, and how you implement that is your challenge as the programmer.
Right. Anybody else? Interfaces?
Dangerous.
Right.
So Ben Alpert was on stage before this, and his intro resonated with me because he talked about React came out and he saw it on Hacker News. He's like, this is awesome, and he got into it, and I did too, although I went in a different direction. But another thing that he said that really resonated with me was he talked about a quote from one of his coworkers at Facebook, which is I'm going to make sure I get this right. No abstraction is better than the wrong abstraction. And the example that he gave was if you say you have three things and they have something in common. You're like, oh, let's make a common interface between them. And then it turns out you find a fourth thing pretty soon after that doesn't quite fit the interface. Now you're in trouble because either you need to roll back what you did and redesign the interface, or you need to say, well, maybe we actually can't have an interface at all between these. And so it's very easy to get excited about a pattern and say, oh, I see the commonality here. Let me make an interface, and now this is generic, and this will be great, and this will scale, linearly for all time. And then the very next example you come across is like, oh no, I need to undo all that. I actually just made a bunch more work for myself. So I think it's one of those things where it doesn't seem dangerous. It doesn't seem error prone or like it might be a trap. But I think actually you should treat them by default with skepticism and say okay, I can see what this might do for me as n approaches infinity, but I only have 3 examples. Is it really time to make this, generic and reusable for all time? Or maybe should I just be okay, let's wait until this is actually solving a concrete pain point for me?
Okay, can I push back a little bit? So I understand your point that it might lead you to a false place. You might have false beliefs about your objects based on an interface, right? Is that a fair summary?
I don't know if it's false beliefs based on your objects, more just if you think you've got an interface that is you're ready to say, this is our interface and let's use that as the interface for these things, then it's easy to do that prematurely and it doesn't seem like as much of a trap as I think it is in practice.
Okay, so the other side, the trade-off to that, is that if it's a shorthand that makes it easier for programmers to think about what kind of thing this is. Oh, this is a widget that takes A, B, and C, right? And I can always think of widgets that take A, B, and C. Then that's great, and I can go faster, right? And if that helps me, then that might be the great thing. And so you come across something that takes A, B, and D, for example, then I don't know. Then that I see how it could be dangerous, but I bet A, B, and C will get me pretty far.
Yeah, so that's actually a great example. So this is good. We've got a discussion now.
Fight.
Panel success. So I would draw a distinction between the example you gave, which is kind of like you got like a public-facing API where you're like, I expect other programmers to come to me and try to fit the interface that I've created, versus when you have your own code and you're sort of refactoring it to try and create that where it's not actually necessarily solving a problem yet, but rather something where you're hoping it will prevent future problems. So to clarify my point, I guess, because I didn't think to express it in those terms until you said that, but I think the danger of it is not so much designing a public-facing API that's wrong, because I mean, really, if you're going to make a public-facing API, you have to pick an interface, but rather taking something that's internal that does not necessarily need to have an interface set in stone, as opposed to just saying, oh, I observe that we've got a couple of functions that look similar. Creating one in an effort to solve future problems can potentially introduce future problems instead.
So what do you guys think about protocols or traits?
I call it interface, protocol, traits. I call them about the same thing, right? Type classes. You want to get crazy.
I've been doing a little more like iOS programming lately. So like the thing of actually adding protocols to things, it's a way of kind of like extending your class, like almost like a mixin, but it's an interface. So like if you suddenly find that you need like something that's like you had A, B, and C, then you need D, you can just add a new protocol to that one specific instance. So you don't have to extend every single class that like as if you modified the parent object of some like very large class hierarchy, then you just add it for just the surgical application of what you needed for that one class.
Right, like a Band-Aid or, no, I'm just kidding.
Not like a Band-Aid. It's
I'm
like
just being a jerk.
that one class is special, it's better.
No, and that's a good way. It's open for extension, closed for recompilation, open, closed, or whatever. And I think it's supposedly attacking the expression problem in that way, but I think it was proven wrong that you can actually solve it in that way. And I'm not going to go into it because I don't know what I'm talking about.
So I think that a lot of us use JavaScript, so the open for extension thing is just kind of like wide open, right? It's not a duck, so you just punch it until it's a duck. That's.
Is that how that works?
Yeah.
Is that how you say that?
Have you seen me at the pier at all? It's a pelican, Ben. Stop that.
I've seen you.
It's got to be a duck, yeah.
I've just been my little binoculars. I work at the ferry building almost, so I'm there. See. But yeah, I mean, you work with RX, and that is built on like these interfaces almost, right? It has this, it's working with streams and observables, and they kind of plug together because of the interfaces.
Right, yeah, so one of the advantages if you can come up with a good generic interface that fits a lot of things, like in observables. So observables can represent any number of values, 0 to infinity, over any amount of time, like instant, could be synchronous, could be asynchronous. So what can that represent? Well, basically pretty much everything. So that means that you've got this sameness to the shape of anything that you could have. Like it could be a list of names, it could be a list of numbers, could be a single item, it could be nothing at all, but you've got the same shapedness that you can leverage. At the same time, that basically also means you can write code that myself and 5 other people on the earth can understand, where it's just like your whole app is just like one big observable with like many, many nested and merged observables underneath. So actually, a similarity to that, I think, is, say, like the design of Lisp, right? Like Lisp, as a language, they've given you this interface where it's like, okay, you've got a parenthesis, you've got a command, and then you've got arguments after it. And that's the interface to Lisp. And that enables you to do some really crazy stuff. However, people coming from Java, ECMAScript-based languages are going to look at it and be like, this is a lot of parentheses. I don't know what's happening here. But it's the same sort of idea. I think, in Lisp, it's probably more successful than it is in RX and in observables. Obviously, it's a language, and RX is arguably a domain-specific language. But there is an advantage. If you can come up with I think the key is finding an interface that's very simple, that can meet a wide number of needs. And that actually is really hard to do because you sacrifice some specificity when you do that. So,
right on. I think we should do one more and just kind of like go down the line, just to kind of close this panel up. And I think this one is really just about, do you have any, like, everything you do in code has benefits and drawbacks, right? Do you have any, like, ironclad driving principles that you will not stray from? Or is it always a situational basis? I think everybody should just mention a little bit about maybe their principles that they just kind of guide them, or if they don't have any. Anarchy.
I have no principles.
I mean, what is your morals?
So I can start by saying I used to have principles, and I no longer do.
Yes.
One of my principles used to be always have unit tests, always have great testing. That would free me up to make sweeping changes. It would free me up to to really experiment and like create the best possible code base. And then it makes it really easy to onboard new people. And then I started a company, and integration tests are totally good enough. It's fine.
Maybe that's domain specific?
A true story about unit tests versus integration tests is I was working on RX one time, and I added this battery of unit tests, and I was like, this is great. I've got everything so tested now. And in order to do that, I had to be able to have some dependency injection a little bit into whatever this class was that I was working on. So I had 100% code coverage and all these unit tests. And then what ended up happening is I actually broke the functionality. Like I tested each little piece of it, but I never tested the whole thing together. So since that day, and I had been warned by like old men that had beards and staffs, like they were like, unit tests be the devil, Ben, you should know. And I never believed them. And then since that day, I've been more integration test heavy. So that's my story about that. I get choked up about it.
Just do a just snapshot and walk away. Drop.
I think both have their value. I mean, I like unit tests when especially testing single pieces of functionality, single function, like math functions, or like testing AJAX calls where it's easy to like mock out something later, but nothing, like you have to do integration tests, like especially like with an actual human sometimes. I guess that's more of an acceptance test.
I think that it's like this. You can take all the parts of a car. You can test your tires. You can test your motor. You can test a transmission, all in isolation, right? And then you walk. You never actually step away from it. You're very focused on this, and then you put the curtain over top of the car, and you walk away, and you're like, okay, go ahead and get in this and drive it to your friend. And they take the keys and they go and they sit in the car, and they're like, well, Ben, I don't think this is going to work. The wheels aren't actually attached anymore. You forgot to put the engine back in, and I have nowhere to put this key. But you've tested all of those parts. It's just not actually wired up together anymore. And that's why the integration test to me is so important now. It's usually I reach for that first, and I usually go for the unit test second now. But I was totally the opposite before this horrifying experience.
But if it's in the shape of a duck, that'd be awesome.
Yeah, just punch that
Callback
sucker.
joke.
So, Richard, do you have guiding principles?
I think the only one that I have is put user experience first. Like, if I have something where, oh, thanks. Everybody else disagrees, like, implicitly. But like a lot of the times, you'll find something you're like, my code will be so elegant if I just do this one thing, and then like, okay, people are gonna be pissed off that this doesn't work, but my code is going to be so nice. It's such a tempting thing to do, but like, I have to have a rule for myself because I value clean code, I value elegant code, but I have to remember that the reason we're doing all this is for the end user. And so at the end of the day, if you have to do something that feels like a dirty hack, but it's going to give the end user the best experience, and they're not going to realize that your code got uglier, do it. It's the right thing to do.
Right. That's a good principle, is that there's some ominous like user out there that's just going to be upset with you at any given time. And that's the driving. Ben, did you already go through principles, or was it just the test?
No, I just had the rant about the test thing.
Yeah.
I think that if I were going to say I had a principle, it would be to question any idea that I had about, like, if I think that I'm right, and I really, really think that I'm right, that makes me worry a little bit.
That's beautiful.
If I'm mostly sure I'm right, I'm more confident. But if I'm 100% sure I'm right, then that does worry me. So I think it's important to question your decisions, especially decisions you made like about something you're about to work on or about to do.
Right. Yeah, I think that's beautiful. Being certain in code and on the internet, everyone. It's not a good thing. Amy, how about you? Any principles to leave us with before we close this off?
Never write the same thing twice. It has saved me in every single programming language I've ever worked in. Unless there's some really good reason, like it just makes life easier for the end user, yeah, dry, all the way dry.
Right on. And that, that just reminded me, I think the quote about the abstraction, the wrong abstraction is worse than inline or whatever, I always hear that attributed to Sandy Metz. And I don't know if anybody's watching that, that might be who said that. Anyway, so I think that's it. Thank you, everybody. This is great. Let's go booze.